All right, everybody, welcome to the start of a wonderful OKD deployment marathon. We've got a number of folks from the OKD, which is the OpenShift's community distribution of Red Hat's OpenShift, and we are going to try today to demo on as many platforms as we can coerce our members into doing so all day long. If you don't know OKD, you can pop over to the OKD.io website and read all about it. We've been working diligently on it and have recently just done our GA release for OKD4, and it is out there in the wild, and that's what we're going to be demoing today. So to kick us off, we decided to start with AWS and the cheapest AWS cluster possible, and a full AWS deployment to follow on that by and Christian Glombeck, who is the co-chair of the working group, is going to set us up and show off the first bits here. And we're going to drive through today, putting a general surgeon's warning on the day. It will be fluid because these demos are live, and we may sneak in a few more in between things if people go short. And we're going to try and do the Q&A during the cluster up, while the clusters are booting up, because there is a lag and there's really not much to see on the screen. So if you're watching, you can ask questions in the chat wherever you are, whether you're in one of the live streams or in the Blue Jeans itself. At about 3 o'clock, the live streams will end, and we will try and move everybody over to Blue Jeans at that time as well, but and continue going because we have a number of folks in the UAE and in Australia who are getting up early for us. And it'll be tomorrow for them when they start doing their demos. So we're going to accommodate them. All of the demos we do today will be recorded and uploaded to our YouTube channel, so you can digest them at your leisure. So without any further ado, I'm going to let Christian take over the screen here and share his screen and walk us through the cheapest AWS deployment we could figure out. And here he is back. So I'm going to share your screen. I'm not seeing your screen yet. There we go.
Does it work? Okay, perfect. So can you see it all right? Is it big enough?
It is big enough, and I'm going to take my video off and let you rock and roll.
Okay, so in order to get a minimal install going, we really just have to change a few parts of the install config. So usually what you do is OpenShift install create install config. I've already prepared that, so I'm not going to run it again. This is where you're going to be asked for essentially your AWS or your account credentials and where you want to install. This is the installer provision infrastructure. Instead, I'm going to just show you what, after the install config YAML is created with that command, you just go ahead and edit it a little bit. So what we're going to do here is the number of worker replicas is scaled down to 0, and the master replicas are just 1 now. I've also changed the type of the AWS node to M5X large, just to be sure we get that. We need quite a bit of RAM still for the install, so 12 gigabits for installing, and then when it's running, it's going to be 6. You could additionally also put in a smaller node for worker nodes if you want to scale up worker nodes right now. As we're just going to install the one master cluster, right now, this is kind of it. So after the OpenShift install create install config, we're gonna do OpenShift install create manifest. And after that, we can go ahead. You can actually, if you don't want to edit anything and just take the defaults, it's not going to be the smallest cluster, cheapest one. You would just do this command right off the bat. Because we've wanted to edit the install config, I had to do them in sequence here. But create cluster will also, if there's no install config and no manifests present, it'll create them. So OpenShift install create cluster, we can start now. So really what I've done is just scale down the replicas, to the master node, the control plane nodes to 1 and no worker nodes at all. Then I think what I forgot here, because I had to change laptops, I should have also put the ingress controller on the master node. So we're probably not going to have ingress right now. I'm just noticing. So usually you have to change the label as well for the ingress controller to run on the. Usually it runs on the infra nodes, which is scheduled on a worker. I should have changed that to master. Anyways, let's see where we get here with this. So that's an additional step for the ingress controller to change the label to point to master. Well, and yeah, now we have to wait a little bit. The install is running. So I think you can go back to this. Dan, is this already the time for Q&A now? I cannot hear you.
Had myself muted, so you couldn't hear my coffee pot percolating, because we're going to need a lot of coffee today, I think. What someone was asking what the O stands for in OKD, and I think that's it's interesting. The O stands for nothing, and when we shifted from Kubernetes to Kubernetes from the older version of OpenShift, which was a Ruby on Rails MongoDB platform as a service, and we shifted over to being on Kubernetes, we had to rename the project to be more in line with other other Kubernetes distributions, and legal, marketing, and trademark issues made us have to use a 3-letter acronym, much like EKS or OCP and other acronyms that are out there for Kubernetes distributions. So the O actually doesn't stand for anything, not even origin. I like to joke that it stands for OK, Diane, because everybody agrees with me on that. But it took a lot to figure out that acronym, and that's where we have our OKD Panda and everything else. So a technical question for you. Nurla is asking, do we need to generate ignition files for the install?
So I'm gonna take this. So this is what the installer does for you. In the second step I just ran, the OpenShift install create manifests. It'll generate all the ignition files within machine config, Kubernetes objects. But then if you run it step by step, you still have the opportunity to change those. If you do want to provide your custom ignition, then you can edit the generated or add to the generated ignition config that is output by the create manifests. There is also the question, curious if install could be done with spot instances. Yes, I think you can. You can, because I don't install any worker nodes right now. If I had changed that to the spot instance type for the worker nodes, I could later scale up workers that would be spot instances. So that is possible as well. I'm not sure how that would work on a master node, to be honest, but it's definitely possible with workers.
All right, and there was one other one, and this is the question that everybody always asks. Were those steps documented anywhere yet?
So we have a draft document right now, and there's a bit of documentation floating around as well. This was originally done by Vadim Rudkovs, who can't be here today. So I will definitely, together with him, submit a document to the OKD repository, so we'll have that properly documented as well. Maybe just to note, this is really just for testing purposes. It's not an HA cluster. You won't be able to upgrade easily because the etcd quorum will not be kept. So yeah, we'll still document it, but it's not. It's just a testing setup for if you want to really do some a cheap test on AWS here. Not supported for any workloads really.
And Lee Schwank is asking, is there a comparison chart table of the capabilities of OKD, OCP, and OKE? And not.
What is OKE again?
It is the OpenShift Kubernetes engine. I think that's what that one is supposed to stand for. And it is another variation of the product that is simply the Kubernetes pieces of it that you can get support for and all that. And I will look for that on the corporate website. I have not seen that, and I have not prepared one on that side yet, or been asked to before. So I will see if I can find one that's at least an OCP and OKE and share that with the group shortly. I think there is an OKE versus OCP one, but I'm not sure about OKD, and there shouldn't be too much difference between OCP and OKD except for, and maybe you want to talk a little bit about Fedora CoreOS.
Yeah, sure, I can do that. So that's actually the main difference. I'm not sure what the difference between OCP and OKE here is in particular, but OCP and OKD, they're essentially the same cluster code. The only real difference we have is we use Fedora CoreOS instead of RHEL CoreOS as a base operating system. We manage the operating system updates the same way we do through the cluster. So there is no, it's one life cycle, the cluster and the base operating system. So if you update OKD or OCP, you'll also get an OS update. So the boots will the nodes will automatically pull down the new image, lay it onto disk and reboot into that, obviously in a safe fashion, one after the other. So if there's any blockers, one node doesn't come up or something, the update will fail. But yeah, we have this, the CoreOS technology, which is essentially today a fusion of RPM OS tree and Ignition. RPM OS tree is our image-based operating system, essentially, or the creation tool for it. So you can compose an operating system image with that, and it's going to be immutable, and you can update it. I think Colin Walters, the creator of RPM OS tree, likes to say it's like a Git for OSs. So you really have a commit hash that represents your on-disk state, and then you can upgrade from one to the next atomically. And we do that through the cluster, and in the case of OKD, we do it on the base of Fedora CoreOS, which you can also use standalone. So Fedora CoreOS ships Docker and ships Podman engines. So if you just want to run single container, single node workloads in containers, then that's the right operating system for you. It's really geared towards running containerized workloads. Yeah, and even Fedora CoreOS and RHEL CoreOS aren't that different. It's just the package sets they use. One is the Fedora package set, and the other one is the RHEL package set. So it's mostly the same packages, just different versions, a different kernel. You get the RHEL kernel in RHEL CoreOS, you get the Fedora kernel in Fedora CoreOS, and yeah, but mostly it's the same tech running there.
And in about 2 hours, I think, at 1500 UTC, our third demoer will be Dusty Mabe, who is sharing the Fedora CoreOS and helping do the community management for that. And he's going to demo OKD on DigitalOcean. And so if you have more questions about Fedora CoreOS, we can pepper Dusty at 1500 UTC, so in 2 hours time too. So if you want a deeper dive, then come back and join us for that. All right, how is your deployment going?
It is running still. So the Bootstrap API is up by now, and now I can share my screen for a second here, if that helps, just to let you see what's going on.
And Ashraf, you were asking about Azure. Azure is one of our second to last presentation today. So we will have a demo of deploying on Azure. The only one that we had to cancel was GCP, and that was only because Vadim wasn't coming, and it's not much different than the AWS one.
Can you see my screen again?
I can indeed.
Okay, perfect. So this is what you're going to see when you run the create cluster command. It's just going to take a while. So first we have to wait for the Bootstrap node, the Kubernetes API on the Bootstrap to come up. That has happened now, and now we're bootstrapping, and that may take up to 40 minutes. Usually it doesn't take that long. But yeah, we're about halfway through, I think. Yeah.
There you go.
Quickly go back here.
There's one more question, and these are great questions, everybody, because after this, we're going to grab all of the questions and turn them into FAQs. So you're helping us develop our FAQ for OKD. And one of the questions was, can I convert an OKD cluster to an OCP cluster?
So yeah, that's definitely a thing we want to do, and it should already be possible, really, if you force an upgrade to the OCP release. So I've never tried that, but it should be technically possible. We want to actually test that in CI at some point to make that a good story. But yeah, it should work, but nobody's tested it so far, I think. I also just pasted a link in the chat, which is our working document here for the cheaper AWS cluster for the one single node. There's also a few more tricks in there, like running the infra on the master node, and also setting up spot instances for workers.
Now, one other thing I would add is, if you're interested in this, because as you can see, this is a working group, and we work. If you'd like to join the working group, I've just put the link to groupsgoogle.com for the OKD working group, or you can go to okd.io and find the link there. But if you have questions that we don't answer, or you want to work on maybe a migration path from OKD to OCP with us, we would love to have you come. Christian, are we actually hosting a call tomorrow? A working group call?
I think so, yeah.
I think so.
I think there's a call on tomorrow. Yeah,
there is one. I know it's Kubecon week, but we did not cancel because the work never ends, and we'd love you to join and help out. So please feel free to sign up for that mailing list and that group. And that's a good place.
I'll also quickly paste the link for the FedoCal, for the Fedora calendar, where we have our OKD meeting. So please also join the Google group, but this is a calendar you can also subscribe to, and we'll have all of our meetings on there. Frank had another question. Do you need a pull secret to deploy OKD? No, you don't. You do need a fake pull secret, though. You can read that in the OKD README here, and it's really just a JSON struct with like a fake application in it, because we're very close to the cluster code, to the OCP code, also in the installer. The installer is actually the only part right now that isn't exactly upstream, so we've had to fork it a little bit. We're gonna re-merge those soon, I hope. And it's not too different anyways. But that is one of the things we didn't want to pull out entirely, because it's definitely necessary for the OCP product. And for OKD, we don't really need it, but we haven't found a super nice solution to dealing with that. So if you don't have a pull secret and don't want to create one, with Red Hat, you can use a fake one. And then you won't be reporting telemetry data to Red Hat. If you use a Red Hat pull secret, then you'll be providing telemetry data that collects it.
Which would be awesome, because we would love the OKDs to have some OKD-ness show up in that as well. So just personally, I'd love to see that show up on some of that. But it's because one of the things with an open source project, there is no gatekeeping on OKD at all. So we know there's a ton of deployments out there. There's a lot of interest in it, but other than the working group and people asking us questions in either the Slack channel or on different tech support things, we don't really know a lot about how OKD is used in the wild. And so later I'll share a survey, and if you are using OKD or planning to, I will have you fill that survey out, and I'll share that with all the videos as well. The other thing someone had asked about was the release cycle, the difference between OCP's release cycle and OKD's release cycle. You want to talk a little bit about that?
Yeah, sure. So we don't adhere to the OCP release cycle at all, really. We just kind of wait for OCP to become stable to go to the next minor version, like the switch from 4.5 to 4.6. We'll be doing at the same time as OCP. We won't be going ahead and using the master before OCP hasn't tested it out enough to say it's stable as well. But we do releases roughly every 2 weeks from the current stable branch, which is 4.5. And we do that in a way where we do that in the alternating weeks in which Fedora CoreOS does its releases. So they do bi-weekly releases as well. And then we kind of have a 1 week soak period to see whether the new Fedora CoreOS works well. And then we'll 1 week after that, we'll release the new OKD on top of that new Fedora CoreOS. So roughly 2 weeks. It's roughly 2 weeks for Fedora CoreOS, so it's also roughly 2 weeks for OKD.
All right. So this is, and here's one more that's just come in. With the default cluster monitoring in 3.11, there is no way to modify the alert rules within Prometheus. Is this something that will be possible in 4. Releases?
I am not an expert on the monitoring side, so I don't know the answer to that question, unfortunately.
I will find someone who can answer that for you, Steve. And so if you want to hang out for a little bit, do you know that answer, Charo, by any chance?
I can venture an uneducated answer. The solution in the 3 dot was to provision an additional monitoring infrastructure for your applications. What was provisioned with the cluster was intended to be cluster specific, and so it was never meant to be modifiable. In 4 dot, I believe it's a similar situation, but there's an operator for that. And that you can you can provision additional rules within the configuration of that operator. I know when you stand up a 4.x out of the box, you can start creating additional alerting rules. I don't know if you can create them for applications or if it's still infrastructure specific. But there is an operator that you can deploy that will enable that. And with that said, I'm prepared to be wrong.
Thanks, Charo. And Charo is one of our long-standing working group members, and he is a new Red Hatter. So welcome to the fold, Charo. Happy to have you.
I'll be playing the newbie card for at least a month, maybe 2.
Maybe 2. I'll let you get away with 2, except you've been deploying OpenShift for a long time, so I'm not sure you can do that much. And he's actually gotten OKD running with Che. So if we get some spare cycles today, I may make him demo that as well. So watch out for that. So let's see. Pepin is asking. There's a GitHub issue he's referring to in the chat.
So I think that is just the fake pull secret that you can use. It's the you essentially need a JSON with the auths field and then just anything in it, like at least one called fake here. It could be any name, and then another with another field with an auth field in it, and then anything in there. It's not going to be checked.
You can call it fake news or something. I'll be fine. So how's your cluster up going?
So it's still running. It hasn't reported back to me. It still says waiting up to 40 minutes for bootstrapping to complete. So as soon as that changes, I will definitely let you know.
Okay. So, well, we'll fill the time, and this is going to be the interesting thing the whole day, is because basically I told everybody to try and do live deployments, and so filling that time while we're waiting for OpenShift and OKD to do their thing will be interesting. So if you have more questions, please do ask them. In the interim, what we'll probably keep doing is I'll keep asking Christian and Charo, and unfortunately Vadim Breskov is not available to play with us today, but there's a lot of other folks on the line who will be coming on today with different levels of expertise on different platforms. But yeah, there you go, destroying Bootstrap resources. Staring at screens is what we do.
Which here again to put on the sound. So yeah, it's that usually happens when it's successful. So let's see whether we will have something soon to look into here.
So perhaps you can tell us a little bit, maybe, Christian, what you're working on now for the next release of OKD.
Oh yeah, sure. So for the next release of OKD, we will really have essentially we will converge much closer to OCP, or even closer to OCP. Right now, we still have 2 repositories forked in the, well, one in the payload you're running for 4.5. With the next version, 4.6, OCP will have moved to Ignition Spec 3, and OKD's been using Ignition Spec 3 for its entire time. So we're really closing a gap here with the machine config operator and also on the installer side. So we'll be much closer to the actual product essentially. OKD's been using Ignition Spec 3 all the time, as I said, and for OCP we were using Spec 2, and the migration had turned out a little bit finicky, so that took its time, but now we're finally able to just move everything to Spec 3. So yeah, that's going to be good. And it's also going to be less of an effort to maintain, I think, and that's introduced quite a few bugs we've seen in the past that because we didn't have this the rigorosity of checking on our forks is just not that big. But yeah, with that moving to be essentially exactly the same code, we're not going to have a problem there on the machine config operator side. And then I think we're not going to be able to merge the installers in the next version, but hopefully the one after that. And another thing we're going to focus on is really bringing all the operators from the operator hub, and all the operators that are supported on Red Hat, on OCP, bring a community version of those into OKD. Not by default, of course, but kind of have them in a operator hub catalog and have them installable on demand.
I think that'll be the next big community effort that we've been talking about in the working group meetings, is to review those, prioritize them, and start pecking away at that list of things. So there's a couple other questions coming in, and I know everybody keeps asking me for a comparison matrix between OKD, OCP, and OKE, and yes, we will get one somewhere. I think I saw one for OCP versus OKE, so I'm just repeating myself from earlier, and I will endeavor to see if I can pull that one out of somewhere in corporate marketing, but I haven't done one comparing OKD yet, and I'll get that on that. James is asking a question, which is probably going to get asked a lot today, is what's causing the slowdown in the, and what could be done to make the deployment faster?
Yeah, so that is a big issue, and because we're installing quite a lot, so it's not, OpenShift is not a minimal cluster per se. We have a lot of operators, just a lot of resources we apply to the cluster that help manage itself essentially, which makes it so stable. But it's also kind of big because of that, and just there is some. So yeah, this seems to be a problem right now with the. Well, it may actually still come up. It's going to try for some time now to grab the API. So yeah, we're working on that. It's a long-term goal within all of OpenShift, not just OKD, also the product. Yeah, but because we have the demand of really being secure and having a big feature set by default, yeah, it's not really super close by now to minimize that footprint. It's a long-term thing, and that is, yeah, that is, I think, what I can say to that.
There's one question, and I don't really know the answer to it personally. How and when does Red Hat engineering use OKD versus OCP in non-production or production, and right now? You're on the Red Hat engineering team. Is there any OKD use inside there other than testing?
I don't think we run any services on OKD right now. We do have something planned in collaboration with the Fedora community to have a cluster there. I mean, internally at Red Hat, there is we have our SRE team that manages our own clusters and the customer clusters that are managed, and those are all OCP. So I don't think we have that right now. But with the Fedora community, we will have at least one quite big cluster at some point in the future for things to test out. So I myself don't have a lot of ops experience, to be honest. I usually just develop and write the code. And then we have this great CI system that really tests out everything. But yeah, I think if there's, and especially with the plan to test these OKD to OCP upgrades, kind of upgrading into a subscription, we will maybe see more OKD usage within Red Hat as well.
So Paris is asking the question that everybody ever asks, as well as what is the status of OKD ready containers? And maybe that was kind of the inference with Charo's Che demo, but maybe Charo, if you've got some insights.
If the question was specific to code-ready containers, effectively for OKD, sort of the minimal single node cluster that you just download and run. I know there is work progressing toward that, but I don't know what the current state of it is. I actually I haven't looked in a while, but I know the Praveen, one of the leads on code-ready containers, was actually working on something so that the same thing would work with OKD.
Yeah, so we'll see if we can get a status out of Praveen, but what we've sort of the workaround has been this simple single cluster installs and some of the work that hopefully we'll get some time for Charo to talk about using Che with OKD. So let's see, we're gonna.
Yeah, I think just to add to that real quick, I think we've had a proof of concept for code-ready containers on the base of OKD. It's just not, I don't think it's really been decided by the team that actually does that to deliver that continuously. Maybe we should push on that a little bit as well. But because it is not that different, especially if you run it on a laptop, I know why I can see why people would want it. But for the CRC team, which has limited resources, I think it may be difficult to deliver on that right now. Even though, yeah, I think we should still follow up on that. It's not really a thing that exists right now. There has been one testing release, but it's not like they do that for all our releases.
Yeah.
We also have a proof of concept for actually upgrading a single node cluster as well, which has been one of the limitations, that if you download and run CRC, it effectively has a limited life, and you need to pull another image of it. But hopefully we'll be getting some progress on those things in the future, so that it feels more like the mini-shift experience that people were probably used to. But going back to the previous point about the enterprise class of OpenShift, we need to strip it down a bit more to get it to a mini-shift-like state. It comes with a lot of enterprise features that were left out of mini-shift.
Yeah, we do know that's a holy grail.
And they are all part of OKD, by the way, those features. We don't strip out anything for OKD.
So Mike Rochefort is asking, if the CRC lifespan stems from the cert renewals? And hi, Mike.
I think it stems from the fact that you cannot upgrade the single node cluster. So you'll just have an outdated version at some point, and you can't migrate to the next version with the way CRC is right now.
To see what other questions there might be here. Seeing any coming in. Mike also says he remembers early on a new image being pushed about every 30 days. Is that for CRC? I think for people to continue to use it, yeah. So
yeah, I think CRC tries to get one release out per OCP release right now. And they obviously don't do as many releases as we do. So yeah, having all of OKD's releases also done as CRC may be a little too much for that team. I don't think it's too big. But yeah, we should definitely get to a point where we can just get side-by-side releases of CRC based on OKD and OCP.
Right. All right, checking back in on that deployment. Is it going any faster now? Do we need to buy you new hardware?
Yeah, well, it's not running on my laptop, right? It's I'm just polling the API here, but it's not up yet. So yeah, let's hope it'll come up time. Still have around 20 minutes for it to finish, I guess, or even more. It said wait up to 40 minutes. So after that, it'll just cancel the thing. But yeah.
So Mike is asking sort of what the purpose is of today, and whether or not it's just a day-long prep for Kubecon. And we normally do an OpenShift Commons gathering the day before Kubecon, and because Kubecon changed its date so many times virtually, I decided that I wasn't going to try and keep up with them in scheduling, and because OKD did a GA release, then we will we decided that we were going to celebrate by forcing everybody on the working group to do a demo of their favorite platforms or whatever they had access to hardware or clouds to do for a day-long thing. One, to capture some of the videos and the how-to bits of it for our website and for our YouTube playlists, but also really to give a little bit more, build a little bit more awareness of OKD out there in the universe. It's not the most well-known Kubernetes distribution at the moment, but hopefully we'll get there. Though OpenShift is pretty damn popular these days. So, and someone's asking, you should have used a more powerful AWS flavor. It would not have been cheap, you're right, but that is going to be the next demo, which Christian's going to do, which is going to go over again, which is why the whole day we say is very fluid. And
yeah, we can actually, I mean, it's not going to be that different because the only thing, I'll just leave out the editing of the install config, but other than that, it's really the same. So maybe we can drop it. I don't know. I can do it again, of course, but we'll have another half an hour wait period.
Let's get through the cheapest, and then maybe with the AWS one, you can just leave that running, and we'll come back to it sometime after Charo starts. But and that will be a good way to segue into what Charo is going to do next.
That sounds great.
So we'll get one done, the cheapest, and that way, because in the working group we tend to have the open source folks who don't have the biggest budgets and or the most permission to use their hardware. But I think the goal is to give someone lots of alternatives and ways of doing things. Let's see, how about if you share your screen one more time, and let's see where you're at.
So it's still just polling the API to see whether it comes up. It'll do that for up to 40 minutes, or actually 30 minutes at this stage. And this is, yeah, it has bootstrapped, and now it's just waiting for the one control plane node we have to come up. That'll do a few reboots because it'll pull down the current or the Fedora CoreOS version we've referenced here in our payload, and pivot into, it's called pivoting with the way we do it. It's the RPM-OS tree image will be, or the RPM-OS tree commit will be delivered to the cluster, to the node in a container, and then we have a binary, the machine config daemon, which has a command pivot, and that'll unpack that RPM-OS tree commit from the container, put it onto disk, and reboot into it. And this is, yeah, this can take a little while. So we have, yeah, I don't think although we're getting close to the 30 minutes now, but yeah, soon it'll either say it failed or timed out, then it'll roll, then it'll destroy the resources here, or it'll say success and give me the domain to log into. So unfortunately, not a lot to see while this is going on. It's just trying to, yeah, get onto the API.
So in terms of faster deployments, how does this compare to like a vanilla Kubernetes? Like, how have you tried? I'm just curious here because I know there's a lot of extras in OpenShift.
So yeah, I mean, it's only one-time thing, the install, right? When you scale up nodes, after that, that is much quicker. But our rollout, our initial install does take longer than just a vanilla Kubernetes. I think, yeah, that may be up in about, I don't know, maybe 10 minutes, and we're, taking half an hour, 40 minutes for it. So we do have a lot of space for improvement here. That is, and it's definitely a thing our customers for the product also want. It's just because it's only once at the very beginning, it is not that super important. But obviously, it is a little bit annoying, especially if you do presentations like this, waiting that long. And yeah, we're on it.
And Mike is making a great suggestion. The installer needs to be more exciting and engaging. And I think someone should take up the challenge of doing an ASCII version of the Panda and inserting it into the installer somewhere. That's, I think, that'll be the next one. Some ASCII art in there.
Yeah. And we're here.
Woohoo! Patience pays off.
So yeah. And let's see how this turns out.
Drum roll.
So it is an HTTPS encrypted connection, but it is self-signed, so you'll have to accept this risk and continue. And ta-da, here we are. So this is our one node, minimal cluster, and yes, cluster has overcommitted CPU resource, requests for pod and cannot tolerate node failure. May have chosen an instance type a little bit too small, although yeah, it came up. Pretty happy this worked. Nice. So yeah, we have one node, as you can see. It's everything. It's master and worker at the same time, so you'll schedule your workloads on that as well. You probably won't be able to schedule a lot as it's already running. Yeah, running full a little bit, but yeah.
So can you, while we're here for a second, and just for a second, go into the operators and show which operators are running in this minimal configuration.
So yeah, we don't have any operators really installed from the operator hub, I think. Okay, yeah, we do have one, which is the operator lifecycle manager, which is actually the operator that manages the other operators from the operator hub. So we only install core operators. But even the core operators bring quite a big set of functionality here. I think in the future, the way we will minimize this is to split out a few more of those operators into operators on the operator hub, so they can kind of be installed on demand, but they aren't necessarily always included. Yeah, on the operator hub, these are the operators you can click and install. Not all of them are tested yet, or actually not many of them are tested yet, but this is kind of the next big endeavor of the working group, of the OKD working group, to ensure we have a broad set of operators here in the operator hub that run on OKD and are tested on OKD regularly.
And there's 2 more questions coming in, but I get to press the easy button.
That was easy.
There we go. That was our first demo. It ran and you got into OKD. Well done. A couple more questions, but well, if you want to destroy that and set up your other one, now that we've done that, the full one. Frank is asking, is there a link from which I can download the CA bundle for this cluster to import it into my browser?
The CA bundle for this cluster. So I don't understand, to be honest.
Yeah, that.
So you right. So you don't have to click the accept the risk and continue one. So you could use a CA that is signed by an authority that is accepted by the browsers, and then you wouldn't have that problem. As this is a self-signed one, you just have to trust it yourself. There is documentation about that in the OKD and OCP docs. So I will quickly stop sharing and set up my full environment here. We could actually
what he's looking for is probably that might be under the in the generated files from the installer. Might be somewhere under there. He could actually use to import into his browser, but yeah.
Yeah, I guess that is probably the case, that you have to change something in your install config or in the generated manifests.
All right then. And in 5 minutes or less, or maybe a little bit more, we could take a little bit of Charo's time. I'm going to try the AWS full-blown install, which we will not wait to come up because we know it's going to be faster. But and then we can come back to it.
All right, let me share my screen again. Can you see this?
Yet. Big black screen.
Just a big black screen?
You can see text.
Oh, you can. Okay. Could be just me. Oh, it's just me.
So do you see my console?
Yes, yeah, we see it.
You see it. I just don't. Go for it.
So this time, really, I'm just running one command here, OpenShift install create cluster right away. There's no install config prepared here. So it's going to include the two commands that I just ran separately, the create install config and create manifests. It'll do all that for you. So you just have to put in your SSH public key, the platform you want to install, the region, then you'll get a base domain that is your AWS account owns that essentially. And then you have to choose a cluster name. Let's just try OKD full. Do that. Now I have to go copy do we still have it in the chat, the fake auths thing? Let me try that. Here we go. Nice. Oh, did this not work? I have copied a space or something. Yeah, probably. Oh no, actually it is running. Okay, perfect. So yeah, and that's essentially all you have to do to start that install process.
Right now, okay, there you go. Perfect. Yeah, perfect.
And now we are at the same point again where we just have to wait, and we have time now to answer questions again.
All right. So why don't we do that? And Charo, I know you're up next with the bare metal, which always sounds to me like a heavy metal band kind of deployment. And I saw the guitars behind you, so it might be appropriate. If we pause now and let the AWS Lives thing go and let Charo queue up for his deployment and share his screen. So
All
thanks
right.
very much there, Christian, for hanging out with us, and I hope you can spend some more time today, because I'm sure we'll be repeating some of these questions.
Yeah, sure. I'll be here. I'll be here.
Cool, thanks.
All right. Do you see a whole bunch of open terminal windows?
I do, and I see your
Yes.
smiling face, and I'm going to turn my smiling face off. Why don't you introduce yourself and what you're going to demo now?
Okay. I'm Charo Groover. I am a new architect for Red Hat services here in the Southeast United
You have
States.
reached the Horizon audio conferencing system. After the
Uh-oh.
tone, enter your conference security code followed by the pound sign.
Let me
Somebody's
find out
phone.
who that is. Pause for a second, everyone, and we'll figure out who is doing something odd here with sound.
It's like it's Nerlip.
Nerlip.
Yes. Yeah, it's Nerlip here.
I'm looking for him, and I'm just muting him. There you go. All right, so start that again.
All right. Carrying on. Like Diane has said a couple of times, these are live demos, so we're fully expecting a Bill Gates moment. It might not be a blue screen, but we might see a stack trace of death and all kinds of other interruptions. But I'm Charo Groover. Like I said, I've been with Red Hat for 1 week, but I've been a consumer of Red Hat products, both upstream and subscription-based for most of my 20-year career in IT. So this is kind of the dream job that I never knew I always wanted. And today what I'm going to demonstrate for you guys is a deployment of a bare metal Kubernetes cluster using OKD. This is going to be simulated bare metal in that I'm actually using libvirt to run the machines so that you guys can actually see what's going on, right? Because it'd be hard to get you console views to bare metal machines in this current configuration. This is a user provision infrastructure deployment, so the installer is not going to be provisioning the machines for us. These machines are already provisioned. If you see in this terminal right here, I've given you sort of a verse list view of the machines that are currently provisioned. You can see we've got a bootstrap node that is not running. We've got 3 master nodes, and we will have 3 worker nodes. And throughout this install, I'm going to guide you through the process of deploying the cluster, first through the bootstrap process, and then we're going to add the 3 worker nodes to that cluster. Now, I'm using Virtual BMC, which is a tool that comes out of the OpenStack world to simulate the IPMI management of these virtual bare metal machines. And these machines are going to boot into iPXE, and using the MAC address of the machine as it boots, it's going to pull the appropriate iPXE boot configuration file that sets its kernel parameters, sets the Fedora CoreOS install URL, and the ignition file that it's going to use to start from. I'm using fixed IPs for this particular lab setup, so everything is already provisioned in DNS. And I'm using a Fedora CoreOS tool called FCCT to manipulate the ignition config files to inject the IP configuration into each of the hosts. I've got all of this written up in a little tutorial that I've got out in my GitHub page, which we can provide a link to. But without further ado, we'll go ahead and fire this thing up. So the first thing I'm going to do over here in the left terminal is I'm going to power on the bootstrap node. Now I'm going to attach to its console. And what we're going to watch here, it's going to do an iPXE boot. It's a chained boot, so it first pulls just a boot.ipixie file is what's being served up by the DHCP server for it to pull from TFTP. That then chains it to look for a file that is named after its MAC address. It pulls that file. You see it got its kernel and its initial RAM disk. The kernel parameters that were passed to it gave it its instructions for installing Fedora CoreOS. And you can see right now it's actually pulling that FCOS image across. Now, we've got an HA proxy load balancer. It's this guy right here, OKD4 LBO1, that is already running and is configured to sit in front of this new cluster as it comes up. This will take a little bit with the scrolling logs. It's like I said, it's pulling down the image. One other thing I'll point out while we're waiting for the Bootstrap node to complete its install is that we're also doing a mirrored install today, which hopefully makes this go a little bit faster than pulling all of the images across the wire. What I have is a local instance of a Sonatype Nexus that I have mirrored all of the images into, if you can see this eye chart. And so the install is actually going to pull its images from the Sonatype Nexus. Right now I've got Quay.io in a DNS sinkhole so that it can't resolve. And because it can't resolve, it's going to assume it's an air-gapped installation, and it will pull from the configured mirror image. All right, Fedora CoreOS is booting now. It's going to overlay the RPM OS tree. And when it finishes, it will boot one more time, and it will start the Bootstrap. Which we will watch right here. Okay, so it just finished the OS tree overlay, and now it's coming back up. When it completes booting, should begin the Bootstrap. Okay. Now I'm going to go ahead and fire up the master nodes. So I'm just running a little script here that's going to do an IPMI tool command against those 3 master nodes and start them up. And the fans on my little Intel NUCs just lit up hot. Okay, and in the top right corner here, I'm going to run the OpenShift install command and direct it to monitor the Bootstrap process. And if you do this at home and you monitor the logs like this, don't be alarmed by these failed entries that you see coming out in the logs. This is the Bootstrap process waiting for its resources to go live. And so it will continue to loop until the various resources come up. And you can see the API just came up. So our API is now live, and we're waiting for the Bootstrap process to complete. Down here in the bottom right-hand corner, we're just tailing the journal control logs of the Bootstrap process itself. This all in takes about 10 minutes from the Bootstrap node firing up to the Bootstrap process itself completing. The installation itself will complete after about another 25 minutes. So we've got some time now to take some questions if folks want.
Yeah, James Casella is asking from Twitch, is the sinkhole necessary to use Mirror?
I think it still is. I know it has been for a while that if you don't create the sinkhole and it can resolve the external host, it will pull the images from Quay.io. And that's why I created the sinkhole to simulate a disconnected install where I'm behind bunch of firewalls and proxies that prevent my nodes from having direct internet access.
Let's see. A couple of questions just to double check. The link to the documentation on this, is this the same as the stuff that you did in the OKD4 UPI lab setup?
Yes. There's a new branch called iPixie that when we're done today, I've got a little more cleanup on the documentation to do, but I'm going to merge that branch into master. The old tutorial that was the CentOS 7 based one, I've branched master to a CentOS 7 branch. So anybody that's still running CentOS 7 would want to use the CentOS 7 branch. I've upgraded my entire lab to CentOS 8 and have enabled iPixie even for the hardware, for the bare metal itself. So that just by creating an iPixie boot file with the MAC address of a new piece of metal, all I have to do is plug it into the network, click the power button, and it will provision itself with whatever personality I want it to have.
Okay. I'm just checking the other feeds here. The other feeds are a nanosecond behind us, so in BlueJeans, so trying to do there. And Brian Jacob Hepworth is saying that he really likes the Fedora CoreOS news and seeing that. Kudos. So is this going to take us another 20 minutes or 30 minutes here?
Well, as soon as the Bootstrap completes, then we'll be about 23 minutes out from completion.
Okay.
The Bootstrap usually takes about 10 minutes in this environment.
Okay, doke. I'm going to do another pitch for people to join the OKD working group while we are waiting here, because that's what I'm charged with, is getting more folks in. So if you're liking what you're seeing here, or if there's features missing, or other platforms that we should be demoing to or testing on, or that you're using OKD on or wishing to do so, please join the OKD working group. The mailing list is here. I just put it in the chat, and it is in open Google group. And we have a lot of meetings. We meet bi-weekly, and we have a meeting tomorrow. And I'll throw the Fedora CoreOS and Chef. Thanks for joining us. And we will do the Azure one that you requested earlier. That is our second to last demo, I think, today is Azure. And for the Fedora calendar link here.
All right, the Bootstrap is getting close. Okay, Bootstrap has succeeded. Now it's going to wait just a little bit longer to send the event, and then you'll see, okay, there it went. So the Bootstrap is now done. You can see in the middle terminal that we do have 3 master nodes that are live. I'm going to now remove the bootstrap node. And I'm going to take it out of the HA proxy configuration as well, so that we will forget everything that we know about the bootstrap node. Now we'll watch the install complete. All right, so we are working towards 4.5.0 OKD.
Awesome sauce.
Now, this is something odd about this install monitor here. It will say 42% complete. Here in a minute, it may barf a couple of errors as some of the resources restart. And it will also reset the clock. So it plays with you a little bit. You'll get up to 74% complete, and then all of a sudden you'll see 12% complete, and then it will quickly wind its way back up. I'm making a bold assumption here that that is actually the result of it monitoring some of the resources that through this process update themselves, and so that percentage of complete becomes a little bit variable. So if you see that running this at home, don't be alarmed. It is actually working towards completion, and you need to be patient because from this point it does take about another 23 minutes.
$23. Well, you want to talk a little bit while you're doing this about the work you're doing around Che?
Sure. Well, actually, it wasn't. It turned out not to be much work at all. And in fact, if we end up with enough time, I can deploy a hyperconverged Ceph instance into this cluster to give us a storage provisioner, because that's really I think the folks that might have struggled with getting Eclipse Che up and running is that it does need persistent volumes, both for Postgres. It deploys an instance of Postgres to support an instance of Keycloak that provides the identity provisioning, identity management for your Eclipse Che environment. But the workspaces themselves also require persistent volumes. You can probably make it work with ephemeral volumes, just understanding that if those pods ever got evicted, you lose everything, which would be significantly detrimental to your Postgres instance. So it does require that you have some kind of a persistent storage provisioner. I have done it in the past in older 3.11 clusters with iSCSI, but now with the Ceph operator, using the Rook operator to deploy Ceph, it's much, much easier. And something else I'll mention here, I'll run this again. So you see we've got 3 master nodes that are running, but they're also designated as worker nodes. That's an artifact of how we're provisioning here, because the install config that we used does not designate any worker nodes. So the installer by default makes the masters schedulable. When the installation is complete, that's something that we're gonna change. We'll add the 3 worker nodes, and then we will make the masters unschedulable.
Right. Fernando is asking, is it possible to specify a different ignition version during the .ing or .gn? I'm going to say that wrong again. .ignition files creation?
I don't think so. I believe the install.
No, it's not possible.
Yeah, we're stuck with one.
You should at this time you should always be using ignition version 3.1.0 for everything.
Slight correction. Ignition spec version 3.1.0.
I was about to say, I'm pretty sure there's more than the ignition versions don't match the spec version at all.
Yeah, it's Ignition v2.x with spec v3.x, and our current config spec version is 3.1.0. So for the Ignition config, always use the spec version 3.1 at this time.
We should probably just bump the ignition versions just to make this a lot less confusing.
Yeah.
Because there's no particular reason not to, as far as I'm aware.
Just going to introduce that new voice is Neil Gompa from Datto is in the house. So welcome.
Hi, yes. I just sort of forgot that I hadn't actually been introduced, so I'll just. Oh yeah, I can't. Why does it say the camera's used by some? Whatever. Anyway, the microphone works. Figure out why the camera doesn't in a little bit. I'm a DevOps engineer at Datto. I'm here as an OKD working group member, and I'm going to be assisting Dusty in a little bit once he and I get to our part of this OKD deployment fun, where I will just talk randomly while Dusty pushes buttons and stuff. But yeah.
So here, I'll walk you through a few of the things that were prepared ahead of time. I said a lot of words to describe it. One of especially the way I'm doing this with fixed IP addresses. One of the things that you have to provision are DNS records, a few key DNS records. You can see I've got in here the provisioning for several different clusters that I run. But this is the one that we're presently looking at right here. So each of the master nodes, worker nodes, and the etcd nodes requires an A record. The master and the etcd obviously are sharing the same node, so they're going to have A records with the same IP address. You also need 3 serve records for the etcd, and then you need a pointer record for reverse lookup for each of the physical nodes. So your masters and your worker nodes, you'll need pointer records for those. But as you can see, the DNS setup is not onerous, but it is necessary. And here I'll show you what I'm using an OpenWRT router. It's actually a travel router to actually provide my DHCP and iPXE capabilities. So the boot.iPXE, as you can see, is very simple. I'm echoing some information just to make sure the right host booted, and then chaining in an iPXE file that is literally named after the MAC address with hyphens replacing the colons. And here's one of them right here that I believe will be one of the worker nodes. And so this right here gives it the kernel parameters necessary to boot, tells it, yes, we want to install CoreOS, tells it where to install CoreOS, tells it where to get CoreOS, and tells it which ignition file to use. And that's really the secret sauce there.
Not very secret.
Yes.
You just kind of told the whole world.
I did, I know. It's all right, I've already published it in my GitHub, so. All right, we are, in theory, at 84% complete. I expect it to reset the clock at least once while it's doing this. But this is
How do you determine this percentages? Because like I don't see anything on screen that would tell you percentages.
Oh, right here. Can you see the?
Oh, okay, there it is. Okay, it helped when you highlighted it. There's a lot of word soup on screen.
Yes, there is. And this is how I keep the install from being boring, is give you lots of journal control and logs to look at.
Because otherwise there's not a lot to look at.
No.
So how did you come up with this setup for, I mean, you're doing the bare metal, right? So
Yeah.
how'd you come up with it?
Oh gosh.
Because like I remember that bare metal's like the least fleshed out deployment method of them all. So the fact that you came up with something is impressive all on its own. So that's worth a story, I'm sure.
Yeah, back at the end of 2017, I got addicted to the Intel NUC machines, and those little form factor boxes are they're not cheap comparatively, but considering the amount of compute that you can pack into one of them, for a home lab setup, they are pretty affordable. And if you buy the right chipset, you can put 64 gigabytes of RAM in one of those little suckers. So, you get one with a Core i7, the newest ones, the 10th generation, they've got 6 CPUs. So you've got 12 vCPUs available and 64 gig of RAM. You can run quite a bit on them. And my idea was actually get an OpenShift cluster running on the NUCs. And then I stumbled across this thing called nested virtualization with libvirt. And while I don't do OpenStack, I had a curiosity about it, and that's how I came across virtual BMC. And so decided to basically bump it up a level and used libvirt virtual machines with virtual BMC to simulate bare metal. And then it was just sort of I want to make this work, so I powered through making it work to get bare metal install of OKD up and running. Submitted a few tickets to the Fedora CoreOS team that they were very, very, very gracious to help out. Somebody that didn't know what they were doing. I had never, touched CoreOS before, so that was quite a bit of a learning experience. And
thanks for being part of the community.
Yeah, Dusty and those guys were incredibly helpful, and so it's kind of involved from that point. The latest iteration of it now uses the FCCT tool to inject some customization into the machines. Actually, while we're still waiting for that, hey, quick, here's the reset I was talking about. See how we went back to 0% complete. Don't panic. I don't know why it resets the clock like this. Maybe somebody in engineering could tell us, but it is still progressing, I assure you.
That is very confusing and kind of frightening. Actually, it looks like it resets after it downloads an update, so it probably loses all of its state when it does that.
Yeah, that's my suspicion, because it does go through several iterations of updating some operators.
Yeah, so it's just probably losing its state every time that happens, which is unfortunate, and I'm not sure that makes sense, but the best I got.
It still works, though. That's what's important.
That's the important part. So don't freak out when it goes from 80 to 90 to 0.
Yeah. So right here, if you guys can, I don't know if this is readable, but you can get to it on my GitHub page. So this
Could you zoom it up just a little bit? Just zoom it up one level. So there we go. Then it's readable.
Yeah, this is a shell script that I wrote that actually does the provisioning of the quote unquote bare metal for me. And right here, this is a YAML file that gets created where it's injecting the customizations that I want each of the machines to have. So in this case, what I'm doing is I'm creating a basically a rename of the primary NIC to NIC 0 so that it doesn't come up as some funky ENP blah 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 blah. I want it to be more than predictable. I want it to be predictable and known. And so I'm using the MAC address of the machine to explicitly name that network interconnect device as NIC 0. And that way I always know what it's going to be and where it's going to be. And then I inject into that its specific configuration. So I'm setting, you know, its name server, its domain, its IP address with the net mask and gateway. And then I'm also injecting its host name so that it persists its host name. And there's a bunch of other stuff that this script does, which is one thing I am going to do. I'm going to add better comments into this so that if any of you are looking at how this thing is working, you'll understand what each of these sections is doing. All right, we're back up to 84% complete. At this point, I'm going to go ahead and fire up the worker nodes. It is safe to do so now. Actually, I could have done it a while back, but I'm going to go ahead and do it now. So I'm sending each of them an IPMI command, giving a 10-second pause in between each one just so they don't slam my poor little travel router with DHCP and file pull requests at the same time. And we'll go ahead and watch one of those guys boot up. So there's one of the workers. It's going to do the same thing that you guys saw the Bootstrap node doing. It's pulling the CoreOS image right now. And then it's going to go through the same process, except that it will retrieve its ignition file. Once it processes the initial ignition, overlays the OS tree, and starts its process to join the cluster, it's going to get its ignition file from the cluster that will give it the personality of a worker node. And if you watch the left-hand side of the screen closely, you should see it hit a point where it's waiting on, and then you'll see it very quickly pull that ignition config, and at that point, it will start to join the cluster. Oh, there it was right there, the start job. And there it goes, it got its ignition, and so now it is booting up, and it's going to ask to be a worker node.
So just to give you a quick update on the AWS cluster, it's still waiting for the cluster API to come up. I do have to leave now for like 15 minutes, 20 minutes. I'll be back after that, and I hope my cluster will be up by then.
And
so see you in a little bit.
All right, see you in a bit, Christian. Our cluster is up. And you see
awesome.
It gave us our initial password, so let's go ahead and log in and prove to the world, hopefully, that this little guy is alive. All right, and as before, self-signed certs. So in whatever OS and browser you're using, you are going to have to accept those certs.
It's okay. Self-signed certs are fine.
All right. Now, it creates a temporary cluster administrator for you, and that it dumps that password at the end of the install process that you can use to gain access to your cluster. And there we are. Now, there will still be some operator updating things going on, and your control plane will still be settling out. But at this point, we have a live cluster.
Ooh.
If you will indulge me for a few minutes, we'll go ahead and finish adding the worker nodes. And then we'll do a couple of housekeeping things on our cluster. So you see we've got some pending certificate signing requests. That is also an artifact of the way we're doing this user provision infrastructure install, is that it's not automatically going to approve those certs because it doesn't necessarily trust anybody that wants to join the cluster. So I'm going to approve those certs. And there should be another batch of 3 that are going to come up pending. Yep. And so now we have 3 worker nodes. They're not ready yet. They're still completing their own personal bootstrap. And that'll take another minute or 2 for them to come live. And I'm going to do a couple of house cleaning things here. One is I'm going to remove the samples operator because it, unless something has changed recently, unfortunately Christian isn't here, we can ask him later. The samples operator, because you don't have an official Red Hat secret at this point, it won't be fully functional and can in fact impede updates to your cluster. So I yank it out. Not using it anyway, at least at this point. I'm also going to create a ephemeral storage for the image registry, because it will also be in a removed state because it doesn't have a persistent volume. So I'm patching its configuration with an empty dir specification for a persistent volume. And I'm going to create an image pruner to run at midnight every night, because the console will gripe at you if you don't have an image pruner configured until you do. So anything older than 60 minutes, it's going to prune at midnight every night, or 60 days rather.
60 minutes would be
60
aggressive.
days. Yes. Yes.
I mean, I don't know what kind of storage you have, but 60 minutes might be appropriate if you basically only have enough for the cluster itself to run.
And there we are. We have
Woohoo.
Yay!
cluster. Okay, now, huge caveat.
Ooh.
Our masters are still schedulable. Our workers are schedulable.
But that's not bad.
Well, it's not, but there is a gotcha in here, which, of course, I never tripped over. Your ingress pods will deploy on a schedulable node. Well, if your load balancer is only configured to look at certain nodes, here you see I've got my the port 80 and port 443 and port 6443. They're all directed to the master nodes. Well, if those ingress pods got evicted and rescheduled themselves on a node that is not in your load balancer configuration, then you will lose access to your cluster. Important safety tip. So the key here is either to span your load balancer, which I don't really want to do because that's a lot of extra cruft in the load balancer configuration, or designate some infrastructure nodes. And that's the path that I chose to take. So what I'm going to do real quick is I'm going to designate my master nodes to also be infrastructure nodes. What
Why
I did
doesn't
is-
it do that by default?
Well, because the best practice is to create a couple of worker nodes that you set aside as infrastructure nodes.
Why?
I don't know.
Good. Okay. Just making sure. Because, like, I've seen these recommendations listed in the documentation, but there doesn't seem to be any particular reasoning to back them up. Like, historically speaking, I've seen clusters typically do the masters as infranodes because that way they handle essentially the stuff that keeps the cluster itself running, and the worker nodes are free to work on developer or user workloads.
Yeah, I think one of the things you need to consider is how beefy you make your master nodes. You know, if you've got heavy ingress operations, you know, given everything else that the master nodes are doing, that might be a little overwhelming for them. In my particular lab environment, the master nodes are heavyweight enough. Each of them has 30 gig of RAM and 6 vCPUs. So I feel pretty confident designating them as infranodes. So what you do, once you run this label on them, then you need to patch the scheduler so that the master nodes are no longer schedulable. You'll see right now they are infra, master, and worker nodes. When I run this, now they're just infra and master nodes. Now at this point, nothing got evicted off of them. So if you want to boot things off of them that you don't want running on there anymore, you do need to either go through and evict all the pods that are running on each of those nodes manually, or reboot your master nodes, which is a bit more of an aggressive way of doing it. Now I'm going to patch the ingress operator to tell it that it's okay for it to run on those master nodes. And if you can read the eye chart here, I'll explain what it's doing. It's setting a node placement policy, giving it a match label of infra node. It's also, that's not enough. You also have to set some tolerations because the master node is now tainted. So you need to give it a toleration that it's okay for it to run with a node that has a taint of no schedule and a taint of master node. And so now that that is done, you will see the ingress operator. One of them is terminating. There's a new one running that is not in a ready state yet. As soon as this one is in a running state, the second one will begin terminating. Don't panic that your other one sits in a pending state for a while, because it has an anti-affinity rule that it won't run on a node that already has an ingress pod running on it. So it has to wait for one of those terminating pods to complete terminating before it will schedule on the master node.
Wow.
And so there you go. Now we've got one running, we've got one pending, and we've got two terminating. And it will remain in that state until one of the terminating pods completes terminating, and then the anti-affinity rule can be satisfied, and the pending pod will also deploy. And these take a while to terminate because they're shedding load. They're gracefully shutting down. Okay, there you go. So one of them is done terminating. We now have two running ingress pods. One of them is in a ready state. One of them is still bootstrapping. And the last thing I'm going to do is get rid of that Kubadmin account because its password is sitting there in plain text in your installation folder. So
so it does get written down to this somewhere. I was going to ask, do you have to make sure you save that output text, or will it actually be somewhere where you can get to it?
Yeah, if you look at the directory that you used for the installation, So there's, there's the boot, the ignition files that it created and the metadata. It creates an auth directory. And in that auth directory, it creates an initial Kubeconfig, which you can load to give you access to your cluster directly from your command line, and it dumps that plain text password right there.
But if you get rid of the kubeadmin user, doesn't everything that links to the kubeadmin user break?
It's a temporary account. So here's what we're going to do. I created an HT password file ahead of time. My tutorial has instructions for how to do that. So I've got an admin user and a dev user with passwords already in there. You saw me just create a secret right here. So I created a secret in the OpenShift config namespace called HT password secret from that file. And now I'm going to apply a custom resource that I've already, here, let me, so this is the custom resource that we're going to apply. It's setting up an HT password identity provider, and it's going to link it to that secret that we just created, the HT password secret. So I will apply that. It complains that I used apply instead of create, but I'm just in a habit of using apply to update objects. So you can ignore that complaint there. And then the last thing I need to do is this admin user that I just set up a secret for but doesn't exist, I'm going to give him cluster admin rights. And now I'm going to be brave and I'm going to delete.
Well, it also says the admin user doesn't exist.
That's correct, but it creates it in the background.
What?
Yeah.
That's not intuitive.
No.
Or obvious.
But it does, and it works.
Okay.
And so there we go. I just logged in with my new, somewhat more secure cluster admin account. And you can see our 4 green checkboxes. We've got a happy cluster. It will complain about alerts until you set up a Slack channel or something to send your alerts to. It's actually pretty easy to do. You create a receiver and walk through it. But I have used up most of my allotted time, so I'll stop playing now and see if
I think the playing is fine.
Yeah. No, I'm going to give you that was easy button. All right, well played. And can you do one more thing for me, just because I think people keep asking me these questions. Go back to the console and show the operators that are installed in your installation.
Sure, I will do that. All right, so you go to operators, operator hub. Why are there no operators found?
Because operators don't exist.
Installed.
I think
No,
that's
it may still be updating.
Well, the operator hub operator might not actually be up yet.
Yeah, because it does take a while after, that initial install took us another 23 minutes. It does take things a while to settle down. Let me show you what it does look like, because I have another cluster that I stood up this morning.
It seems less healthy.
Yeah, I think I did something to upset it. But here are the operators that are available. Quite a few. You can see if you want code ready workspaces, the upstream of it. Eclipse Che is in here.
Do you have enough time to try and install the Eclipse Che one?
I might, especially if you don't mind going a couple minutes over, because the first thing I need to do is deploy. Oh, actually, no, I can, because I've already got. Let me make sure I've got Ceph deployed in this cluster. So we're going to go to the Rook Ceph namespace. Yes. Yes, we
Cool.
do.
The fact that the Rook Ceph namespace kind of indicates you have it set up.
Well,
it doesn't.
not
It doesn't.
necessarily.
It shouldn't exist if you don't have it.
No, it can exist, and I haven't completed the install yet. But
Well, okay, there's that.
all right. So we'll go back to the operator hub, and we'll find the Eclipse Che operator. And yeah, it's a community operator. If I call Red Hat, they're not going to help me with it. But if I go on the Slack channel, they're usually nice enough. Okay, and unless you want to do something different about it, you install. And we're going to keep the stable. It is going to create the Eclipse Che namespace. And we're going to let it have an automatic strategy for its approval. If you switch that to manual, then when the installer installs, you have to go to the installer and then say, yes, you can actually install.
That seems painful.
Well, if you think about it, I'm doing everything as a cluster administrator. So if you're not a cluster administrator, but you want to request something, that's part of what we've got going on here, because there's all kinds of configurable RBAC capabilities within this thing.
So when you install this operator as a cluster admin, does that mean that anybody who logs in with an account can then instantiate it afterwards?
Absolutely. Yes, absolutely. The workspaces, people will be able to get in and create workspaces. Again, it's got lots of role-based access control so that you can control who can do what. But yes, anybody that you've got created an account in this cluster should be able to log into Che, create an account in Che, which will provision them into the Keycloak instance that it's going to create, and then they can create a workspace. So let me switch this real quick to the workloads. Okay, our operator is running, it is alive, so we should be able to provision a Che cluster. And you see what I did from the operator. Here's the installed operators, the provided APIs. That's what I clicked on to get to this view here, that I can now create a Che cluster. It's going to name it Eclipse Che unless I tell it to do something else. Lots of things you can configure in here. I'm going to take the defaults on everything except storage. And this is what I was mentioning earlier that I believe has probably hung some people up, is Postgres is going to need a PVC. And then any workspace that you provision is also going to need a PVC, which almost requires that you have a dynamic storage provisioner for this to work. So I'm going to give it the name of the storage class. And actually, I'm going to cancel out of this, go down here to storage, show you that we do, in fact, have a storage class. It's a block provisioner as part of Ceph. And when we create our cluster, I'm going to tell it to use that for Postgres. And I'm going to tell it to use that for the workspaces. Also note, each workspace is going to get a gigabyte of provisioned storage. That may or may not be enough, depending on the type of development that you're doing. That's pretty minimal. So you might want to crank that up to 5 or 10 gigabytes, depending on how how big the artifacts that are going to be built in the code base, and everything about the development environments that you're going to be working with. So I'll create on that, switch back to the pod view, and you can see it's provisioning Postgres. Hopefully our storage provisioner is working. And we do, in fact, have a Postgres data that is bound. So our storage provisioner is working. Okay, Postgres is running, not ready, so it's still deploying itself. And this takes a couple of minutes, and then Keycloak is going to provision itself after Postgres is done. So now Keycloak is provisioning, and Keycloak actually goes through a couple of phases. It has an init phase that it runs through. So you'll see that pod come up and then terminate and be replaced by another Keycloak pod that will be your final configuration. And you won't see the Che controller come up until both Postgres and Keycloak have completed their provisioning.
And about how long does that take? Diane has to ask.
Not terribly long, couple of minutes.
Okay, cool.
It feels like a long time when you're staring at the screen.
That's all right. I have plenty of coffee today, and Michael has just pointed out maybe you still have Quay.io blocked via DNS, and that could...
You know what? I don't. That was a good point out. I snuck that in while Neil was talking. Right here, I blasted a command to my DNS server to remove the sinkholes for Quay.io and for registry.service.ci.openshift.org.
I did actually notice, which is why I didn't repeat the question that he was saying, because I figured on screen it was obvious that you got rid of your Quay.io block.
No, I slipped that in and didn't mention it. So
well, now...
All right, so we've got Keycloak is bootstrapping itself now. So you'll see some activity go there. All right, and there it is. So now you see another Keycloak instance provisioning. And it will take over from the first one here in a minute.
As we all wait with bated breath. In other news, Christian says that his full-blown AWS cluster has finished installation, so when we're done, we'll pop over and let him prove that, and then we'll grab Dusty when he's back, and we'll hit up the DigitalOcean stuff.
Okay, Keycloak is running.
Any of you who are joining us for the DigitalOcean demo, we'll probably get started on that one a few minutes after the hour. We're running pretty close to on time, which I think is amazing.
Indeed.
And we'll probably lose that thread at some point, but hey.
And quick plug for my favorite Java framework.
Quarkus, there we go. There's the Quarkus ad. Thank you.
And what does that have to do with this?
Well, once your cluster is up and running, you got to run something in it, right?
Oh, so you're going to make something with Quarkus.
Okay.
Go up that mad programming skills.
Yes, indeed. So the first Keycloak instance, you see it terminating now, so it's getting itself out of the way. The plugin registry is fired up. Now you see other activity. There's our Che controller right here that is creating. We've got a dev file registry. We've got a plugin registry. And as soon as this guy becomes ready, wish you could hear the fans on my little nooks.
I wish I had a fan here. The temperature is popping up here in Canada on the West Coast. It's probably going to hit 32 today. So
All right, so all of the resources are up. They are all in a ready state. We've had no restarts, which is always a good sign, although occasionally a restart is not necessarily a bad thing. If we click over here to routes, we have a route for Che, and if I'm brave and open that, okay, now self-signed cert again. So what you have to do at this point is grab that cert. I'm going to create a folder here for you guys so you don't have to see all the cruft on my screen. I'm going to go here. I'm going to show the certificate. This is Safari specific, obviously. So follow the instructions for your favorite browser. Safari is not my favorite, but here it is. Grab that. And then what you're going to do is once you've got that certificate, you need to add it to the trust store of your operating system. So in my case, I'm going to go into Keychain and I'm going to drop that certificate into Keychain and I'm going to make it trusted. I'm going to do that for you guys here real quick. I'm going to drop it into my certs, system default certs. You see there's an old one from a previous install. I'm going to take the one that we just downloaded. I'm going to replace. Okay. Now I'm going to open this up and I'm going to say always trust. Now it's going to make me certify that I am me one more time. Now, ta-da! Woo! And I'm going to say, yeah, allow these permissions. And now it's going to ask you to create an account. Now, another important safety tip, if you do what I did, there is an admin account that Che creates. Well, I named my cluster administrator admin. So I need to give this a different name or I will cause some pain for myself. And there we go. Eclipse Che, up, running, ready for your code.
Woo!
awesome. That is awesome sauce. Thank you very much for that. That makes my day.
This is awesome. Yay!
Thank you.
I think you've just made the entire Eclipse Che community happy too. So well done.
And we're only 3 minutes over.
You were only 3 minutes over. So with that, Charo, thank you very much. I'm going to see if I can coerce Christian into sharing his screen for a couple of minutes to prove that his full-blown AWS did go live and just show us.
So I've actually not checked the domain yet, but the command finished successfully, so I'm pretty optimistic about it. I'll share my screen real quick.
Okay, here we go. Live demoing at its best. And we'll see if Dusty's online.
I'm here.
And hey, one last thing to prove. Operator Hub did come back on the cluster we just deployed, so it was just initializing itself.
Perfect.
Can you see my screen now?
Yes, we do. We can see your secret password.
Yeah, I'm not going to add this to my trust store right now, and it's ta-da!
Well played. Awesome. And that was significant.
So the alerts are not configured because I guess that is because I don't have a valid pull secret.
Yeah.
Or is
That's not why. You just have to configure it with something.
Yeah.
They're just not configured until you configure them.
Okay.
Right. Okay. Oh yeah, right. That's telemetry. That's otherwise going to be sent to Red Hat. That's not the alerts. Okay. Yeah, that's it. This is a full-blown cluster. We have 6 nodes here, instead of the 1 from before.
Now do something with it.
Yeah.
Well, what shall I do?
Show us first. Do this. Show us what operators are there. Just that's my other litmus test.
So it's the same one. So from the operator hub, we do have all the core operators. They don't show up here in this operator hub section of the menu, and there's only the package server, which runs. Must be the OLM something. Yep. So it has something to do with actually installing operators from operator hub. Well, it's the same one that was up in the single node cluster. So we don't have anything extra here. Yeah.
Perfect. In the interest of time, because we're 5 minutes over, and to respect Dusty's showing up on time, perhaps what we could do now is switch over and let's let Dusty introduce himself, and he's going to show deploying on DigitalOcean and talk hopefully a little bit about Fedora CoreOS.
Absolutely.
That would be great.
Go Dusty, and thank you all for watching.
And I'm going to pause here before you introduce so that I can stop the recording.
Recording has stopped. Recording has started.
And that's just so that when I'm editing, I don't have huge day-long files. So Dusty, are you with us now?
Hey, can you see and hear me?
Absolutely, I can see you.
Cool. I'm wearing a CoreOS shirt, so if it's off screen at any point, just don't forget it. Okay, cool. Let me share my screen and see if I can hop into this real quick. We'll see if you guys can see my entire screen now.
There you go. Yes, we can.
Okay, cool. So the first thing I'm going to do is I'm actually going to run a script that will do a cluster install to DigitalOcean, and then I'm going to do a presentation. So the goal here is to take up some of the dead time waiting for the install to complete with a presentation that explains what the script is doing. So let me go ahead and kick that off and just see if it actually starts running without issues, and then I'll kick over to a presentation and start. Okay, looks like it's started doing its job. So I'm going to go over to a presentation. Let me know when you guys can see the presentation, and then I'll start off.
I can see it.
Perfect. Okay, so this is a presentation about OKD on Fedora CoreOS on DigitalOcean. My name is Dusty Mabe. I'm a software engineer at Red Hat. I also have Neil Gompa, who's going to talk about his interest in DigitalOcean as well and help me fill some of the dead space in the room, or the dead air in the room when the install is taking forever. So Neil,
Hi.
would you like to introduce yourself too? Yep.
Yeah. So my name is Neil Gampa. I'm a engineer at Datto, and I'm a member of the OKD working group. I mean, professionally, I'm sort of interested in running OKD on OpenStack, but personally, I don't have money for that, and I don't have money for the cloud. So OKD on DigitalOcean is a rather affordable way to kind of try it out and use it in a semi-production-ish kind of way. So that's what I'm here for, just to kind of pretend to be the idiot to kind of help explain everything that's going on and just, as Dusty said, fill in the dead air with the very slow and oddly not very fulfilling screencast of the installation process.
And don't let Neil fool you. He can pretend to be the idiot, but he's definitely not. Okay, cool. I'll hop in and do a little short presentation. So this OKD running on DigitalOcean is kind of a blog post series that I kicked off a little while ago. And I'm slowly releasing new content for it. The first blog post that I did was talking about preparation, things that you need to consider before you're able to set up and run this script that I've created. And there's a link to it here. I'm hoping I can share these slides somewhere. But if you don't want to type this full link out, just go to dustymabe.com. And it's in one of the last two posts that exist. And what I'm going to do now is I'm going to actually give a short overview of that particular blog post. More or less what you do for that one is you grab the OKD software, which includes the OpenShift installer, the OC binary and the kubectl binaries, just in case, we'll need those for different things, and it's nice to have them versioned together. The OpenShift installer we definitely need because we need that to generate the information that we'll use to kick off the cluster. You need to grab the doctl binary, which is DigitalOcean's command line client. And then you also need to set up API keys for access. So one of them is DigitalOcean access token. That's what we use to talk to the API to bring up new droplets. And we also set up two environment variables that are the AWS access key and secret. This seems a little weird, but this is used for access to DigitalOcean's object storage. So they reuse the S3 APIs for that. And so we actually use a different tool that has a different set of credentials. And I'll explain why we do that here in just a minute. Okay, the next thing you want to do is choose a domain to use with OKD. So basically OKD needs entries in DNS in order to operate properly. Actually, I messed up this slide because I shouldn't have more information on there, but more or less OKD needs entries in DNS. And what you'll want to do is you'll want to go to your registrar and set that up and point the entries or the entries for that particular domain over to DigitalOcean's domain servers so that DigitalOcean can essentially manage that subdomain for you. Okay, the next thing is actually doing the deployment. This is the second blog post in the series. And this one actually talks about the automation script that I created and also what each piece of it does. So I created an automation repo that has the DigitalOcean OKD install script in it and a few other things. One of them is a resources directory that contains a few files. I'll go over those here in a little more detail here in a second. And then there's also a config file which has user customizations in it. And then there's the script itself, which I'll go over a little bit more here in just a second. But first of all, let me dig into a few of those things. So we have the resources directory, which has a few files in it. One of them is an install config for OpenShift. And this install config is just about as bare bones as you can get. And it also contains a few things that get substituted into it. So this is actually a template. So I just called it install config.yaml.in. So this is a template that a few different tokens get substituted out. One is base domain, cluster name, number of OKD workers, and the number of OKD control plane nodes. So that is just a basic install config that we feed in and substitute a few values out of. And then we also have a few FCCT config files that are used to either, make some configuration to the nodes and or work around some bugs. So for example, if I look at the Bootstrap node here, there was a bug in Fedora CoreOS. It's already been fixed at this point, but I'm leaving this in here for illustration. But there was a bug where the host name on DigitalOcean wasn't getting set correctly. It was getting set to localhost and not the actual, name of the node that you gave it in DigitalOcean. So this was an example of running a script called hostnamectl, run hostnamectl via the set hostname.service that you could use to work around that particular bug. So this is an illustration of something that you could do to work around an issue in Fedora CoreOS if it happened to exist at the point that you were running this. And there's similar ones for worker and control plane as well. So if you had a customization that you needed to make specifically for a particular type of node, you would do it there. These files themselves incorporate the output of the OpenShift installer. So it will merge in the config that is in the generated files directory and the worker.ignition file. So that basically pulls in what the installer spit out and then merges it in with this other information that's in here. So it's kind of like an additive thing. Real quick, I'll go over the config file. So if we look at this file, it basically is a bunch of key value pairs that allows somebody who is not me to come in and edit this to be what they want it to be. So for example, when you choose your host name, or sorry, your domain name, you can go in here and set this. Mine was okdtest.dustymabe.com. So if you had your own domain name or subdomain that you wanted to use, you can update these two variables. If you wanted to change the number of workers or control plane nodes that get started initially by the script, you could change these two variables to be different numbers. I think the minimum number of control planes recommended is 3, so I wouldn't go below that. I know Christian, I think, showed an example of just doing an all-in-one earlier, maybe. You can change the region that you want to use. So if you don't want to use NYC3, you want to use something maybe closer to your locale, you can do that. The one thing you will need to update is your key pair. So whatever SSH key that you want to use when you create an instance in DigitalOcean, I believe it's required that you actually specify an SSH key. So you have to specify one. So you have to update this information right here. The size of the droplets that you want to use, you can run doctl compute size list to get more options there. The Fedora CoreOS image URL, so this is basically a path to the DigitalOcean artifact, and that will be used to create a new image in DigitalOcean for you, so you don't have to do that yourself. It does that via the custom images workflow. It also will basically derive the name of the image from this, and it will name it that. And if you run this script multiple times, it won't attempt to recreate one. So if you go and look at some of the first output from the script, it says image with this name already exists, skipping image creation. So that saved us a little bit of time. Let's see. And then, a few other things that you can change, what you want your registry volume size to be and stuff like that.
So to be clear, with the FCOS image URL thing for your DigitalOcean OKD install, that's going to, if you don't have it already made, it's going to automatically convert it for you and make it DO ready.
Yeah, so it will basically call into DigitalOcean's API and create a custom image for you using the same URL that you provide.
Okay,
so,
cool.
Yeah, Fedora CoreOS outputs DigitalOcean images. So usually the normal workflow for you for finding out where that is would be just to go to our download site and go grab it from here. So you would just right click and copy that link and then use that as what you provide to this script.
Oh, so we already have a DO version. It's just that you get an uploading it into DO.
Yeah, the only thing that's missing right now is with DigitalOcean, with the images that they provide, they don't do DHCP by default, I don't think. So there's some networking work that needs to be done on Fedora CoreOS side to support their static networking config. But with custom images, they do DHCP by default, which is something we already support. So DigitalOcean images work with the custom image workflow, but not with the provided image from DigitalOcean right now. So that's why this script will automatically create it for you if it doesn't exist. Okay, and let me hop back over to the presentation. So the DigitalOcean OKD install script itself does quite a few different things, and this at a high level is what it does. The first thing it does is create a spaces, also known as S3 bucket, to hold the Bootstrap ignition config. The reason we do that is first of all, we already have access to DigitalOcean, so this is assuming that you can use another DigitalOcean service seems safe. And the other thing is you don't want to just put that particular ignition config anywhere because it has secrets and stuff like that in it. The other thing is you can't actually provide that ignition config directly to the instance on boot because it's so large. It's above 64 kilobytes, which means DigitalOcean's user data service will basically say, sorry, your user data is too large. We can't, when you try to do the API call to create the instance with that user data, it won't allow you. So what we needed reference to this ignition config, and the safest place was to put it in S3 and then use a pre-signed image URL to grab it on boot. And that image URL that I'm using is only valid for 5 minutes. So it's just a way to kind of lock it down as much as possible so nobody else can grab your configs and somehow take over your cluster. The second thing it does is creates a custom image in DigitalOcean for the linked Fedora CoreOS image. We talked about that briefly just a minute ago. The third thing, it creates a VPC for private network traffic. So that way, anything within the VPC is good. You don't have to worry about it affecting your other nodes that exist in your account. It creates a load balancer to balance the traffic. It creates a firewall to block against unwanted traffic, generates manifests and configs via the OpenShift install binary. It uploads the Bootstrap config to spaces to be retrieved by the Bootstrap instance, creates the Bootstrap control plane and worker droplets, creates a DigitalOcean domain and the required DNS records. It provisions the DigitalOcean block storage CSI driver to the cluster, and then once everything is up, it removes the Bootstrap droplet and the spaces bucket since those are no longer needed. One thing that I will mention, at least for right now, I took a shortcut with the automation script. I only create one load balancer. So normally what you would do is you would create a load balancer for like the control plane nodes and then a separate one for the worker nodes where the routers are running. But to simplify things, I just created one load balancer that has the control plane nodes in it, and I modified the ingress routers to run on the control plane nodes instead. That's not best practice. It just happened to be something that simplified the script quite a bit, and yeah, I might change that in the future. Okay, yeah, and there's more posts I have to come in this series. I want to start talking about like configuration, for example, your certificates, so you don't have self-signed certificate warnings every time, if you wanted to share this cluster with somebody else. And then also, setting up identity access. Like for me, for my personal blog, I use GitLab identity access to log in. You can use many different ones, but Okay, and this is my shameless plug for Fedora CoreOS, but I know we're talking about OKD today. So let me hop back over to the install and see kind of where we are. And I'll talk briefly about where we are, and then I'll see if anybody has questions or if Neil wants to jump in and tell me what I should be doing differently. Okay, so where we are in the install process right now is, first off, it checked to see if the image that we were going to upload already exists, and it appears that it does. So it basically looks for an image with this particular name, and it assumes that if an image with that name exists, then it is what we want to use. You know, it's theoretically possible somebody could specify an image with that name that wasn't that content, but you know, we're going to make that assumption here, and we should probably be okay with that. Okay, we created a VPC and a load balancer, and we waited for the load balancer to come up because the load balancer IP itself is something that we use in later commands. So we wanted to wait for that to come up so that we could grab that IP. We created a firewall. We generated the manifest for the install from the OpenShift install script. We created the droplets, and then there's an informational command that runs that basically prints out all the droplet names and the IPs. This is useful if you kind of want to hop in and debug something on boot, maybe. It created the domain and the DNS records, and then it also ran OpenShift install to say, hey, let's wait for the bootstrap to come up. So the bootstrap came up, and let's see, it took 11 minutes for the bootstrap to come up and finish, and then it removed the bootstrap resources. So the bootstrap node is now gone. That S3 bucket is now gone. So you don't have anybody able to pick up that config and use it or whatever. It's gone out of S3. And now what it's doing, or what it was doing, was waiting for the workers to come up and make certificate signing requests. And those all have been approved now, and it's moving the routers to the control plane nodes. I mentioned this earlier, so we only have one load balancer. So what we needed to do was move the routers over to the control plane nodes. So what it's doing right now is, before it can move the routers to the control plane nodes, the routers need to actually be up and created. So it's waiting on the cluster to create those, so that it can then move them. So right now, the cluster, you can see we have 3 nodes, OKD control 1, 0, and 2 workers. And we have quite a few pods that are, that are kind of up and running. You can use Control Z in here to see which ones are kind of in a not running state at this point, and if there's anything you might need to investigate as the cluster's coming up. The cluster operators themselves are in the process of coming up, but what we'll do is we'll hop back over here and just wait for it to finish the install. One other thing I'll do real quick is I'll just go browse around our, oh wait, that's wrong. Go browse around the account real quick. And look at, so these are all of the ones that we brought up today. This is the domain that was created just now with all of the different DNS records that are needed for the cluster. And let's see, what other thing, networking. This is the load balancer that was created. And the way these things are set up for the firewall and the load balancer, they're based on a tag that's given to nodes. And so for the control plane nodes, I gave it a tag of OKD test-control. And so all nodes that match that tag will be a part of this load balancer. That means that if I add another control plane node in the future, as long as I create it with the appropriate tags, it'll get automatically added into this load balancer, which is kind of nice. And the same goes for the firewall. So the firewall itself matches on a tag of OKD test. And so it matches all of the nodes in the cluster right now, which is kind of nice. Okay, so while we wait for this, do we have any questions? Or Neil, do you have anything to add right now?
Neil is frantically multitasking with 2 different calls at the same time, so I think this is the first time I've ever seen Neil quiet. So he was hand waving and everything on video a minute ago. I'm not, and I'm not seeing any questions right now, which is great actually.
Well,
but are you back?
I am kind of back now. Yes. So I mean, you did a good job, Dusty. You like actually explained basically everything. So the one thing I was wanting to ask was, how flexible is this deployment strategy? Like, is it really easy to tune knobs to make it bigger or smaller, or like what kind of knobs do you have with this deployment strategy?
Yeah, so what I have right now is this config file, which essentially has a bunch of key value pairs in it. I've tried to make it somewhat flexible without making it too complicated. So like the easiest way to be flexible is to adjust the number of workers and the number of control plane nodes. Just with this, so like if you just wanted, you know, a bare minimum cluster with just workers in it, with just control plane nodes in it, basically what you would do is you would just mark the number of workers as 0, and it'll just bring up control plane nodes, and it will do that. They'll both be, the control plane nodes would be both, master and worker role. But in this case, I decided to bring up 3 masters and 3 control plane nodes and 2 worker nodes. But you can easily change that if you want to, just by changing these variables right here. Different region is something that you can do. One thing that's kind of inflexible right now is you can't set droplet size for your workers versus your control plane nodes. So it just uses a uniform instance type for all of them. And the other thing I think I kind of mentioned or touched on was the load balancer not ideal configuration that I have, which is, yeah, that one's not great. Might be something I need to switch up in the future. But I mean, I don't know. I don't think it's like super flexible, but I don't know how flexible you need something like this to be. And the other thing is, it's also written in Bash, which I don't want to go too far there with making things super flexible. So it's not ugly Bash, but it's still Bash. Did I lose everybody?
Nope, you didn't lose anybody. We're all just
okay.
So how much does this whole thing, like, how much is this going to cost you right now? With essentially 6 nodes.
Yeah. Yeah. So the cost is not quite what I would like it to be. So I've got some things that you can do to bring the instance size down. That I haven't quite published. I was going to make that a follow-up blog post. But let's see, what do we have? We've got the 16 gigabyte size instance. And if we look at the one that I'm using, it's probably not some for this one. I'm using the 16 gigabyte instance because that is what the OpenShift documentation recommends. For my personal cluster, I'm using the 8 GB instances, which are half the price. But this particular cluster with, 5 nodes at $80 a piece is, it's going to cost you some money every month, and it's probably not going to be something you're just doing for fun.
At least it's better if you were doing this on AWS a little bit.
Yeah. And like I said, I've got some things that I've done in CVO overrides, which basically cuts, some of the more fancy features out, but aren't really, if I'm just running my blog and a couple other things, I don't need that, right? And I honestly, if I'm just running my blog and a couple other small things, I don't really need OKD, but I use it as a...
You're a king of overkill.
Yeah, I use it as a tool to learn, right? I want to learn this stuff, and I want to, be up to date on, what the state of the art in the Kubernetes landscape is, and I think this is a really good way to do it. I think the nodes that I'm using are like these 8 GB nodes for my personal cluster, which are half of that. And I don't run any worker nodes. I just run 3 control plane nodes. So yeah.
So at least it's moderate. You could kind of eat that cost.
Yeah, it's better. But yeah. So let's see. Let's like take
Should
a
we be
little while
concerned
for
that waiting to Ingress controller has been going for so long?
Let's see. All right. So what is the magic button? There's a
Also,
button.
this K9S thing that you just started randomly using.
It's basically like a text user interface for Kubernetes. And it just allows you to browse around your cluster without needing like a web browser or without running a whole bunch of commands just directly in your terminal. So I find it a lot easier to use, especially when you're just learning Kubernetes or OpenShift. Let's see. Ingress. So the ingress is not up yet. Let's see if we have. No, we shouldn't be worried. Although, I actually don't know how long it took earlier when I brought up a node. So
it just takes a while.
Yeah, I mean, it's just part of the cluster, right? And it takes a while for an OpenShift install to complete, unfortunately. Let's see. What do I want to do right now? Let's go look at the pods and kind of see where we are in. So it says all of them are in a good state right now. And let's see which ones were brought up recently. So yeah, I think it's just progressing through bringing up the cluster.
Aaron is asking, could the cluster just be built as 3 nodes with a schedulable masters?
Yes. So if you just want 3 nodes with control, just 3 control plane nodes, basically all you do is you come into your config file and you just replace the number of workers with, just make them 0. So in the documentation, which is not really documentation, it's just a comment, I mentioned the minimum number of workers is 0, and according to the documentation, the minimum number of control plane nodes is 3. Although I think Christian showed earlier, you can run like an all-in-one node, but that's not something that this script necessarily handles. Yeah, and basically, if you have no workers, then the control plane nodes will be marked as schedulable. So I think that's just something that the OpenShift installer does by default. I know Charo mentioned this earlier, and I was going to ask him when he mentioned it, but if I look in the resources directory at the install config, I substitute in whatever values are set in that config file. And so if that value is 0 right here for the number of workers, the OpenShift installer will automatically say okay, I have 0 workers that's being configured, so I'm going to mark the control plane nodes as schedulable. And you know, in this output, when we're looking at the nodes, these 3 nodes up here would be, they would have 2 roles, so they'd be master and worker. So yeah, if you want to change that to just run 3, all you have to do is update the config file to have 0 worker nodes. And that should do it. That's pretty much all you have to do. And that's actually how I started with this script. I didn't start with worker nodes. I just started with control plane nodes. And that's part of the reason why the load balancer is still just one load balancer. It's just much easier just to have one with how I set everything up with tags and whatnot. Okay, so the ingress controller was created. So we can go look at that now. So that exists, and we actually updated it so that it would run on the master or on the control plane nodes themselves. So let me get out of that, and we will go over here. All right, so the ingress controller was created, and then we updated it so that it will move them over to the control plane nodes. And if we want to go look at that particular code, it basically waits until the ingress controllers exist, and then it patches them to basically ignore the no schedule. So control plane nodes by default, you don't typically schedule workloads on them. So we had to modify the ingress controller to ignore that, and then also to make it match on the control plane nodes so that it would get scheduled there. So we patched that, and then the other thing we did was we want to make the router run on every control plane, because the way the load balancer is set up, it routes traffic to all of them. So we set the number of replicas of the router itself to be the number of control plane nodes that we have. So if I go look at we have 3 pods in the OpenShift ingress namespace that are the routers. So they're running on control plane 0, 1, and 2. So that's all of them. And let's see where we are now. So now it's basically waiting for the cluster to come up and then install. And it shouldn't be that much longer, just because it spent a lot of time in this step.
So while we're waiting for that to come up, I have to ask, you bring K9S into Fedora?
Did I?
Yes.
I haven't yet. I have been meaning to run go to RPM on it to see how much work would be there. Yeah. Yeah, actually, I've been wanting to do it for a while. I just, yeah. Last time I was in that setup and I was doing some Rust packaging. I was planning on just running it against K9S, and then I think my box got shut down. It's kind of funny. So like I did a lot of research recently into why my box shut down, and in the logs it says power button key was pressed. What? And I was like, searching Google, I'm like, why would my box shut down and tell me the power button key was pressed when I know I didn't press it? And then somebody on Stack Exchange was like, are you sure you didn't press the button? And it turns out my wife had let my kid come up here, and my 1.5-year-old come up here and get around my computer and stuff. And she was like, oh yeah, he pressed the button. So
well then, there you go.
That explains it. I was like all suspicious. I was like, this box is like almost 10 years old anyway. Like, oh my gosh, I need to get something new.
If you had just let it go, you would have had a great excuse to get a new computer.
I know, yeah. So Yeah,
10 years old computer is not a great thing to be working on in 2020.
I know. Yeah, I've been meaning to get a new desktop, but it's something I put off for a little bit. But I mean, honestly, the performance of this thing is pretty good, and so
it's aged well.
It has. I mean, you know, Linux does a good job of harnessing those resources anyway.
That's true.
So do we have any questions in general about kind of how all of this is set up? Does anybody want me to poke around in here and show, you know, kind of what, you know, what resources are created or whatnot?
So I'm wondering if you haven't finished deploying, correct, yet? So
not quite yet, no.
That's what I thought. So no. There aren't any big questions, and I think someone put the link into your K9S blog post in the chat. So I think there's a lot people are very interested in that. So that'll be cool if we can get more folks using that.
Yep. Yeah. So that's in the chat. And if you don't like typing links, you can just type dustymave.com, and it's like the third one down. So it happens to be there.
I like the new logo on your blog.
Thanks. Yeah, I had the
Clever.
default one. I had the default one for a long time, and I was like, I really want to change that little OctoCat to something different. So I finally broke out GIMP and started trying to merge the Project Atomic and the CoreOS logo together.
Well played.
This is what I ended up with. So
well played. So
the logo is super neat. I discovered, I saw that like the other day, and I thought this is super cool.
Yeah. So maybe while we're waiting, talk a little bit about Fedora CoreOS and where that's going, what that community is. I know you did a shameless plug for it earlier, but maybe we've got a few minutes here while we wait for this to initialize.
As much shameless plugging as possible. I mean, we're going to be waiting for the thing to come up anyway.
Yeah.
Yeah, okay, give me 1 second. I'll see if I can find a good presentation that I might be able to sponge off of here.
And while we're doing it, I just wanted to say that we are in the OKD side of the house incredibly grateful to the Fedora and the Fedora CoreOS community, as well as the Atomic folks that preceded it, and that for all the efforts that went into making Fedora CoreOS what it is today. And we really have been doing some real tight coordination in our releases and their releases, and look forward to continuing to collaborate with the Fedora community. I think this is an exciting new chapter for cloud and Fedora and OpenShift. So thanks for everything you all are doing.
Yeah, absolutely. So I'm going to reuse a presentation that I gave maybe a week ago or so. And I've been making the rounds with this presentation, so if you've seen it before, I apologize. But I'll just briefly go into what Fedora CoreOS is, and I might blow over a few of these slides, but that's okay. So Fedora CoreOS itself is an emerging Fedora edition, and it kind of came from 2 different communities that we put together. One of them is CoreOS Inc.'s Container Linux community, and then also Project Atomic's Atomic Host. And Project Atomic was primarily backed by a lot of different people in the Red Hat ecosystem. And Fedora CoreOS itself kind of incorporates the Container Linux philosophy, provisioning stack, and cloud native expertise. And then Fedora CoreOS also incorporates Atomic Host's Fedora Foundation, the update stack from Atomic Host, and the SE Linux enhanced security from Atomic Host. And some of the features of Fedora CoreOS are automatic updates. So this is one thing that Container Linux, was core to Container Linux's value, and something that we decided to also pick up with Fedora CoreOS. So with automatic updates, by default, we need them to be reliable for people. So in order to not break people's systems, we try to catch issues in several ways. One of them is having extensive tests in our automated CI pipelines. and then also having several update streams to prevent what's coming from landing in stable if users happen to find issues. Sorry, to preview what's coming. So users run various streams to help find issues. And then we also have managed upgrade rollouts over several days. And what that allows us to do is find issues with updates and stop an upgrade rollout. So, if the first 10% of users that got an upgrade had issues with it, we will stop the rollout so the rest of the 90% basically don't ever get affected by it. And when things go wrong, people can always roll back to the previous version. Hopefully, that still works for them. But, for OKD itself, the updates are kind of managed by the cluster. So some of this doesn't quite apply as much there. I mean, it does, but in a different way. So like as far as different update streams, OKD doesn't necessarily take advantage of that, although in the testing infrastructure, we do. So we try to catch things in OKD before it hits users as well. And in Fedora CoreOS, these update streams that are offered are next, testing, and stable. Next is kind of experimental features and Fedora major rebases. So our next stream should be moving over to Fedora 33, sometime soonish. Testing is a preview of what's coming to stable. So usually that's just a point in time snapshot. And that will end up in the stable stream in a few weeks' time, assuming that people don't find issues. Stable is just the most reliable stream that we offer, which is the promotion of testing stream after some bake time. And the goals of having these multiple streams is to publish new releases into update streams every 2 weeks, and then find issues in the next /testing streams before they hit stable. So our users happily leave automatic updates on and don't disable them. For Fedora CoreOS, we have automated provisioning. So Fedora CoreOS uses Ignition, which is something that Container Linux also use to automate provisioning. So the idea here is any logic for machine lifetime is encoded in the config. So in the case of OKD, all of that information for Bootstrap is in the config, and then the node comes up, joins the cluster, and then the cluster itself kind of manages the machine. So it's kind of a hybrid approach there. And then for these nodes, whether you're starting in the cloud or on bare metal, you use the same starting point. So you use an Ignition config either way, which is kind of nice. There's some more details in here about Ignition. I'll skip over those. The cloud, being cloud native and container focused. So basically software runs in containers. That kind of helps our reliable update strategy. Having the host basically be host software and then a container runtime, and doing that well, and then any applications running in containers makes it easier to upgrade more reliably. But in general, Fedora CoreOS is ready for a cluster deployment, so you can spin up 100 nodes, have them join a cluster, and then spin down the nodes when they're no longer needed. If we have enough time, I'll actually demonstrate adding a new worker node to this cluster here in just a minute. And then Fedora CoreOS itself is offered on or for a lot of different cloud/virtualization platforms. So we have Alibaba, AWS, Azure, DigitalOcean, Exascale, GCP, OpenStack, Vultr, VMware, QEMU, KVM, and we're trying to add more all the time. OS versioning and security is another feature that we like to mention. So for example, if you run RPM OS tree status on a machine, you will get a specific identifier that says, all right, you can take this particular either version or hash and share it with somebody and say, hey, I'm running Fedora CoreOS, this version, and I'm seeing this problem. And that single statement tells me as a developer on the platform almost everything I need to know. So it tells me exactly what version of systemd you're running, exactly which version of kernel you're running, and all that. So that's very valuable in my opinion. It also uses read-only file system mounts. So theoretically, anything that you have delivered with the OS, the software hasn't been changed, So for example, if somebody accidentally does an RMRF, if they happen to be on the system playing around, it'll prevent issues there. And then also unsophisticated attacks. So if somebody happened to get onto the system and try to run a script that they, was kind of a dumb script or whatever, it wouldn't allow you to modify the existing software on the system. But for more sophisticated attacks, we also have SE Linux enforcing by default. So hopefully, if one of your containers does get compromised, it doesn't gain any further access to the system. It just can modify that on that single application. And as far as what's next, we want to add more cloud platforms. We want to do multi-arch support for Fedora CoreOS. So AArch64 is the first one we're kind of chewing off, and then hopefully we can add support for PowerPC and S390X. We want to make FCCTs, like the configs that are used to generate ignition, a little more human-friendly, making some common things that people do easier, and then also host extensions. For software that is just extremely hard to containerize and maybe like a small system utility, we want to enable people to be able to package layer that stuff and not have issues with their upgrades. Right now, if you package layer stuff, your upgrades can pretty easily get in a situation where versions of things don't work well together, and the upgrade won't actually go through just because, which is a good thing because the upgrade catches it. But and stops, but it's also a bad thing because it means that you're no longer automatically upgrading and you have a system that might be in a state that you don't understand. Improved documentations and tighter integrations with OKD, blah, blah, blah. So yeah, that's kind of a short spiel on Fedora CoreOS. And let's see. Oh, I see. All right, so let me explain this. So the install actually finished, so that's good. This error down here is because for some reason, I guess I pressed the up arrow key and enter at some point. So it started to try to run the script again, and it got an error because a VPC already existed with that same name. So just ignore that bottom part. So our cluster is up and running. If we want to go look. Yep, go ahead.
When you're with the output, it says that the time elapsed for actually doing the installation was 8 minutes and 25 seconds. I feel like that's not even close to how long that was.
No, so that is from the time that I think that was from the time from this point, right?
Okay. So when the OpenShift console root is the OpenShift console operators are being spun up, it took 8 minutes and 25 seconds.
Right, yeah. So we waited a long time for the ingress controller to be created, and then it popped back into OpenShift installer, waiting for it to initialize. And then the next state was waiting for 10 minutes for the route to be created. And then the install was complete, and yeah, it took 8 minutes for that. So yeah, these times are a little misleading. Maybe I should wrap the entire script into some sort of time call that basically says how long the entire thing took.
That probably would be a good idea, just so people have a better approximation of how much time this thing actually takes.
Right. Okay, so real quick, I'll copy that. And I know I'm running out of time a little bit, so I just don't want to.
That's okay. Take your time.
It's fine. Don't worry about it. Like, we started, 15 minutes late anyway, so who cares?
Yeah. Well, the next speaker cares, but that's all right.
Is somebody literally starting at noon? Because, wow.
Zvonko's up next with GPU.
So here we are into the cluster. And, obviously, I think Charo gave quite an overview of, everything that you can do in here. Real quick, I want to, I have a small script that basically will add a worker node to the cluster. And this script, I'm planning just to add it into DigitalOcean OKD install and make it a subcommand or something like that. But this script itself will more or less just run doctl compute droplet create and give it a name and then appropriate tags. and it will pretty much just join itself to the cluster. So let me run OKD worker. Did I use what? Dash, okay. -2. So basically what's happening now is a new droplet will get created, this one, and it will join itself to the cluster, which is kind of nice. So the way that I set things up with tags means that, you know, if an instance has a certain tag, which I guess that's a bad example because that's just the control plane nodes. If the instances have a certain tag, then they'll automatically get added to things that apply to them. So OKD Worker 2 is automatically a part of this firewall now because it has that tag in it. So that's kind of nice. It makes joining nodes to the cluster a lot easier, I think. Theoretically, you know, you don't really only have to run. Oh yeah, sorry, I ran that with bash set-x, so that's why it's so confusing. But yeah, you really only have to run the compute create command, droplet create command in order to join a node. So that's kind of nice. And then, actually, before that node can join, once it actually comes up, we'll have a certificate request that comes in that we'll need to approve. So I plan to automate that as well. I just haven't done that just yet.
So Dusty, a question showed up in the chat that I think is important enough for you to answer in recording.
Okay.
Is it possible to auto scale OKD in DigitalOcean? And if not, when will it be?
So I don't think it's possible. It's definitely not possible as part of what I'm doing here. But part of the reason that I went through and automated this is because it's just not part of like OpenShift. OpenShift install itself knows how to talk to various clouds. So it knows how to talk to AWS. It knows how to talk to GCP and things like that. And that also means that there's a machine API operator that also knows how to talk to AWS and GCP and whatnot, and bring up new nodes in the cluster if you have set up auto scaling, I think. So
yeah, Mike McCune actually did a demo of the autoscaler for us a few weeks ago in one of our working group meetings.
okay.
I don't know if it's in 4 or 5 fully functional. He might have been doing it off of 4.6, but I have actually seen it alive.
Nice. Yeah. Oh yeah. So for auto scaling itself, I haven't personally used that, but I've definitely done the thing where I've got a cluster up in GCP, and I just go and edit the number of replicas in a machine set, and it spins me up a node, right? And it just does that for you, which is really darn cool. But yeah, I think the moral of the story is, or the answer to the question is no. As far, I mean, there might be Terraform modules for DigitalOcean. I'm sure there are, but none of that exists in OpenShift, and we don't have DigitalOcean as a supported platform in OpenShift. But if DigitalOcean was a supported platform in OpenShift, you know, maybe if it was just a supported platform in OKD, not necessarily OCP, the product, that would pretty much obsolete everything I've done with this script. More or less, I was just trying to scratch my own itch with this, and it started as a short bash script and ended up as a bigger bash script. But yeah,
basically automated UPI. That's what you've done.
Right. Yeah, and the only reason I was able to automate UPI is because DigitalOcean has an API that I can use, right?
Yeah, because
you know,
if that didn't exist, you'd be toast.
This is the bare metal workflow automated because DigitalOcean has an API, right? So that's it. Okay, so I've got a pending CSR right now. So I'm going to go approve that. Wait, yeah. So I'm going to approve that one, and then there should be a new one, another one that comes in here in just a second that I will approve as well. And then that node will be able to join the cluster. There we go. Okay, so now if I go look over here, that node is joining the cluster. It's not quite ready yet, but eventually it'll have some pods on it. That's, yeah, so these haven't come up yet, but eventually it'll have some pods on it, and it'll be able to schedule stuff. And let's see where, yeah, okay. And the other thing too is I installed an older version, but you know, as soon as I log into the console, it tells me a new cluster version is available. And if I get cluster version, it tells me what I'm at. If I OC ADM upgrade, it tells me what is available that I can upgrade to. But I won't do that because that takes a long time and I don't have time. But yeah, so that was the demo. Do we have any other questions?
I think that kind of covered all of the questions that I can see coming in from other places too. So I think you've done an awesome job covering off everything. And we look forward to continuing to collaborate with you guys and seeing more DigitalOcean folks coming on board and testing this out and giving us feedback on your scripts and everything else. So I'm gonna queue up our next speaker. Zvonko is going to demo deploying and configuring NVIDIA GPUs for OKD4 on AWS. So I'm going to pause the recording here for a minute, and then I will upload this video.
Recording has stopped. Recording has started.
Just do that so that I have editable chunks. So Zvonko, you want to try sharing your screen? And I know I didn't hit the easy button for DigitalOcean yet, but maybe someday soon we'll hit that and make it even easier. Zvonko, I'm going to unmute you, and you should be able to share your screen now. Let's see. I can see you in the chat.
Hey, can you hear me?
I can hear you, but you need to share your screen.
Yep.
And introduce yourself. So thank you so much for coming and doing this today.
Let me just.
Trying to show all the different flavors, and that's a nice size.
Nice size? Good.
Nice size, yeah, I can see that without my reading glasses or anything on. Perfect.
I can make it bigger if you wish, but it's okay. Okay.
First, introduce yourself and tell us a little bit about who you are and what you do at Red Hat and all the other good things.
All the good things. Okay. My name is Zvonko Kaiser. I'm team lead for the OpenShift PCEP team. The PCEP team mainly is responsible for enabling accelerators on OpenShift. And one prime example is the GPU. We also enabled other accelerator cards like Solarflare, doing this right now with Mellanox. In the process of enabling those accelerator cards, we developed an operator which is called the special resource operator, which is the base for the NVIDIA GPU operator, for the Mellanox operator, and some other hardware accelerators that are using SRO to enable their hardware. Last week, I spoke of the OpenShift Commons briefing about some details, how SRO works and how it fits with the NVIDIA GPU operator. But for today's session is more hands-on, a demo how to enable GPUs in OKD using the NVIDIA GPU operator and NFD. Okay. I have here a OKD cluster, F4.5. 4.5. It's pre-installed on AWS. We've seen a lot of installations today, so I don't think we need to see another installation. We have free worker nodes and free master nodes, free CPU worker nodes, and now we need to add a GPU worker node. So the easiest thing to do on right now is to go to the OpenShift machine API project and look at the machine sets that we have. We have a machine sets for workers, and we can take, for example, this machine set and just pipe it into a YAML. Worker YAML. And the only thing we need to do if this machine set is change the name, change maybe the cluster machine role, the type, and the important setting is, of course, the instance type. I have a pre-populated machine set here, which I use for this demo, and we are using a G4 instance which has a T4 GPU. On AWS, currently we get either V100s or T4s. T4s are mainly used for inferencing and V100s for training. But because of the low cost and ease of deployment on AWS, we are using here a G4 instance. We can add more settings, but the most important one is the instance type. So we just create our new, oh, I forgot something to say. Another thing we should look for is replicas. I'm setting it to 2. So if I instantiate this machine set, we will get 2 GPU nodes because I'm later on going to run a multi-node TensorFlow benchmark so that we have already 2 nodes running. So just create to get machine set. And we are seeing we have 2 desired, 2 current. They are not ready or available. So in the meantime, when those GPUs are instantiated on AWS, we are going to do another step. So for GPU enablement, we have targeted always Red Hat CoreOS or Fedora CoreOS, an immutable system, container-only system, to have the NVIDIA GPU operator working. And that's where we developed the notion of a driver container. A driver container is kind of a delivery mechanism for out of tree drivers via container. And we are currently working with NVIDIA to add Fedora Core support, but for now we don't have any containers available. So we are going to build our own driver container. I have a document. Diane, can I use the chat function here to post a link to a document?
Absolutely.
Okay. Link so people can follow and maybe add some comments on this document. This was also shared on the OpenShift Commons briefing last week. I already checked out the needed repositories, so I'm just going to change directories in here. We have a folder Fedora, and we can run a podman build with the right tag. It's all cached, so we don't need to build it right away. And we can then get to our private repository. I explain in detail in the document how to tag the driver and how to use the repository plus the name, and how to instantiate the NVIDIA GPU operator later on with some settings to make it run. Let's get nodes. Let's take a look at our nodes. Okay, they are not yet up. When those 2 GPU nodes appear, we have a heterogeneous cluster. In the past, people were manually labeling the nodes as a GPU node or as a CPU node. to steer the right containers on the right node. Since OpenShift 4.2, and we are currently working on adding to OKD as well, we introduced NFD. NFD is a project which exposes node features to the cluster. For example, CPU flags, PCI devices, and other hardware that is exposed. So the first step is to bootstrap heterogeneity so that we know and have the labels automatically applied to our cluster without manual intervention. We are currently in the working to adding it to the operator hub for OKD so that customers can install it just by one click. But for now, we have to check it out and call it via make plus the NFD operator. We change the branch to release 4.5, and we can just run a pull policy always and make deploy. What this will do, it will deploy NFD masters, which are responsible for labeling, and NFD workers that are running on the workers for detecting the features. And open. Just need to wait until the connections are made from the NFD master and the worker. Okay, all things are running. Once you get nodes, we can have a look at our nodes. Okay, one of the GPUs is coming up, but we can, for example, look at one of our CPU nodes. OC describe node. And what we see is all the things that is here with the prefix feature node kubernetes.io are coming from NFD. We have here the CPU flags, one feature. How we're using those flags is for optimized workloads. So for example, if you have math libraries that you optimize with AVX 512, you can steer your workloads to these nodes. Otherwise, you will get, for example, a legal instruction if you're running on a later node or on later CPU. You can extract if SLNX is enabled. And for the driver container to work, we need the kernel versions that are running. We need where is the system OS, for example, the operating system release, it's a Fedora 42. So we can, by tagging the driver container in a specific way, we can steer only drivers that are pre-built for this kind of kernel version and operating system to the right node. And PCI 1DOF, I don't know what this PCI vendor ID is, but let us have a look if one of the GPU nodes is coming up. OC describe node. So this is one of my GPU nodes, and this is the other one, seeing by the age. And if we have a look at the GPU node, we are looking for something like PCI 10DE. 10DE is the hex number, the vendor PCI vendor ID of NVIDIA. So now we have all the pieces and the nodes are labeled correctly so that we can steer our NV stack on the right nodes. One thing we need to do is we have currently a wrong cryo config. In this version, there's an upstream fix for that. So we need to reload cryo with some corrected config. So that's what we're going to do now to enable the hook directory. How GPUs are enabled in a container is that NVIDIA has written a prestat hook. A prestat hook is called during the runtime of or stages or life cycles of a container, and the prestat hook is executed just before the command is run. It mounts all the needed libraries, binaries, and devices into the container. And since we are here on a non-writable system, we have no chance to write to /usr. So we need to change the hook to /etc, which is the default where the prestat hook is installed. Do OC debug node. host, and then it's cryo conf, and we need to look for the hook steer. So this is the wrong hook steer because we cannot write to /user. We need to change this to /etc 3dw etc right quit systemctl reload. And we are on another another node. Just change the same settings. Let's use just and reload and restart. So we prepared the host and the node so that pre-start hooks are placed in the right directory, and cryo is now able to pick up the pre-start hook. Otherwise, cryo wouldn't find this hook in /etc because it will just look in /usr. The hooks are prepared. We've built the driver container. We labeled the nodes. NFD is ready. The next step is to install the NVIDIA GPU operator. We are currently using it, going to do it via Helm. Also in the working to add it to the operator hub to have it in OKD. So later on, it would be just a click in the operator hub and instantiating a cluster policy with the right settings without fiddling too much around. But for now, we have to do it via Helm. Going to create a project for the GPU operator where we can save our stuff, and then Helm install. There are a lot of settings we are setting here, which usually are encoded in the CR when developer instantiating from Operator Hub. But since we are overriding the driver container, we need to add stuff like platform OpenShift true, that we have the default runtime cryo because the GPU operator works also on Docker and Containerd. Adding our driver repository we created before, a driver version, toolkit version, and we are saying we have NFD enabled false because the NVIDIA GPU operator is also able to install NFD, but this would be an upstream NFD and not the tested NFD, the downstream version, which is shipped by RHEL and which is certified. So let's hit this. And okay, some leftovers from before. OC delete. I was doing a dry run a half an hour ago, but forgot to clean up some of the pieces. This looks better. 1, 2, 3. Okay. OC-get pod. We have the GPU operator running here. OC-get pod and GPU operator sources. We have the complete stack starting to enable. A container toolkit will install the pre-start hook. We have the driver beam set, which is the driver container we just created. Let us switch to project. Also get part or driver set -o YAML image. So this is the one we created before. We instantiated with the right driver container so that you're running a Fedora 32 driver container. Then the device plugin is used for exposing the hardware to the cluster. And after each of those steps, we are running a validation step. The NVIDIA driver validation will just run a small CUDA application, CUDA vectorette, allocating memory, doing some computations to verify that the driver is working. After the device plugin is deployed, we are running a device plugin validation, allocating an extended resource and running the same CUDA vectorette on to verify that the device plugin and CUDA is still working. Custom node exporter for NVIDIA metrics. I will show later on Prometheus integration for NVIDIA, and said before the toolkit is for the pre-setup. So let's pods. We have a bug in the NVIDIA device plugin daemon set. It's not restarting on error. This is from the early days where people were not using NFD and have the device plugin running since the daemon set. It will run on any node. And so the daemon set were running on a CPU node. And NVIDIA decided to just sleep on an error, which should be fixed in the next release. We can just OC delete those pods for a restart. Daemon set are not running to completion. They're just sleeping here and not. Logs. At first, should have checked that the NVIDIA driver daemon set is. Oh, it's not yet ready. So what the driver container is currently doing now, it's building the kernel modules on the fly on the cluster. The other step was just to prepare the container with the source code and the tools that we need. And the driver container will then figure out on the cluster when it's running the kernel version, install kernel devel headers and other tools that it's need for building, and then build the drivers and the kernel modules on the fly on the cluster. Okay, go 1 minute. Okay, wait, 4899, so this is good. See logs. Let's just look for the other driver daemon set. Then also get pod and OC logs F. That device plugin, the device plugin validation is going to be restarted. It's completed. See logs. You can see that the test pass done. OC get pod. We can wait for a restart of the NVIDIA driver validation, but we can also delete it. Make it faster. OC logs of the NVIDIA driver validation should also say test passed. OC get pod. And the complete stack is completed for the parts that should be completed, and all the other parts are running. We can now look again at the nodes. I'll see describe nodes and one of the GPU nodes, just to have a look on the exposed and resource. You see here we have a capacity of 1 GPU and allocatable of 1. So we are now ready to run a GPU workload. and a pod allocating this extended resource. This I have prepared the MPI workload, which runs TensorFlow distributed by Horvath. Pretty simple. We just need to deploy the MPI operator, which creates a CRD MPI job. We can instantiate a CR with an MPI job. It's all documented and linked in the document I shared. And let's just have a look if data is deployed. Okay, it's running. Oh, next time I should switch the namespace. But as we see, we have here a launcher, which is the part that launches the MPI jobs. And for each node, we are getting a MPI job on a worker running. Let's just wait for pulling those images. They're pretty big. Then we can take a look at the logs that they're actually using a GPU and doing some training. Okay, what also works with GPUs is autoscaling. You can create a autoscaler that references this very machine set that we created here. So if a pod comes in with min and max, and if a pod comes in and Kubernetes scaler sees it's impending, the autoscaler, cluster autoscaler will kick off on AWS, will kick off and create a GPU node. The NVIDIA GPU operator will take care of installing the NV stack. The NFD will label it so the operator knows where to deploy all the pieces, and the workload can run. For all the steps that are needed for this one, I linked it in the document I just shared. And let's just wait. But maybe this would be a good pause to answer some question if there are some questions coming up.
Actually, I think you're doing a pretty wonderful job of doing this, and not a lot of questions are coming in. However, the document that you shared with the notes,
yeah.
I think a few people are having some technical difficulties getting into it, and I'm wondering if either after this demo you can make this into something that's more public than the Google Doc.
Yeah.
So that we can have access to it, maybe somewhere in the OKD repo or wherever Christian and the team think that.
Yeah, if there's something that's more publicly available, I'm happy to share it.
Yeah.
And update it as we are proceeding and adding all the parts that I have mentioned here that are still work in progress.
So there's this great hackmd.io tool, which is like an Etherpad, but it uses Markdown the same way GitHub does. You can actually store it in GitHub as well. And that you can put permissions on there, similar to Google Docs, but it's more collaborative and more open. So maybe that's a good choice. Otherwise, a PR to the OKD repository would be super.
Yeah, that's what I put it in HackMD. We can all hack on it and add to it and get our feedback on it. But I think the getting into the docs, how to configure GPUs and stuff like that, eventually I think is a not long-term, medium-term goal as well. So we tend to do a lot of documentation by blogging. So we clean some of that up.
Yeah.
It's a Red Hat habit.
Maybe we should. Yeah, maybe I should do a OKD GPU blog, but since I'm covering a lot of the, maybe I should do it on the OKD. There are also some documents on how SRO and the NVIDIA GPU operator work internally. If you're looking on OpenShift for how to enable hardware accelerators, there are several parts describing what a driver container is, how to use entitled builds, because SRO it was always a template for hardware vendors to enable them, because most of the steps are always will always repeat, like enable the hardware with the driver, which is a driver container, because you can deploy a driver container on Red Hat CoreOS, Fedora CoreOS, RHEL 7, RHEL 8, even on Ubuntu. So you don't have to fiddle around with the host, because we said from the beginning, don't touch the host at all. Keep it in a container, because then it's far easier for an operator to pull those images or update the drivers. And with the conjunction with NFD, we have all runtime information there to easily tag or pull the right container into the cluster. And then after the driver container is deployed, we have the device plugin, which exposes the hardware. Then we have the node exporter, which exposes metrics. And we also had in SRO a custom Grafana, which also exposed a GPU dashboard. And NVIDIA is currently thinking of adding this as well, so that they have maybe their own Grafana dashboard just for GPUs and their metrics, what they have, because it's far a lot of metrics, and that they can expose like NVLink metrics. Then if you're doing multi-node, all the stuff that would do bandwidth from node to node, and then all the GPU metrics and alerts if you're overheating, if you're not using the GPU, because they cost a lot of money. So a lot of stuff that can be added to the GPU operator. So we are still working with NVIDIA to add the features that we already had with SRO. Besides that, as I said, there's always this template repeating, and we've developed SRO in such a way that you could just templatize. It's all templatized. You don't have to write any Go code to enable another accelerator, and that's what we've done with Mellanox, for example, to enable RDMA. The only thing we supplied is a custom CR, some manifests, and the operator takes care of it, ordering state transitions, RBAC rules, and stuff like that. So we are at the end, TensorFlow run here, GPU workload run multi-node with MPI and Horowat distributed. And that's the end of my demo here.
Awesome.
I'm happy to answer any other question if they came up.
Oh, I think, is it, and I'm not sure whether, can you boot into the OKD dashboard from here? Just to end on a screenshot. Proving out that it is actually deployed.
That is what deployed exactly.
What that means, and it's tiny, tiny font that you have in that screen. So
yeah, it's just a second.
Yeah, that's okay. And you did make it look easy. So hopefully we can get this documentation up and accessible somewhere so that other people can test it out.
There are a couple of people who tested it out. So Joseph Meyer, who is, I think, the next speaker, he's done that. And he followed the document and made it run on his cluster.
And our next speaker is, I think Justin Pittman is coming on board next, and then Joseph will be on after that.
Yeah.
Justin's going to try and attempt to do OKD on overt and using IPI, living dangerously on the edge.
Yeah, I just wanted to say this has been a feature that has been requested a lot of times, actually, in the working group meetings, not only by Joseph, but I think others as well. So really great to see this works, because we weren't able to definitively say it works, as is nobody had tested it out. But that's super great to see.
There we go. If you're supposed to be seeing your other terminal, we're not at the moment. Sonko.
Yeah, I'm just trying to log into the console, having trouble.
Oh,
Let me just get me this thing. Oh. Okay, it should be monitoring metrics and DCGM. So DCGM is the data center monitoring stack of NVIDIA, and here's GPU temp, GPU utilization, for example, run queries, and we've seen here that we've done some work. So the metrics are working, workloads, pods, all projects. We were in GPU operator resources. There should be the TensorFlow benchmark launcher. And if you look at the logs, we see the same logs we've seen before in my console. TensorFlow running. What else? The pods. I don't know what else to show to prove that it works.
I think you've proven it. I think you've actually done something pretty awesome, and we're really grateful that you took the time today to come and join us. So I know we'll probably hook you up with a lot more questions afterwards. I'll join your email and your contact information. I'll put that out there on the working group. So if people have questions, they can reach out to you directly or post questions. Actually, that's probably a better question. Where is the best way to, if we have questions about the NVIDIA GPU and working with OpenShift and OKD, what's the best route to asking those questions?
I'm on the Kubernetes Slack, and email is always a good way. And I would say Slack on Kubernetes or email would be the fastest thing to ask questions. And then if there's some other problems that are not related, I can steer the people to the right contacts if something is missing or we need to do more work. Or but I'm tracking all the work upstream with NVIDIA. I'm the technical lead for GPUs on OpenShift. So any requirement, I'm happy to help get those things upstream or to have more features included.
Perfect. And we're in talks right now for in October to do an ML AI OpenShift Commons gathering co-located with the GTC's event that's going to be virtual then. So we'll probably see a lot more from you and other folks doing interesting workloads here. So, you know, I look forward to all of that. And October should be a really interesting month because we'll have both that GTC event and I think we're going to try and do something with open infrastructure around OpenStack and an OpenShift Commons gathering. So we'll be busy in October and probably the ramp up to that. So also I'll share the link and chat to the video from last week that you did that was a deeper dive into it, and we'll get all this up and running and up on our YouTube channel again in a playlist for today. And great work. I'm totally appreciative, and we all are, of all the efforts that go into the accelerator program.
Yep.
So thanks. So I'm not seeing any more questions anywhere. So what I'm going to ask, I'm going to put Charo on the spot. We have 20 spare minutes here, or about. Which demo, Charo, would you like to try? Rook-Ceph, or there was one other one, the Maria DB?
Well, they need to go in order because we have to have storage to provision in order to deploy a MariaDB Galera cluster. So we'll start with the Ceph operator, and we'll go from there.
Awesome. We're never at a loss for things to demo on OKD.
Right. This is probably going to be a little less polished, but we're going to do it anyway.
And this, by the way, is what we do to all new employees. We just throw them into the fire pit and stoke it until they
Good luck.
they can demo anything.
My cheat sheet here.
The Red Hat hot seat.
Okay, so a lot of what you're going to see here, I pulled the configuration that we're going to deploy directly out of the Rook project, which you should be seeing on your screens right now. So what you see me running here, I pulled from here specifically. Let me clear this out if you guys can see the screen on the left. The common YAML file and the operator OpenShift YAML file. Those are pulled verbatim from this project. You can see the path here to get to it, and it's release 1.4. It's the latest release. I'm not quite brave enough to run directly out of master at this point. So back to the cluster that we deployed earlier this morning. You can see it is fortunately still healthy. There's a few errors being thrown, but it tends to do that in my home lab, network latency and such. So what we're going to do first is the 3 worker nodes that we deployed. What I didn't tell you when I deployed them was that I actually deployed them with an unused hard drive attached to the virtual machine. So it installed the operating system. It's using a SATA bus, so it installed the operating system on SDA, but it's got an SDB sitting there that is not currently being used. What we're going to do is we're going to create a Ceph storage cluster to serve up block devices on these worker nodes. The first step is we need to label those nodes to give them a role of storage node. And so I just applied that label to them. If I hit a quick OC describe on one of those nodes, I can show you that it now has a role of storage node. Okay, so that's step 1, is we need something to tell Ceph what it's going to be working with. Step 2 is we're going to deploy this common.yaml, which, as you can see, is creating a whole lot of boilerplate that the Rook operator is going to need. And one of the things that it did was it provisioned for us a namespace, the Rook Ceph namespace, which currently is very uninteresting. We're getting ready to make it interesting by deploying the Rook operator. And this will take a little bit for it to bootstrap itself. The operator image right now is pulling down and installing. When the operator is up, it's going to create some workloads, some pods on each of those nodes that bear the label, so that they can discover the resources available on that node. And this will take just a little bit to run. Okay, and there you see the 3 discover nodes that are spinning up now. And while those are coming up, let me show you a little bit bigger so that you can see it on the screen. Okay, the cluster.yaml file is the thing that actually defines our particular Ceph cluster. And again, the Rook project has a boilerplate copy of this for you to take and modify to your own purposes. This is the version of Ceph we're going to be running, 15.2.4. We're going to have 3 monitor nodes running. I have set node affinity on those, and that it's also going to be looking for a role of storage node. I've assigned resources for the various components of Ceph, a limit and a request, just like you see in a typical deployment. And here is the piece of magic that tells it where to find those devices that it's going to create the Ceph storage cluster on. Now our operator appears to be fully bootstrapped and up and running. So the next step is to go ahead and deploy our Ceph cluster on top of that. All right, now this is also going to take a little bit, and you're going to see a bunch of activity here as the operator provisions this cluster. There's the 3 monitor instances you just saw spin up. There's the CSI plugins. Here in a minute, it will start actually dealing with those physical devices and formatting the storage for its own use. Okay, you see these OSD prepares? There's 3 of them. When they are done, they're going to go into a completed state. Once you see that completed state, then the Ceph cluster is up and it is ready for use. Looks like we're still waiting for one of the crash collectors to go into a ready state, but everything else at this point should be usable. So to prove that it's usable, let's take our image registry and let's give it a persistent volume. I've created a storage class here that I'm going to apply. Its name is Rook Ceph Block, and it's going to use the new Rook Ceph CSI plugin that we just deployed as the provisioner. So I will apply that to my cluster. Right. Now, if I flip back over here, go down to storage, we should have a storage class, and indeed we do. So now, let's create a persistent volume claim, 100 gigabytes, because I tend to use a lot of container images. All right, now we should have persistent volume claim. And the key here, you can see now it is bound to an automatically provisioned persistent volume that our Ceph cluster kindly handed out for us. We can see that from the command line as well. There it is, 100 gigabytes. Now, remember, if you were watching previously, when we deployed the OpenShift cluster, we gave our image registry an ephemeral volume. We need to remove that ephemeral volume before we give it the new volume. So, caveat here, any images that you had put in between, you're going to lose those because we're yanking away the storage. You would have lost them anyway because this is an ephemeral volume. Okay. now going to put our registry back into a managed state. We're going to tell it to use the persistent volume claim registry PVC. We're also changing the rollout strategy of this to a recreate. Because I created a read-write once volume, the rollout strategy that comes by default is not going to work because it will try to do a rolling deployment. I need this to tear down the first instance and create a new instance so that it doesn't try to violate the read-write once policy. So we just patched it. If we log back into our cluster and look at the image registry, here we go. We have an OpenShift image registry that's creating and should be binding to that persistent volume claim. So I'll pause there. Any questions on that? I know that was pretty fast.
I think you're doing pretty good here.
All right. I will now deploy a MariaDB Galera cluster. It's going to be a stateful set. All right, what we're going to do, we're going to deploy this stateful set right here, which is going to create a 3-node MariaDB Galera cluster from a customized image that we're going to build and push into the image registry that we just created. First thing we need to do is build our image, which the official MariaDB repository, it's going to install 10.4. Our Docker file looks something like this. So we're going to do some things to set up a MariaDB. The real magic happens in this shell script that is going to be run by the image when it starts up, that actually provisions the MariaDB cluster, detects whether or not a cluster already exists, if it's the first node in the cluster, so forth and so on. I've got a short tutorial written up on this that you can see, so I won't drain it here. We'll just do the fun and kick it off. So first thing I need to do is make sure I'm logged in. Okay, and I am in the right cluster. Important safety tip, always make sure you're logged into the right cluster. So I need to expose a route for the image registry. So what I just did is I patched the image registry operator to say, create a default route so that I can externally get to my image registry. Then I'm going to use Podman, and I'm going to log into that image registry. Hooray, it succeeded. And now I'm going to do a Podman build and build our MariaDB image. And you see, I'm grabbing the route from the image registry to tag my image that I'm getting ready to build so that I can push it to the directory. And it generally doesn't run that fast. I ran this just a little bit ago to make sure it was going to work. That's why that build went so fast, because it had already actually been built. So all it did was add a tag to the already built image. Now we'll push it to the registry. Okay, so now our OpenShift cluster in its local cluster registry, it now has our customized MariaDB Galera image. So let's create a namespace for it. Let's create a service account. Okay, we're going to create a service account for MariaDB. The reason is MariaDB is picky about its UID. And it's especially picky if it restarts and its UID has changed. It tends to get upset. So we're creating a service account, and we're actually going to run this privileged with this new service account so that it can run as any UID. There is likely a better way to do this, and so I am open to suggestions. And now I'm going to apply a config map that actually contains the MariaDB server.cnf file. So by using a config map to do this, I can modify the configuration of my cluster without having to deploy new images. I'm now going to apply a couple of services. One of them is a headless service that allows the cluster to talk to itself on the necessary TCP and UDP ports. And then I'm going to deploy a load balanced service that will allow applications to talk to the cluster. Not sure why that's taking so long to come back. Okay. Now, before I hit this, I'm going to switch over here so that you guys can see the deployment. All right, so I'm going to deploy the stateful set, and what you'll see in the console is a ordered deployment of the MariaDB stateful set. Good. We should see this PVC. Okay, good. The PVC bound. Now we have persistent volume. And you see the first node in our 3-node Galera cluster is now starting.
So just pause just for half a second. Frank's asking a question. He missed the very first part of your Rook operator installation, and he says he has no Rook operators with his IPI-based cluster installation. Is the operator hub filtering operators based on UPI, IPI installation choice? Maybe clarify that for him.
Okay, good point. I actually deployed the operator from the command line because it doesn't show up in the operator hub. See? Not there. Not sure why.
It may be one of the ones that we need to, as a working group, add in a community version. There's a community version of it on operatorhub.io that works with generic Kubernetes, but I think we need to do some work. I think it's on one of the ones that's on the priority list for us to work on as a working group.
Yeah, and that's why I deployed it by using the operator configuration that is provided in the Kubernetes Ceph examples in the Rook project itself. All right, so our second cluster node is coming up, and these do an ordered startup and an ordered shutdown so that you can gracefully stop and start this cluster and it will retain its state. And when this is done, we have a 3-node MariaDB Galera cluster that is a full multi-master database cluster running in our OpenShift with provisioned storage.
Wow. Well played. Thanks, Charo. that was pretty awesome. I think, and I keep emphasizing in the chat too, as well, some of the operator work is the next things on the roadmap that we're trying to get folks to work on. So getting some of those default operators from Operator Hub into Community. So we'll be working on that. So you've filled the time very nicely. Justin Pittman's here, and he is going to try and outdo you on bare metal. So if we can take a pause and a deep breath, I'm going to stop the recording so we can bite-sized chunk it.
Recording has stopped. Recording has started.
So Justin, now that Charo has done magic on bare metal earlier today, you're up next. And let's see if we've got you muted or, yeah, we've got you muted and all kinds of things. So how about sharing your screen, Justin? There we go. Hello.
How about that?
Oh,
a little bit better.
I love the t-shirt. You could just, you have to show that off a little bit. I read your email.
Okay, so the reason for that is I did not read your email, Diane, that you sent on Tuesday. So I thought you might enjoy that.
I was on vacation.
This is
doesn't matter. So cool.
This is actually an old Think Geek shirt, if folks remember Think Geek.
Mm-hmm. Oh, absolutely.
Yeah.
I might have a few of those somewhere around. So Justin, introduce yourself and the topic you're going to try and achieve here today, and we will rock and roll.
Yes, for sure. So let me try to share a screen, if this will possibly work. This is not the first time I've done this, I promise. Try.
You're a Red Hatter. We know you've used blue jeans before.
Yeah, full disclosure, I do work for Red Hat, but yeah, this is going, full community. Sorry about that. I thought I had this slide. I want to show you a slide, and I thought I had it, but obviously I don't. Hold on. Just to give a background here. All right. Work any minute. I'm just going to share the whole screen. There's nothing too private. Might see yourself for a minute. Does everyone see that screen share?
Yep. It just says you are sharing. There you go. There's Justin.
Okay, so just as a background, because there are a lot of different people, I've worked since the Linux 2.0 days on various different Linuxes. And currently, I do work at Red Hat, and I'm focused on OpenShift, but I have played with OKD just outside of my work. So that's the background here. And just to give you a background, I always like to show, who you're talking to. So we have some furry friends here, and the story I like to say is I was flying for work up to Toronto. This was before COVID, and my dog was very jealous that I'd be flying, so she chewed my passport. And if any of you had tried to look into the details of flying with damaged IDs, damaged IDs are no good, at least in the US. The TSA does not accept them, so I had to do a same-day passport replacement. Buyer beware for pups and owners of pups to keep valuable things like photo IDs and passports away from them. Anyway, today we're going to do OKD4 on overt. So hopefully that's what you came here for, and we are going to do this live. I jokingly told Diane that my overt lab was down last week, and so for hardware replacements. And so for a moment, I actually went to Packet. If people are familiar with Packet.net, they're an Equinox company. They have excellent bare metal. So I temporarily spun up Overt in Packet because they provide pretty cheap. It was about $2 for the size instance that you would need. So if you want to try this at home, you can go into Packet, and I can just briefly show you how you can spin this up, what you would need to spin up Overt on OKD. You'll be looking for their M2X Large. They run about $2 an hour. I don't get paid for Packet, I'm just letting you know. This didn't work for me, however, for Overt because of the way that Overt needs to do networking. There's certain, Packet does bonded network interfaces. I can actually show you that just so you know and can be aware. So these interfaces get bonded. So I wasn't, and Overt needs to have a VM guest network. So I wasn't able to go this route. I had to abandon it. So I had to go back to using and quickly spinning up my own hardware lab that I have. So that's what I'm showing you here. This is not on Packet. This is actually my own hardware that I use. And I'll show you the version that it's running and stuff like that, because this is what we'll be deploying OKD to. So it's version 4.3.10 of Overt. This is a CentOS 7 based Overt. So, and it's actually launching OKD right now. That's what's going on in the background here. So we'll get to this in a minute. But I just wanted to show you, if you want to try this, see, there's a second master going up for OKD. If you want to try this, Packet might be an option if you don't have your own hardware, because Packet has pretty cheap bare metal instances. You'll want to shoot for, you know, the minimum requirements. Probably shoot for at least 256 gig of memory. We're going to slim it down a little bit today, but this lab, for example, doesn't have the minimum requirements that OKD is supposed to have. But let's get into it. So I'm going to have to actually rewind because I have a deployment running. So can anyone see is the text large enough on the terminal?
It could be a little bit bigger for us with older eyes. Just tired eyes, not even older, just tireder.
I feel you. Okay, so I made it a little bit bigger. So there's a deployment currently running, but I want to actually destroy this cluster because today we're supposed to be live deploying OKD4, right? And I want to destroy it also to tell you a couple caveats that you'll have to know about OKD4 in order to get it running on your Overt virtualized system. So the first is if you go into the documents, so that the documents, let me make that screen bigger as well. The documents for OKD have, if you switch to version, oh, see, this is already wrong. I'm on the wrong installer. That's the OpenShift installer. So get to the right installation doc. There we go. I was comparing the OpenShift install doc to the OKD install doc, and there are some differences. So I think a doc bug is in order. So here's the latest OKD for installing Rev quickly. This is what you'll want. This is the method that I've used before I had all of this Overt lab fiasco. It's under docs.okd.io, the usual stuff. So we're going to step through this today. I do want to share with you the diagram of what this is. If you're familiar with any other virtualization environment, vSphere, basically you have multiple virtual hosts that will be running OKD4 in VMs. And so that's what this is describing. There are several things that you need to do in order to set this up, and there's at least one doc bug. So Diane, talk about community. I may file the doc bug live with us here because I pounded away at some issues and I think it's just some documentation that needs to be changed.
Oh,
So,
there's always documentation that needs to be updated, but thank you the docs.okd.io for us. Thank you, much appreciated.
yes, for sure. So let me, I hate to destroy a cluster, but let's do it. So I'm actually going to cancel out of this install. Now, if you're curious about what I was doing there, you can see I was doing an OpenShift install. The installer is still called, even for OKD, it's called OpenShift, even though we get it from the OKD build release. But that doesn't matter. Just wanted to show you what it was. Now, I needed to destroy this cluster, and so let's see if that's actually in the doc about the specific way to destroy the cluster. I always try to go by the document, because if you reference something, then people always ask. Okay, so is it going to No, it's not going to document that. Oh, wait, there it is. Destroy bootstrap, but not destroy cluster. Okay, anyway, it's destroy cluster. Oh, no, sorry. It probably wants me to tell it the dir. So I created a directory, test3, and so it probably just wants me to specify test3. Oh, I bet I did not keep my install YAML, did I? So I may not be able to destroy this cluster. Let's see. Okay, there it goes. So I used this directory to install because I had several different test installs running that had issues. So you can see now it's removing the VMs and whatnot. Now, just to show you that was happening on what was happening on the overt side, you can see overt is saying removing VMs. Let me make that bigger for you. So if we were to go into overt and finish removing master 1, yep. So it's cleaning out these VMs that OKD was created on. And it's actually leaving one around. It's leaving this bootstrap. And you can destroy that with the bootstrap command if you want to do it that way. Sometimes I just destroy the VM. Doesn't really matter. It's just a bootstrap node. So if I stop it and do a stop shutdown, we're going to destroy it. For those of you not familiar with overt, this is basically the UI interface to it. And then we're going to remove that. We don't need it. Don't need. Okay, let's get a clean install. This temp VM is interesting. I don't recall it in a previous install. Anyway, okay, so let's go through the installation and what you need. Let's actually run through the whole document to install to overt, so we can get to any issues that don't make sense to folks. Let's go back to the very top. So requirements. Remember I said that there were certain requirements to be met. For example, they recommend 230 gig on the docks of disk space. I'm running less than that, but I'm doing thin pull. So in the virtualized world, for storage, you can do a thin pull back to VMs and get around some of these hefty install requirements. They also recommend 28 cores. That's pretty reasonable. They do recommend here at least 112 gig of memory. So those are the basic requirements. You can go to the main kind of dashboard of overt, and you can see that we meet most of those requirements. I have 140 some gig of free memory, and I have about 200 gig of storage. So we might just barely be squeezing by on the storage. Back to the doc, what's required. It gets into step 4. It doesn't really make a whole lot of sense in the document, but I'm going to step through because I want you to know the whole process, and ask questions if the process doesn't make a whole lot of sense. So this curl command, what they're doing is they're just trying to get a access to this engine, this manager engine for overt. They're just trying to get a local certificate out of it. So what I'm going to do is I'm actually going to install from my local box here. So this is just my laptop. It's not running anything special. But let's start from scratch. How about I do that? Let's just make a new directory. We're going to do live OKD4 install. Let's just go into that. And the first command it had was that, see, this is the docs do this wrapping. So the first command that they have is to try to get the REST API in order for you to download the PEM. Now, I don't want to show you my password, so I hope you'll understand that I already did this. But the bigger point is to understand that there's this API endpoint that you'll need to connect to, right? That's the bigger point. So that API endpoint is right here. And I could try to do that with a curl if I did something like, let me get rid of this URL here and append the API on the beginning and then ignore security, and then it's going to prompt me for a password, right? And see, it's going to, let's see if it will let me do it this way. I think it's going to require, cannot authenticate. Okay, hold on. I think it needs to have an @internal.
I'm just going to pause
Yep.
you there for a second. Your terminal's kind of blurry. It's like you've got one thing in the background and...
Oh, you don't like the, the transparency?
Okay. It could be my eyes again, but
I like the transparency because then I can see while I'm typing notes behind. No worries, I'll change it.
It might be just a preferences thing.
Yes. No transparent background. How about that? Is that better?
Yeah, the transparency is blurring things in the video a little bit. Yeah, that's much better. Thank you.
No worries. Okay, so I did do the curl command, but I didn't include the password, just for security's sake. So you can see all this gibberish is what the API returned, and that's what you want to see. You want to make sure that your command works. But this is the first thing that you'll notice is that Overt, by default, has this admin @internal that's needed for the API and that's not clearly documented. So if you bump into that, just make sure you have the @internal. It is in our document on OKD's website, but just make sure. Now the next things, and this verifies that whatever you're installing from has access to that Overt manager that you should already be able to access. Now the next steps are where you will make sure there's some free IP addresses on your network. So this is assuming that you have access to like a subnet. You will need to have 3 IPs at minimum. Those are used for the DNS, the internal DNS that the Overt OKD uses. The OKD uses on Overt. It is for ingress. That's the second IP is for ingress, and the third IP is for the API, the Kubernetes API. So those are the 3 IPs. You just need to make sure that they're not used, and there's an ARP command to make sure that they're not used. The second thing is to make sure your DNS has got the 2 entries that are required now. So there's been some changes in which DNS entries are required, and this may have been talked about a little bit in the previous discussions, but it's been ramped down. We used to require, for example, and some installs still require etcd entries in DNS, but the Overt install does not require that. It just requires these 2. So I put in my ones that I'm going to use are called api.okd4.lab. Let's see if that's going to return. Yes. So that's the API, and I've reserved, and DNS has this A record entry. So this is a nice test. Now I had some issues with the DNS server that I'm using for the apps, or what's used as the ingress. I don't think it's resolving correctly. I tried to fix this earlier, so we're going to see if my DNS server is cooperating, or we might have to stand up a new DNS server to complete the installation. But those are the only 2 DNS entries that are required, so that's good. The third one, it makes a note that you don't actually have a DNS entry for it because it becomes the DNS server for the cluster. Next is the install doc jumbles around. So now we're back to the overt manager, the curl command that we issued before, and now we're actually going to get the certificate from it. So you'll notice that there is a certificate because this is an HTTPS connection, and that API back to overt is going to be communicated by the OKD installer. So we're going to have to trust that certificate somehow because it's going to be interactive. So what the installer is saying is you need to download that PEM, well, the certificate in a PEM format. So that's what this does here. And if I just redo my previous command, this shouldn't require a password. So I'm going to redo my curl command. Yeah, I'm going to get rid of the password. It shouldn't need a password. Okay. Yep. And I'm going to whack the API. And instead, we're going to get the services. And I'm going to output it to a ca.pem. Oh, I did not close my quote. Sorry about that. There we go. So now we have the PEM file, and it looks pretty normal. There it is. Now the installer will take care of injecting that into the authentication mechanism for overt. I'll get to that in just a second because that can cause you a heck of a lot of pain if you don't get the PEM file correct for this self-signed cert. And then we changed some file permissions for that file. I don't know why it thinks it needs sudo. Aha, this is the first time it thinks it needs sudo, and quite frankly, I found out that anytime the install doc says use sudo, just don't. And also, I moved it to a different directory. I keep on doing sudo. I love sudo, but I'll show you in a second why it became a problem. Or in a couple minutes, we'll get to why it became a problem. Okay, and then I'm going to copy that PEM file that came from the overt manager into the local anchors on my box. So let me just, now this may indeed require sudo because I'm sure this is owned by root, this area down there, that etc directory is probably owned by root. And then to update the CA certs, usually that is a super user that's required to do that. So we'll do that quickly. So now what's happened is the local certs on this box that I'm going to install from my laptop locally trusts the overt manager. So that was that whole process. And you'll see, I'll explain in the installer where that fits in and why you need to do that then. The next part is an SSH key. Now the SSH keys are used mostly by folks, if you're familiar with OKD or OpenShift, it's used to log in to the actual nodes, so as the core user, stuff like that. So the installer needs it to be injected. I did this process before, but we can do it again if you think that you need it. But this is a standard SSH, generate a new key pair, run the agent locally, and then the installer can pick it up. I'm not going to run through that because I think most of us probably understand SSH and how to do it. But the point is either use a key or create a new key for the installer. That's all that is. And pretty sure I'm still running my agent. Yep. So let's just make sure. Running my agent still. Yep, I'm still running my agent, my SSH agent locally. Okay, so that's a lot of the prep work. We covered the SSH, we covered the certificate for the overt manager, we covered the DNS entries, and we covered the IP addresses. That's kind of like the prep work. Now we get into the OKD installer. You'll get the installer from the standard releases. So you can go to any of them that are listed here as assets on the main OKD releases. And I already installed this, I downloaded this, but it's the 4.5 for Linux is the one I installed. So I put that down, I put that in a previous directory I was using, that OKD4 demo, I believe is where I dropped it. Let me make sure. Yep. So I'm just going to quickly move it so I don't have to wait for my slow internet connection. OpenShift install. I'm going to move it into the current directory. And just so folks can verify that it is what it is, then there it is, 4.5 OKD, right, built on the 12th, so 5 days ago. All right, and you'll want the CLI, but we'll do that later. All right, so already got it locally, and I don't need to untar it because I already unloaded it. Now the pull secret, now this one's a little odd, okay? So when you click on, I'm going to click on this link in the doc in a new private, you'll be prompted for a login. That's what, okay? So what do you do? I don't know of a way around this, even though it redirects you to a Red Hat site. You're trying to install OKD. Okay, well, the way that I have found the easiest way to get around this is go to the developers.redhat.com site. Sorry if the URL is not big enough, but press login at the developers.redhat.site and create a new login, like log in with your GitHub account or something. That will create a developer account for you at Red Hat. And it will work with this pull secret. So again, go to the developers, create an account, and log in with that account to get the pull secret. Right? That's how to do that. Any questions about that? Because it doesn't really clearly explain how to get that pull secret. You do need an account with Red Hat to do that. And there are questions, I guess since I'm a Red Hatter, I can go ahead and answer this question. There are questions about, well, what do you do with that information? Well, if your cluster is disconnected, there's nothing that's being communicated between the two. You can run OKD and OpenShift disconnected. But the way to generate a pull secret for you, we have to have an account in order to do that. So if you have any more questions, just ask one of us. Okay, so I already downloaded my pull secret. I put it into a different directory. I think it was that previous directory, OKD4 overt. I downloaded a pull secret. And that pull secret is valid for, I can't remember, 24 hours or it might be a couple days, I can't remember. So I'm just going to reuse it from this morning. All right, so now you have the pull secret and you have the OpenShift OKD installer from OKD 4.5. Now it's the time to install. This command will not work. Let me just restate that. This command in this doc will not work. So I'm going to show you. Here we go with the doc bug. I'm going to show you what does work. If you were to run this command, let's just copy and paste it. It's got a line carriage, a new line separator, but I'm going to get rid of that. Let's just try. It won't work. Directory. Let's do log level info. Paste that. All right. Enter my sudo privileges. Look at this. It's a nice little interface that prompts you for overt. Sits there. Sits there and errors. Fatal. There's something about Terraform can't get authentication to some admin internal. But you'll notice the admin internal again, so it makes you think, oh, it can't communicate with overt. There must be something wrong with my overt cluster. No. This is just a doc bug. So if I rerun the command with, let's just try will work. If I rerun that command without sudo, it prompts me for my SSH key. Now, why the doc has you install the agent and then still prompts you for the public secure key, I'm not entirely clear. And then we get prompted for which platform you select overt. Aha! So it actually pulls in some information and it automatically detected the cluster name. Now, the reason I can tell it's communicating with overt is if we were to go back over to the manager of overt and we were to look at clusters, that is the name of the cluster. So the OpenShift installer is pulling information out of overt. And let's look at storage. What is the name of, what is the name of my storage? Let's look at domains for storage. Aha, hosted storage. So the OKD OpenShift installer is communicating with overt, and we can tell because it's dynamically pulling this information out. But the real question is, because I'm going to cancel out of this install, the real question is, why did this failure message happen? And it's all because of this document telling you to use sudo. Don't do it. And after we get an install working, I think I'm just going to do a doc bug live with us. Don't do sudo. It's going to bypass it. I'm going to show you exactly what it's bypassing. So here's the bug. The OKD installer needs to access overt somehow. The way that it accesses it is it creates this file under a hidden directory in your home directory, .overt, and then overt. That comes from the installer, the OKD installer. It doesn't come from overt. Let me see if I've got an old one here to show you. I don't want to show you my new one because it's got a password in it. So I'll show you an old one, and just so you can see the contents of it. See if I go up a level. Oops. I'll show you an old one of those. I copied it. OKD4. Let's see if we do overt 4.3. Do we have an old overt? Here we go. Old. I don't care showing you the old one because it's not valid anymore. You can see in this file, it's actually literally calling that API endpoint. It's got the username and password, and it has a cert bundle, all generated from the OKD OpenShift installer. And for a while, the only reason I knew this was an issue is for a while there was a separate bug where this file wasn't being created, or people were complaining that they had multiple overt clusters and data centers, and they weren't connecting to new ones. It was just using old ones. And so the way that we got around that was to delete this directory. So literally, if you have any issues with this, you can delete this directory and it will reprompt for all this information. So that's what I'm going to do. Oh, yeah, recursively, of course. Yep. So if you have any issues connecting to your overt cluster for the installer, blow away that directory and try a OpenShift install with the create. Instead of the create cluster, here's what I would recommend. I would recommend the create install config instead of cluster. This is good anyway. I'll show you why. It's not in the doc and it will still work in the doc, but here's why. So no sudo and do the install config. It will generate all of the required files. Again, select overt, and now you're being prompted for the API endpoint. Now that's where you have to enter in the overt engine I'm having to copy and paste it because it doesn't know, it doesn't have that file anymore. It needs an API endpoint. You can say that it's trusted, but it's still going to prompt you for the certificate bundle. Again, I'm not, if anyone knows why it prompts for that again, that might be an interesting thing to look at. Hold on just a second, I need to copy this. Oh, that's the pull secret. I need to copy my cert bundle. Just copy the cert bundle that I copied down. I need to get into the right directory. Live OKD install. Now you can see that we're actually using some stuff. See, I need to copy and paste this cert that we downloaded. Again, I know it's part of the local trust, but this is what it needs. So 2 empty lines at the end. This is a little weird. You paste. Did that paste correctly? See, here we go with bad pasting. I copied the begin certificate, but I don't see the begin certificate. We'll see. We'll see if it errors out. So you got to enter in 2 empty lines. Okay, there's the begin certificate. Admin internal is the standard unless you've changed it. And then I'm going to enter my new password. And voila, you can see home lab cluster being accessed. So these prompts, these last 5 prompts, are creating that overt YAML so that it can communicate with overt. Absolutely critical. And I think another thing to document may be to help people through this process if they have issues here. Does that make sense? Any questions about how the installer is accessing overt? No? Did I bore everyone to tears with that?
You did not bore anybody to tears. We're all just thrilled at your enthusiasm.
Okay.
There was an earlier question Mike asked, and you may have answered it, but about the storage requirements that he'd always seen each node should have 120 gigabytes. Any comments?
120 gig per node, I think is what he's referring to, right?
Mm-hmm.
Yeah. So how much of that is actually used on a node? I've gone down, and I think I've seen as little as maybe 30 gig actually used. So if you set up the VMs as thin pool, then you can gradually, you can grow that disk over time. That's the nice part of that. And you don't have to thick provision 120 gig for each node. But yeah, it's a bit of a heavy requirement for those nodes. But yes, to get full support from Red Hat, it's supposed to be 120 gig. But for OKD, yeah, use what you have.
We've been having an emphasis today a little bit on the cheap side of things. Where
Yes.
can we run and deploy OKD the cheapest, whether it's DigitalOcean or a cheap version of AWS? It's been a running theme, so thanks. There was also a little bit of conversation about the pull secret use, and Charo was mentioning that he uses Quay.io account for that, and then I think Christian was
okay.
saying that you don't actually need full secret. You can use fake. I think we did that in one of the other demos. We just fake it out. So
how do you fake it out?
Christian, you want to pipe in here?
Because the Quay.io images, you'll still need to pull them down somehow. Are they entirely public? Let's see what he says.
So I think the usual Quay, if they're public images, they don't need a pull request, a pull secret. And the pull secret you have to add into the installer really is just for pulling the images from Red Hat. And in the case of OKD, everything's on Quay, so you don't need it. So you can really use a fake one. So you can use, because we haven't disabled the functionality in our installer fork, because we didn't diverge from the OCP installer too much, you can really use anything in there. It just has to be a proper JSON blob with like field auth and then one auth field. yeah, what Charo just pasted in the chat. But it could be, you know, it could be auths, it could be, and then, you know, fake could be anything. Then it has to have another field auth, and in there could be anything again. So, yeah, it's really just.
I got you. So do you inject that pull secret into like the install config YAML, and it could be just a standard Quay.io? Like if someone were to go in with Quay.io, they just use it.
Oh yeah, definitely. You could put in your Quay.io one there, and then you could even pull. If you change the payload references to a private image, you could use that with it.
Okay.
But you're not required to put it in or to put in a valid one for the OKD use case, because all of our images are actually publicly pullable without.
Public. Okay.
Yeah.
Yeah.
Wow.
The fake pull secret didn't work for me for mirroring. And it's been a while since I tried it with the fake one again, so maybe it does work now. But that's why I started using my free Quay.io account. You can actually generate a Kubernetes pull secret from your profile in your Quay.io account, and those are free to set up.
And that is probably because you're not using it as a pull secret. Then when you're mirroring, you're pulling, but then also pushing again to Quay. So you need your own valid secret to pull to your Quay account. At least I would assume that.
Oh no, the push was to my Sonatype Nexus. So yeah, I did have to include a secret for my Sonatype Nexus too, so that it could push the images into the local registry.
Okay, I'd have to investigate why that didn't work, but that's actually kind of an open thing right now. We have to clean up a little bit, because it's, first of all, it's annoying to have to put that in there, the fake one, if it's not really used or needed. If you put in the normal Red Hat pull secret there, OKD will actually send telemetry to Red Hat as well. It's not a lot of data, but it's like a bit of data. How healthy is the cluster? There's no, you know, personal information, but some people may still not want that. So we've definitely at least enabled folks to go without any you know, calling back to Red Hat by using that. We opted to not pull that functionality out completely, to not diverge too much from the upstream from the installer.
So at least on the Red Hat side, I can't say entirely what's possible, but for like super secure customers who don't want any phone homing at all, one way to not do the telemetry is we have an entirely disconnected restricted cluster. So that involves not only the install is mirrored, but then they might have a proxy that intercepts any outbound requests that the cluster is making. And then it can't go back to Quay or Red Hat at all. So that's, but you have to extract everything, the OpenShift installer and everything from the mirror. You can't, I saw some people that were doing it and they saw things still going, phoning home. It's because they didn't extract everything from their local mirror. I did notice something though. Mike Rochefort said that, asked, would the registry Red Hat IO images, you wouldn't have access to those Red Hat specific images, and that is true. You can enable that back into an OKD cluster. You could inject a Red Hat username, password, or token back into the cluster, and you would have access to the Red Hat images. But yeah, the registry.redhat.io images, I think, you wouldn't have access to them without a login.
Yeah, that's right. And that's also the reason we don't currently support the bare metal IPI path, because we don't have public images for those. They're all rel based, so you need that pull secret. And yeah, we've been trying to get the IPI, the bare metal folks to release something either on top of CentOS or Fedora to make that install path work as well. But yeah, there's a few limitations. You won't be able to pull any operators from Red Hat or anything without the Red Hat pull secret.
There's another question, Diana. I don't want to take over your
Nope, that's okay.
scanning of the chat, but there was a ask about, can you just do overt and secure and then don't have to worry about the CA cert? So a couple of months ago, back in the OKD 4.4 beta days, I did try that. And if I remember correctly, it still didn't work. The installer would still fail out. I don't remember exactly where it would fail, but I don't know if that's something to do, and maybe they changed it in the OKD 4.5 and they fixed it. Ovid, you could retry that. It is an option, but it did not work for me. All right, so we have 10 minutes, which means we must have an install. Okay, so I'm going to move forward. Okay, so we're going to select the storage, and I'm actually going to select this overt management. That's not what you're supposed to do, but I currently have an issue in this lab with the typical VM subnet. Anyway, we'll get it around that. Now, these are the 3 IPs that need to be reserved that I talked about earlier. So I know what those are off the top of my head. They're in the 10, and the API is. Actually, let me make sure. I said I knew, but I probably don't really remember. Was there? Did I see this? Tunes. Is it not returning an IP for me? Oh no. Did my router bork supposed to be there? Did I typo something? OKD4.lab supposed to be there. What about int? Is it there as well? Or is this not? Well, something just changed. Let me. My lab uses syntax error. What did I change? I shouldn't have changed anything. Try to restart. I'm using it in this lab. I just have pfSense running with Unbound as the DNS, and I obviously made a change right before I went live with you all, so apologies about that. Okay, resend it. Okay, while that restarts, let's move forward because that's the IP that's going to have to be is the 199 is what it's supposed to be. Let's move forward. 199. DNS is supposed to be the 197 is what I had reserved, and the ingress is supposed to be the 198. I just bunch all 3 IPs together, make it easier for myself. And lab is supposed to be the base. OKD4 is supposed to be the cluster name. And here we go with the pull secret. I'm actually going to use my actual pull secret that I got, but nice that we have these options. That's really, I want to try the quay.io option, so there's not to have to log in to Red Hat. Thank you for that. That was awesome. Okay, I'm going to insert that. Oh, wait. What? Oh, I had a typo. So we have some validation going on. Well, that's good. Did I really typo that? Oh, yeah, I did. No one caught it. I was typoing. Sorry. That's what happens when you do things live. That's how you know that it's real.
And we distract you by asking questions.
No, it's all good. 199.2.168.2.197. And let's type it correctly this time.
And if we go over a little bit, don't worry about it.
Well, I'll at least get the VM starting up in overt. That should happen. That shouldn't be a problem. All right. So it generated our install config. Oops, will work. Right. Voila. So now what I want to do is just start. Now, the reason I showed you that is because I wanted you to see that it really did create this hidden directory that you'll want to just verify the contents of so that you can get your overt working. But now I'm going to run the OpenShift install create cluster using our directory will work, being optimistic. And I just like to set some info level. So it's consuming the install YAML. It should go a little bit faster. Okay. Ah, it's using a cached image. Okay, good. That's from my previous attempt. So it's already using CoreOS 32. That's cached locally. That's good. All right, so now it's going to make the calls out to overt. And we should eventually start to see the manager. If I go to VMs, it will eventually start creating VMs there in overt. Yep. And I think as soon as we'll have to wait a couple of minutes for it to start creating the VMs, but we have what, 6 minutes left, Diane? Anything else? Any oddball?
Yeah, you can go a little over. Everybody's run a little bit over today, so don't worry if you need it. We
Well,
like
I'm thinking if I've done, see, this error is still here in my DNS server.
Mm-hmm.
Oh, well, that's not supposed to be there. Is that there?
We do like proof of life.
Living on the edge. I was futzing around with my DNS server right before the call today, and I wonder what just happened. Else. And my DNS server is going to have to stay up for the OpenShift install to actually make a call out. Let's see, is it still running? Yeah, okay, good. Well, that's cached probably, but sending a request. Open this again. That's doing. Very slow. Something's going on.
Well, yeah, the gerbils are running.
Well, that kind of latency
Didn't happen.
is not good. Okay, well, unless my router starts to crash, I do want to file that doc bug. So I do have a question. What's the best way to file a doc bug against OKDs? Is it there in the installer? Does it say contact us somewhere in here? It says ASCII binder was used.
So Christian, where would you like him to log this?
For the don't use sudo, and also how to troubleshoot overt connectivity.
We've been opening most of the issues on the OKD issue.
Yeah,
project.
I was going to say, just open any issue you find on the OKD OpenShift/OKD in the OKD repository, and we'll work out how to find the proper place for it and refer it there.
So you could file a live issue.
I just want that sudo removed. I don't remember it being there before. Okay, so OKD. Oh, document still referring to OKD. Okay, so I'll tag it as kind documentation. Okay, I can do that.
There you go. And you know what? That's almost a great way to end a live demo on, is filing an issue, because it's a wonderful community thing to do. And we'll
I really wanted the VMs to start coming up, and before we totally signed off.
That's okay. So we may bring you back again to do this. another day.
Give me 5 minutes. How about that?
I'll give you 5 minutes, absolutely. And just tell Waleed and Joseph, who are logging in now, that we're going to be about 5 minutes late. And so just take a breather.
Yeah, we can see.
Okay, cool. Hey, Joseph.
We'll blame Justin for our demo.
Yeah, for messing everything up.
Hi.
So while he's doing that, I will make a pitch again in the chat. So if you're listening in today and you want to get involved in the OKD working group, please, you can go to okd.io and find all the links there too, but you can also just go direct to the groups, Google Groups for OKD working group, and join in there and post any questions. That's also where I will be posting the links as the videos from today go up. So there's another reason to join there. And then the Fedora calendar is the other place you can go to find out when we are meeting to chat about stuff and to work on things collaboratively with the Fedora community and others. So please do check out and sign up for our calendar.
Yeah, maybe I can say a few words on our roadmap again right now, because I'll have to drop soon.
Okay.
But yeah, as long as
keep finding that bug. Keep finding the bug.
Figuring out things. So yeah, it's just hooking into, we want to collaborate, and we really do want to collaborate as the working group with not only the Fedora community, but all the communities that are interested in, or all the individuals that are interested in joining in. And so what we've planned is to work closely with the operator SDK team and all the people that develop the operators, to get them to release their operators in a way that it works on OKD. And also we want to revive, well, that is again Fedora, a little bit more Fedora specific, revive the container special interest group in Fedora to make more Fedora-based containers, which will obviously run well on Fedora CoreOS, and make those the basis for some operators too. Yeah, and so any community you can think of, please do invite them to our working group meetings, and also individuals that may want to contribute. We're really interested in growing this in a collaborative way, and just in general making what we've been showing today even more seamless. So we're already at a really great point where all these platforms work very, very similarly. So the installation process is almost the same on all of them. And we really want to get that even more, make that even more seamless, and just, yeah, improve on all the things. So that's just me saying again, please join the working group and bring your folks as well.
Yeah. And Mike, you were asking about the container SIG meetup. I haven't seen any action on that. I have been on vacation for a couple of weeks, so I haven't looked, but we were going to try and spin that group up again, or get them to spin themselves up again so we could participate with them. So I'll check back in with them and see if we can't get something going with the Fedora container SIG group. How are we doing there, Justin?
It is working. So the VMs for the masters are coming up. They're booting CoreOS, and they're starting the bootstrap had already come up. And I also filed that doc bug. So right under time.
Awesome.
Thank you all for giving me a couple of minutes to share this with you. And it really is awesome to see the progress here. I mean, we really didn't even have much to install with Overt until 4.4, so this is really awesome.
So there's one last question for you from Aaron. He's asking, is the lab storage on SSD?
So this lab storage actually has spinning Rust with an SSD in front of it. So it has an LVM, a DM cache to accelerate. I guess people call that an accelerator in storage world. Yeah, you can't survive any of the etcd requirements if you don't use at least SSDs. I think that is made mention of in here in the document. You click on this etcd backend performance requirements. There'll be a link to some testing that some IBM folks did and what the Kubernetes folks said for requirements. And the general consensus is you can't get to that kind of speed without at least SSD or NVMe. Good question.
Well, thanks again.
All right, Diane. Yes, thank you.
I totally, my hat's off to you. My red hat somewhere behind me is off to you. Taking on the challenge today. We've got a new challenge coming up here. I'm just going to pause the recording for a second so we can have this in.
Recording has stopped. Recording has started.
And, now up next is vSphere. And Walid Shari and Joseph Meyer from the OKD working group have taken this one on, and they've also taken on Azure, so they're sort of back to back with this. So I'm psyched to see this. So if you want to share, Joseph or Walid, whichever one of you is going to drive to start with, share your screens and take over. That would be great. And Walid, we say many thanks. I know this is a time zone challenge for you, and it's becoming a time zone challenge for Joseph. So
I shared my screen, but I don't see anything.
I can see someone says that they're sharing their screen, and I'm seeing somebody's screen, but it just says sharing screen. And then
it says sharing screen. But
do you have a split screen set up?
Yes.
That might be what's going on here.
Let's start it then. Okay, let's go back to mirroring.
But definitely it's your screen.
There we go.
You can see my screen?
Yep,
yes.
Display mode is there.
Oh, okay.
I can now see the chat. So if you want to share your slides, terminal, whatever you're going to start with. Yeah.
So are we going to start? What's our cue?
That's your cue right now. We're live. We've been live since 6 a.m. my time. So.
Okay, good. Okay. Hello, everybody. My name is Walid Shari. I am basically a community lead of two groups, the AWS for the Eastern Province in Saudi Arabia and the Docker meetups. I like community and I like sharing, and this presentation is about openness, OpenShift, OKD, and my mentor is Joseph Meyer. Joseph, do you want to present yourself?
Yes, I'm Joseph Meyer. I'm a cloud architect and evangelist at Rodi & Schwarz in Germany, and we are using OKD3 since 2 years, and we are excited that OKD4 got released a few weeks ago, and yes, we are trying to get a live installation on vSphere for you.
Okay, so this is mostly hands-on. We will start with the vSphere first, and then the next hour we'll start with the Azure. But that's because it will take some time. We decided that we will show you something running first. So what we are expecting after the installations. So we're expecting to see basically this console, the OKD console. And if you click on Administrator Home, Overview, straight after installation, you should have the cluster ready, the control panel ready, but we didn't include the operators from Red Hat. So you have two operators regarding Red Hat sample and OpenShift samples are not done, and the storage is not done. That's why it's degraded. So this is what you expect at the end of the installation. This installation was done on 1, 2, 3 master nodes and 1, 2, 3 worker nodes. And you can see the specs of these nodes. This is the OKD console view. If you want to look at the vSphere console view, you can see that basically we have these VMs and we have a bootstrap node. It's not needed actually now. We can just power it off. I hope I power off the bootstrap, not the vCenter. Okay, good. We used bfSense, but it actually delayed us. It caused so many issues, so we dropped it. So that's what you should see from the vSphere. You should see the VMs, and you should see their IP addresses because they have the VMware tools built in. And one important component of the installation is the load balancer. That's how the load balancer should look like, and that's the endpoints at the end of the day. If it all looks green, that's good. But if you can see that the load balancer already has the bootstrap also, but it doesn't matter. And the ingress has just needs 2 nodes. So there is one node which is not participating in the ingress, which is okay, fine. So that's what we're going to see at the end. Okay. Now, what's the plan? The plan is that we start the installation and then we can talk about it. So we need to go to the console. So I have, so everything, we try to do everything, me and Joseph, from the documentation. So you have to start with OKD.io, basically, and you go to the documentation. The documentation will point you to a GitHub, GitHub repo for the OKD. Yes, and on the OKD, there's guides, and under the guides, there is user provisioned infrastructure, vSphere Terraform. So this is one of the installation that is when you provision the infrastructure using Terraform. The other installation, which is, go to the slide. In any OpenShift installation, OKD installation or OpenShift installation, basically the installation ends to be OpenShift install, create cluster. That's it. Yes. So that's as simple as it is. But different environment will have certain different prerequisites. So that's what we're going to take care of. So let's go now and see. So I have here, if I want to do OpenShift create cluster, OpenShift install. First thing, check, especially if you're running OpenShift and OKD, check if you have the right OpenShift install. You could be running a different version of OpenShift install. So the first thing that hit us before is which version that we're using. And I just say create cluster. I prefer to give it a directory where it saves its artifacts. And in this directory, I already have an OpenShift install. This OpenShift install has my environment. Okay, so let me not run it and show you my environment, how it looks like. Oh, sorry, it's install config.yaml. I put so this is a YAML file, but you don't need to worry about it because this gets generated by the installer itself. Okay, we can generate it. So it asks you things like, for example, if I'm installing on vSphere, you need to know what is the vCenter, and you need to know what cluster you have inside vSphere, what's the data center, what's the data store, and if you want automated install, what is called infrastructure provision installation, you just give it 2 things, the ingress VIP and the ABI VIP. And these are floating addresses that will be maintained by KeeperIFD. Of course, you need the administrator. You need certain privileges. You don't need full administrator privileges, but I'm using full administrator privileges. And you need the SSH key so that you can do some troubleshooting. I actually done extra step that I am using, so just in case the internet or QA goes down or there is an issue or there's contentions. So I'm doing also an offline registry. This is this section. Okay, now.
This is optional. You don't have to do that, but
yes.
at least in lots of company environments, I think you will mirror the images just to have them in place and
yes.
are not dependent of external registries.
Yes. So if I run the installer, okay, because the file is not there, actually, I copied the wrong file there. It will ask me these questions. So it will ask me which public key I need. So I don't need to write any YAML. I just select which key I want to use, what platform. So basically, it's the same for any other platform. I'll select vSphere. Keep me honest, Joseph. vCenter, so it's vcsa.lab.local. This is a home lab, one machine, Dell R620. A username, administrator, vSphere.local, and password. Hope I get it right. If I get this right, it will connect to vSphere. Oops, I didn't get them right. Likely it's the password.
But you could also use the install config YAML, I think, and
yes.
It won't ask you.
Yes.
But it's good to see the questions.
If this fails, we'll use the. Okay, it's connecting. Oh, it failed. Let me find the password. Maybe I forget the password. Yeah, it's correct. Okay, last time. The live demo, so this is expected. vCenter, server appliance, lab.local. Beta. Okay, yes. So it was the password.
So it's talking with vSphere and shows you. Yeah.
Go ahead. Go ahead, Joseph.
So it's the same for Azure. If you entered the credentials, it will connect to the system and provide you with information. At this step, you can be sure that the connection is stands, and
yes,
you can proceed.
So so in my data center, I have 3 data stores. I have one Kubecon, which is basically empty now. It's an SSD disk, around 890 gig. Okay, so I select this data store, and then it will ask me about the network. Again, as Joseph said, it gets this information from the vCenter. If I look at the vCenter, I have these networks. So basically, I will select this network OKD. Okay, I need a floating IP address, and this IP address should be non-used, floating. So this is one of them. And I need another IP address for the ingress. So this is the other one. Now, this domain is my home domain. Local and cluster name, Kubecon. Let me. Okay, so it's Kubecon. So I get it from the DNS. It's Kubecon 2020 EU. I will tell you why I need to get it. I need. Oops. Or Kubecon. What was it again? Sorry. We get it. Grab API from the DNS. Just to double check. So it's Kubecon 2020 EU. Kubecon 20 EU. That's my cluster name. Full secret.
I saw the fake secret in the chat. You can take it from there.
I don't see the chat. Okay, good.
I can.
Where is it? What is this full secret?
I will paste it.
Okay, I have it here. So I have this document always.
Yeah.
So the full secret is just fake. Unless you want the Red Hat operators, you can put the full secret from try.openshift.com. Now, this will start the infrastructure provision. We have been trying it. We have a problem with the virtual IP, the ingress, but several people on the Slack have success with it. So you see now what it's doing. It's pulling the image. So you don't need to do anything. You just sit and relax. You just basically fill the information. You didn't even touch the YAML file. And you sit back and relax. And it will pull the image. And it will create the infrastructure. So it will pull the image and cache it. So if you do another one, most likely it will not be doing it. And that's what happened here. It's reusing my old image. Now it will create the infrastructure resources.
Don't get confused by the message that it's pulling an RHCOS image. It's in fact, it's a Fedora CoreOS image. So messages misleading.
And if you see here, it created the folder. On vCenter, it created the folder. And in this folder, there is a template. It's powered off because it's a template. It's not a VM. And from this template, it will start cloning what machines are required. So because I didn't customize it, so by default, it will create 3 masters, and then it will create 3 worker nodes. And of course, it will start with the bootstrap. Okay. If we go back, okay, it's still creating the resources. So let's go to the slides.
You could show maybe in vSphere.
Yes.
How it creates the resources in the vSphere folder.
Okay, it started. So it started. It created the bootstrap node, which is the most important node to initiate the cluster installation. It's only required during the cluster installation. It will run the etcd, which is the key value data store that keeps information about your cluster. And then we'll start the 3 masters. Okay. Later on, it will start basically the worker nodes, because the worker nodes depend on the masters to start. And for this, the only requirement for this installation, the only requirement is just 2 entries on your DNS. Okay, and this is all in the documentation. In 1 hour, I cannot really tell you much, but in the resources, I have basically asking you to join DevNation or join OpenShift TV. They have already created several videos and several blog posts regarding the installation steps and the different options that you have.
Walid, should we delete it because we know in our setup it does not work? Should we show as installation with Terraform because maybe you're in luck and get it running?
Yes, but I just wanted to show how easy it is, this one. Okay, and so it will wait until the bootstrap completes, but let me delete it as Joseph said. So the deleting is very easy, actually. You don't need to enter any information. You just say destroy, the same command. And this is good because basically it cleans up after itself. So you can see now, I don't have the VMs. I just have the template. And most likely to remove this also. Okay. So this is the easiest way to install OpenShift on vSphere. Okay. The other way, as I showed you in the documentation in GitHub. Okay, where is here? Using Terraform. So Terraform is a very popular infrastructure IAC, infrastructure as code tool. And instead of provisioning the machines yourself, doing the template and cloning them and whatever, you just enter the information that you require, and it will install it for you. What is the information? It's exactly the same as we saw before. The cluster ID, the cluster domain, what kind of base domain you have, what is the vCenter server. Well, here it's called vSphere server, but it's actually the vCenter server. the vCenter user, which has certain permissions, and these permissions are defined in the documentation in OKD.io. So normal stuff, okay? Now, what is not normal? It needs the bootstrap ignition, control plane ignition. So this is basically the OpenShift install program that will give it to you. Okay, let's go. And we have a cluster, by the way, running. So we need to destroy it also. So if I go to the probably 0. So this is my Terraform directory, and I have a cluster running. So what I need to do, I need to delete it. And I delete it this time using Terraform. Terraform destroy, auto approve.
So it's a you should take care about sometimes to delete also the Terraform TF state file where Terraform stores the state. We had a few moments of trouble with that. If you don't delete it, then Terraform will have something in the history and sometimes complain about it. It's good to know that the OpenShift installer is also based on Terraform. So if you want to customize something, you could, in theory, change the Terraform files. They are in the OpenShift installer repository. Build it, and you have an installer exactly matching your infrastructure. That's one nice thing about the installer.
Yes. So as Joseph said, my first initial try was with Terraform. And I had several issues because basically the Terraform assumes that you have a cluster and I just have one host. So to solve this, I added the host to the cluster, and it assumes you need resource pools. And to have a resource pool, you need more than one host in a cluster. So what I did, I enabled DRS to basically get over this requirement. But because I was playing on and off, there is a file, terraform.tf state was created, and I had other issues, and I couldn't solve them. So basically, Joseph showed me how to do it. Just if you have a Terraform, delete the state file or make a backup and start fresh. Terraform is a declarative tool, but we have found out that there are some corner cases, and you don't need really to learn a lot about Terraform. All you need to do, now if you go back to vCenter, we'll find that basically our cluster is done, and this is the other cluster we're using the IBI. So now we can start a new cluster. Okay. So what we need to remove, we have certain files that are hidden. I need to remove this. So
it would be good to know. It would be good to know what the purpose of these files is, because if you don't delete them and you call the installer twice, you also will have trouble that your install config change won't be recognized until you delete these files. And they are hidden, so it's very easy to stumble about above that. You just delete them in the start, and you're fine.
Yes. So the log file is the log, all the log file from the previous state. Terraform TF state is the most important one to delete, and the OpenShift install state, because also there is certain things related to certificate. If I believe that, especially if you cross the 24 hours, that might cause you installation issues. Okay, now I have deleted the files, and what I need to do, if I am starting from scratch, I need to add the context of my environment in terraform.tf vars. What's this context? This context is basically, again, the cluster name, what domain you are going to use, what's the cluster domain, the vCenter credentials, and the vCenter name. What data center you're going to use? Okay, it's correct. Here, the data store is saying SSD01, which is okay. I have another one. And what template you're going to use. And this template, you need to upload it actually earlier. Terraform doesn't upload it for you. And you need to upload it to a content library. So if you go to the vSphere, and if you say content, okay, maybe it's easier to go through the menu. And if you say, where is content libraries? Yes, content libraries. And you find basically I have uploaded the template here. Okay. Now, one section is that it requires an ignition file. So this ignition file, you need to create them using the OpenShift install command. Okay, we are fixing MAC addresses because we need to use DHCP. So the prerequisite for user provisioned infrastructure, you need to have a certain services around it, which are DNS for the host names and DHCP, so that basically you can map MAC to IP addresses, and you can have exactly. Yes. So what we are missing now in this file is the ignition files. So how are we going to do this? Again, using the OpenShift install program. So if I say OpenShift install on, okay, I was trying to get my history, but OpenShift install.
Create.
Let me, I can, sorry, oh, okay. Basically, it will ask me the same question, but if I have a main, if I have an OpenShift, I can get the other one. Okay, let's do it. OpenShift install, create, install
configs.
Sorry?
With S. I think.
With S.
Yes, I think so.
I have one. I have one.
There's a backup. Yes.
Yes.
One nice side effect is that the installer will delete your install config YAML for some reason. So you should take a backup of that before you call the installer.
Yes. And let's reduce the compute to 2. Just in case. And yeah, it looks fine. Home lab. And the okay, it looks fine.
The SSH key is okay.
Yes.
So we can SSH into the VMs, okay?
Yes. Okay. So if I have the install.config, I just run the installer, which is again OpenShift install create. So this time I need the ignition files so that my Terraform can consume them. Create ignition files, correct?
Configs instead of
configs,
files.
Ignition configs. Yeah, make me honest. I don't need to install specify directly because basically oh, okay. So there was the ignition files here. I need to delete them. Let's delete them.
Also the Terraform no.
Yes, was
no,
warning
sorry.
me about them there. Yes. So let's delete them and start from scratch. Okay. Now what's the result? The result is the ignition files that were created. If you can see, so I have the bootstrap ignition file, master ignition file, and I should have worker ignition file. Yes. Now, what is this ignition file? Think about it as a way to tell the Fedora CoreOS how to configure itself. Okay. Now, I need to...
It's applied to the VM in the first start. Fedora CoreOS will wait for ignition file, and we provide it to Fedora CoreOS through Terraform. There is a specialty on vSphere. vSphere does, because the bootstrap IGN file is rather big. I think it has 200 kilobyte, and it's not possible to provide a vCenter with such a big ignition file. That's why maybe you can show this short ignition file, Walid.
Yes, I can.
There is
one trick I do when I copy the file. I copy extra characters to make sure that I copied the right file, because sometimes you think that you copied the file, but you didn't. You didn't. So, oops. Okay. Sometimes I add characters.
You have to provide a chain of ignition files for the bootstrap. Can you show that again, Walid?
You want me to show the ignition file, correct?
Yes, no, the Terraform TFOs.
Okay, yes. Let me get the worker file so that I can copy it there.
Yeah, okay.
So, yeah.
So as you see,
basically,
as you see, the worker and the master ignition files are very short. The same is for the bootstrap IGN file. And the reason is that in the ignition file, there is a source defined. Maybe you see it in the first line. And this HTTPS address is at least for the ignition, for the bootstrap ignition. Maybe Wally can show it in a second.
Yes. Okay, again, the same trick. I copy extra characters just to make sure that I have the right file. And here's the bootstrap ignition. It's really long. Okay, and it's in base. Actually, it's not in base 64. It's JSON. So if you want to look at it, use JQ dot, and you can look at it. And it has all the information that you need. So it has basically what kind of ignition file. Now, Fedora CoreOS uses version 3. OpenShift uses version 2. So basically, be careful with this. I don't know why it adds another key. I guess this is a cluster key, but that's my key. And this key, I'm not sure what it is. So it has all the information it needs to configure the Fedora CoreOS. There's a base 64 or there's certificates.
There are lots of files. Basically, there are lots of files and their content. Yes. They are written to the FCOS directories as a storage, and there are also defined some services that are started automatically on the first boot. And Walid, maybe you can show, because I tried to explain that since a few minutes. Maybe you can show the Terraform TF files again. Yes. Can you show the ignition file? There's a bootstrap ignition.
Yes. So the bootstrap ignition, because it's big. Go ahead, Joseph.
Yes. Because the ignition file for the bootstrap node is so big, you have to provide it we use a web server for it. That web server can serve this ignition file. And the bootstrap node will only get this small, you see it here on line, starting at line 43. This small part tells ignition that the master ignition for the bootstrap again will be served from this location. And you have to provide either a GitLab repository or a web server that serves this file. And with this way, you can provide the vSphere VMs with a very small ignition files, but the big ignition file will be pulled afterwards in the second phase from the web server.
You don't need a full web server. Some people just do a Ruby or Python script to serve this file, but whatever floats your boat, basically. But that's good because, for example, if Joseph didn't tell me about this, I would have forgotten to copy the bootstrap.ignition file to the web server. And that's one step you need to do. And an extra step you need to do is that curl it. So you have, and don't curl it from your, from your memory. Just find it and use the same command that is here, same URL. To make sure that basically, because this is the most important one, this is what triggers the whole installation. If you cannot get to this file, the whole installation will not work, basically. Where's the file?
It's not copied it.
Oh no, it got stuck. The time, okay. But live demo. We're expecting this. Okay.
Is it frozen?
Oh, my machine my machine frozen.
Okay. So
let me open another terminal.
Yeah.
The beauty of TMUC. Oh no, I cannot. Okay. So I'm using a helper node, and this helper node was created by Christian Hernandez. Let me enter the IP address. Because I'm using TMUC, I can attach, hopefully. Oh, okay, I can attach. I need to reset and find out how to reset. Okay. So the ignition file works.
So we can start.
Somebody can find out how to reset TMUC to this size. It's the same size, but I'm not sure. Okay, so now what can I do? I have the ignition files and I have the TF bars ready. I can start the installation. How do I start the installation?
Maybe you should clear the screen so we don't get this character mess.
This one, it's I need the reset, TMUC reset. I don't remember it. It doesn't happen often. TMUC reset window size. So I use Google to find out how to do this. Is there any way to delete Tmax? Yes, there is. Tmax minus V. Oh, okay. Control Tmax attach minus no. And that's Control P plus Q, which makes flash number. Sorry?
There was a command detach. If you go up.
Yeah,
here it is.
Yeah. Okay, but the problem is that I cannot detach from the other one because it's stuck. So maybe I can close this.
Is it? Okay, close terminal.
Okay.
Nice.
Yes. I just need to close the other one. Now.
Can you clear the screen while it?
Because the issue. Okay.
Yeah.
Okay. So I need Terraform apply auto approve. Yeah. You can do plan if you want, but that's the quickest way. Now, what Terraform is going to do, going actually to create the infrastructure for you. It's communicating with the vCenter to get the state. It's doing the virtual machine template, checking if it's there or not, checking the data stores, doing everything that OpenShift install does. Because OpenShift install at the end of the day is using Terraform. Okay, so you can see it's creating the machines, creating a folder. Let's go back to vCenter and see if this is done. vCenter, I go to home, I go to VMs and templates. Okay, it created the folder, OKD4, and I can see it started creating the machines. Okay, just a matter of time, it will start them up.
So normally you have nothing to do with the insights, but we will show you a few important steps just in case if you have trouble getting the system running. So if the VMs are up, I think, Walid, we should start with the Bootstrap VM to SSH into it. But at first we will show in vSphere if something is wrong with the boot procedure.
So, because I spent some time on the slides, I would like to show some. It's the slides are just for supporting us while we are talking, because there's lots of things that you have to wait. So the takeaway, if you want to ask me what's the takeaway from this whole hour, the takeaway is that if I want to install OpenShift or OKD4, it's very simple. It's just OpenShift install, create cluster. What's difficult? The difficult part is if it's a user provisioned infrastructure, the user has to provision this infrastructure. How can he provision this infrastructure? There is basically the OCB helper. So if you go to GitHub and you say OCB helper, the OCB helper node, this will give you all the services that you require. So DNS server, load balancer, web server, DHCP, Pixie, and whatever method you need. And actually, if you go at the end, it have the UBI automation for vSphere. If you click on this one, quick start, this other repository, which is under Red Hat official Git repo, have all the different scenarios you might have. Do you want to install from OVA, or do you want to install with Pixie, or do you want to install static IPs? Are you in a restricted network? You don't want the cloud provider, so all the options you have are there. Okay, let's go back and see. Okay, the nodes have started. So now what we can do, we can check what's happening with the Bootstrap. Okay, the Bootstrap came up. It has taken the ignition file.
And you got an IP address. It scrolled out of the window, and you have a host name. The host name is Bootstrap, and we should SSH into it to show this two-phase installation. Oops, error.
What's that?
Oh no, the tags does not have the permissions for the tags. Okay.
Strange.
But it should work without that, I think. Normally,
the tags is for the data store. The tags is for the storage, I believe. Is it?
But I think it will work because the beauty of OKD4's installation is that it will start the VMs, they get the ignition files, and you are done. The installer, mostly the OpenShift installer, will provide you with some status message, but normally you you can wait and it will run. You don't need the installer if the resources are created. Now we will. There's a question. Yes, this fake. Yeah, I think they are working on at least a sample operator, because it's degrading after some time with this fake secret. Is it 100? 8?
It is 100. Yes.
Yeah. We tried it before. That's why I know the IP addresses. Everywhere. There is known hosts. Yeah. Okay.
So that's what you usually do, because it takes time. So basically, you try to figure out is everything okay or not. First thing that the Bootstrap needs to do is to pull images, because basically it's dependent on containers to start. So yes, it pulled one image, that's good, and it will keep pulling. How you can check that? You do BSAUX grep for Bodman. It's pulling image using Bodman. Yes, I have Bodman. It's still putting images.
It's booting in two phases before we are thrown out. It will, I think, valid. It will pull 2 images.
Yes.
In these images, there is a release payload and tools like Cryo, VM tools, Daemon, and then it will install them and it will reboot. And
yes.
that's yeah. Sorry.
Go ahead.
And yeah, and if it reboots, the first phase of the installation of Fedora CoreOS on a node is finished. And every node, also the masters and the workers, do have this 2-phase installation.
Yes.
And I think in a few seconds we will be thrown out here.
Yes. And another thing, when it pulled the image from Fedora CoreOS download the CI server or from the download site, it pulled the latest image. But each OKD release has a specific image to it. So if it needs to upgrade or downgrade, you will see that basically it will take care of that. You don't need to worry about it. Because sometimes in other different installations, if you are not going to use the official OKD repository, some other instructions will ask you to download. Like, for example, this is Greg. He's also from the OKD working group. He has instruction that you have to download the image, and you download just the latest image. Don't worry about it. Okay, let's check the masters. If there's the master will not do anything until the boot the bootstrap is.
You could show the masters what they are doing.
Okay, now. So there is lots of errors, but that's fine, because the way the control cycle in Kubernetes and on all these systems that to get to their desired state. So if you look at the logs, it's full of error, get error, because basically the bootstrap is not ready yet. So it's trying to go to this IP address and this port, which is basically the API internal, which is the machine config server. This is where it will get, the master will get the ignition files from. Yeah.
Maybe you remember we showed before the Terraform VARs file, and we had a little stubs also for the masters and workers, and they are pulling their huge ignition file from the load balancer, and the load balancer in the beginning only contains the bootstrap node, and the bootstrap, if the bootstrap node has finished with its installation, it will serve the ignition file to the masters. And at this time, you won't see this message again, because the master will load their ignition files, configure itself, and start with the 2-phase configuration. Maybe we can show, we should have thrown out from the bootstrap node, Walid, I think.
Let's see. Not yet. Okay.
Now
you jinxed it.
just in time. Yeah.
Yes, and it's very fast to connect. I love it, because basically the 2 things I love about OKD and OpenShift, the images they use for host, the Fedora CoreOS or Red Hat CoreOS, they are very minimal and they are very easy to maintain. And you are not supposed to configure them except using the ignition file and except using basically a desired state. You are not supposed to SSH into them. Now, if you look here, this is a different version than the one here. This is June. This is July 26. This is June 29. So basically, it did downgrade itself so that it can fit to the requirements of this release version of OKD. Okay, let's do the same command again, images, and see. Okay, so we are getting more images. I think we'll get over 12, 16 images, correct?
Yeah, I think so, yeah.
Yes.
And it's good to know that in OKD and OpenShift 4, the operating system is an implementation detail. You don't have to patch hosts for security package, but OpenShift and OKD will take care about that. If you upgrade your cluster, you will get a new operating system. It's automatically installed during the update in a rolling upgrade on each node of your cluster. So you must not take care about OS upgrades on your own.
So if you look at the journal, you can see that basically it downloaded the release image, and now it's starting the bootstrapping the Kubernetes cluster. Usually the bootstrapping takes 10 to 15, sometimes 20 minutes. Hopefully not much, because basically the images, I have them close by. And if you see these characters, this is basically Arabic characters in Linux, but they are really messed up, so don't use Arabic in Linux.
What do you think about showing OC get pods? Because I think we could see something already.
Yeah, I tried. Okay, so Bodman images, I have the 3 images. So what did it do with these images? So if we check Bodman, oh, not yet. Bodman, no, write control, sorry. Yes.
Right, CTL. There is a T too much.
Yes, it's a live demo. Expect me to do mistakes. Not yet. You can do BS, but I don't think there is something yet. Change. Let's see.
It takes a little bit. It's rather slow. Or
Another image. Yeah. Let's see the log. Okay, starting etcd. That's the most important thing, because what the bootstrap will do, it will be its own key value data store for the whole cluster, and it will try to provision another cluster. So the moment etcd is up and running, then it will try to scale out to the other nodes, the master nodes. And the moment it scales out to the master nodes, they will start the machine config server, and the bootstrap node job has finished. It will basically, you can kill it then. Still the same images. So now, because it's starting the etcd certificate signer, most likely we'll find, we should see jobs. We should see pods now.
I think it will pull.
Okay. So how to start? How to start? As I said, you go to OKD.io and you get basically you get the instructions from there or from this site. Okay. Now, one of the things it will tell you, if you go to the release page, one of the things it will tell you, it will ask you to run this command, OC-adam. So you don't have OC-adam. You go to the GitHub of OKD and get it from the releases pages. So you see this is the release. And if you go down, this is all the images that are contained on the release. You'll find basically which, this is the client, which is OpenShift client, OC. So it is also OKD client. So it can be actually, you can submit a bug report that should be OKD client. It doesn't matter. Yeah. The moment you have this client, from the release page, as you saw, you run this command, it will pull the boot OpenShift install and OC and kube control. And then you are in your way. Yes. Now, this is the menu, just in case you haven't seen it in the beginning. So what kind of, you don't need to create any YAML, it will create it for you. Now, if I want to do the caching, I just set up certain variables, and they use the OC-adam release mirror. The instruction is for disconnected environment, but you don't really need for disconnected environment. Even if you need to make sure that you are not dependent on the upstream, just in case, you can mirror them into your own network. Okay. So the installation, we said there are two types. There is the full stack automation, which is what we call IPI, which infrastructure provisioned install, and the UBI, the user provisioned infrastructure, which is not fully automated. And you can see here the fully automated, it will build your network, it will create the load balancers, it will configure DNS, it will provision the VMs for you, it will do the operating system install, it will generate the ignition configs. You don't need to generate the ignition config as you saw that we had to do it for Terraform. But even in Terraform, the installer can take care of that. OpenShift, open system support. For the OKD, it's usually Fedora CoreOS. I think there are talks about CentOS, correct?
Yes.
Yes. Now, the other thing about why do you want the automation is that you can do the auto scaling out of the box. If it's user provision, you need to make sure that your cloud provider, in this case the vSphere, has the capability to do this. And I believe in 4.5 it has the capability to do this.
That's true.
So this is the fully automated install. Yes, let's go back.
Because I just want to take the chance to look inside if we have progress. No, okay.
Yes.
Now we should you can show OC get pods outside of the Bootstrap node, because now we are in the Bootstrap node, and we could do a watch maybe.
So one of the things, the artifacts that it creates this odd directory. And it has the kubeconfig, which is basically the configuration you need to connect to your cluster. So if I say export kubeconfig auth and the kubeconfig, I can see OC get bots -a to see what kind of bots. I don't have yet because it just SCD. It's still starting.
I like to do a watch on that.
Yes. So another thing I can do using the OpenShift install, I say wait for. I want to check the status for the bootstrapping. Is it finished or not? I can say bootstrap complete. Yeah. Wait for bootstrap boot. It helps if I type correctly. Yes. So it doesn't tell me much. So I increase the verbosity by increasing the log level. Again, it doesn't tell me much. So what I can do, I can actually trail the OpenShift log file. There's a log file. It will tell me what stage it is on. So it can tell me that the Kubernetes waiting for Kubernetes API to come up. So unless the API server is up, I cannot use OC, because OC is basically a client for this Kubernetes API. Everything is RESTful. Everything talks to the API. And if the API is not up on the Bootstrap, I will not be able to talk to it. Okay. So as we saw, the installer is very simple. It's text user interface. It takes the cloud credentials, the vSphere, for example, the vCenter, the administrator, what data store do you want to use, what network you want to use. And Bootstrap creates a cluster control plane, creates the Bootstrap. The Bootstrap basically creates the master nodes. So that's the diagram if you want to see. So from one machine, your installer, it will create the Bootstrap node. And then the masters will depend on the Bootstrap node to get their ignition files and to basically provision themselves into the desired state of the cluster. And then the worker nodes will talk to the master nodes. Now, the ingress for the application's ingress basically usually gets installed on the worker nodes. We'll share the slides. These slides are from DevNation, to give credit to DevNation and Barsatar and Eric. These are actually the slides from the master class for the OpenShift operators. So it tells you basically how you start and stuff like this. Okay, I don't think we will have time to do the autoscaler, so let's see. It's strange because
the pulling is rather slow. So maybe you could do a watch on OC get pods, all namespaces. So okay, maybe we see a little bit more now. Normally, you should you would see a list of pending pods. This is already good because it's talking to the API server already.
No, the API server is not up, Joseph.
Because but it responds. Does it that it
Let's
does
check.
not have
Let's check. Let's go
does
to
not have a resource.
Yes.
This message comes short before you see a lots of pending pods.
I am again on the Bootstrap node to double check what's happening. Okay, I have more images, but they are not really enough. I want to check if these images are actually resulting in container runs. I will try Control BS. Okay, that's better. So what I have the etcd. I have the etcd metrics. I have the etcd member, and I have the machine config server. That's really good because the machine config server is the one that is responsible. How do I check again? I can also check from the load balancer. If it looks green, but that's not true. If I do refresh, oh, actually I have the Bootstrap is starting to serve the ignition file to the masters.
This
So
means
if I
that
go,
the masters should be able to pull them and start
yes,
over.
they did.
Yes.
Yes.
So maybe you remember that before the masters were pulling for an ignition file, and now
Yes.
the Bootstrap node can serve this ignition file. This machine server pod is responsible for that, and the master pulled it, configured it, and now we should see something with OC-GET pods. It's the third try.
Here it says still waiting for the Kubernetes API. I believe the Kubernetes API should be ready. But it's not ready because the config what -a is not actually giving internal error. That's good.
It's switching over.
Errors are good in OpenShift, by the way, and OKD.
Normally everything is fixing itself. It's magic.
I can reboot the nodes during the installation, and don't worry about them. They will get to the same state also. So they are in a loop to get to the desired state.
Normally you can't break anything because the system will fix itself. So we were often in a situation where we thought we have broken something, but it's rather easy to fix it. And because OKD or OpenShift 4 is based on operators, operators are first-class citizens. These operators will take care about the pods they are responsible for and fix itself.
Yes. If you have a problem, you can also go to Slack, and OpenShift Dev in the Kubernetes Slack is basically where you can ask your questions when you have problems or OpenShift users. These are two nice channels. If you have OpenShift or OKD, I believe OKD is mostly OpenShift Dev, correct, Joseph?
Yes, where we are the most time.
Yes.
I think give me a fourth try. I think now we should see the pending pods. I have a strong thing. Yeah, because pulling is slow. So normally it should not take so long. You will see a list of pending pods, and then the containers will creating. The masters will configure itself themselves.
Okay, performance is okay for the Bootstrap. The Bootstrap specs is really low for CPUs, 8 GB, but it's doing good. The master, let's see actually the registry. That's the one maybe that is, I guess my registry is the one that is blocking this.
You are using mirroring?
Yes. So basically this one maybe is the one that is causing us the headache. Not really. It's
it may just take time, guys. It may just take a little bit of time.
Yeah.
So give it a little bit of time.
I want to see the pending pods.
Everybody does, yes. I want to see the OKD dashboard is my proof of life. So
that's why I showed it in the beginning, just in case.
Normally, but you can say normally an installation takes 30 minutes. If you pull from an internal registry, it takes about 30 minutes. So we were talking a little bit about the insights, because I think it's more interesting to see the insights as to have a dashboard. Because you should see what normally happens if you install it. Because normally and how to fix
So this
things.
is my home lab. It's an old Dell server, like 5-6 years old. It has 40 logical cores, and basically memory is good enough, around 320. I killed everything just to make sure that we don't have any contentions or anything. I didn't shut down. I killed actually everything. But I mean, at work, if I do this at work, it will take, as Joseph said, maybe 15-30 minutes max. If you have good SSDs, if you have basically a powerful server, this is really an old server, and you can see the hertz. It's really 1.7 gigahertz. It's very, very. It's good for a home lab. I love it. So let's go back to the bots.
But we can let it run, because we have the next platform. We will install it on Azure, and we can let do the installation what it wants to do, and look at it in the end. But could you do? Have you seen some pending pods or last try?
Not yet. So basically, if you look at let's see the logs. Still waiting for the API.
Okay.
I hope the tagging issue. I don't know why it came from.
It's taken some time for a couple of the other demos, so don't panic.
We're not panicking.
It'll come.
We're live.
I know we're live.
Yeah, you're live. If it can go wrong, it will.
Yes.
And if it takes too much time, it must be live.
Actually, I was worried that I'm not be fresh. I wasn't really fresh this morning, and I needed to do lots of stuff to catch up with the installation. I wanted to do the automated install, because I know it's doable. I know people done it, but there is something in my environment that is blocking me from doing it. So I couldn't figure it out yet. Yes. So the automated install for vSphere, very, very straightforward. You just need 2 entries, one for the API and one for the ingress, and they are floating, and they are keep alive D, and this IP addresses will travel with the nodes. So basically, you don't need to provision a load balancer, and you have to have DHCP, because it will create it will talk to the vCenter to create the VMs. Yeah, so it's really very nice. I will get it done. Okay, so what are the issues that we had? As Joseph said, the Terraform TF state. So I like this one. I like to stay. There is so many. One of the problems with OpenShift and OKD is that so much information and so much videos are there outside. But if you follow the official Red Hat and the Open Commons, OpenShift Commons, I think you should be safe, and the Slack, of course. So. And what is the difference between OpenShift and OKD when it comes to installation? First of all, the release format. If it's OpenShift, it will be 4.50 or 4.51. But OKD, you'll see this date. If I go back to the index and you see the different releases, you see basically, they are really a little bit different. Where should you go for documentation? It's OKD.io. If you go to OpenShift, there might be some discrepancies in how things are done. So it's better stay OKD.io. So this is the stable.
Yeah, I like also that you can see that change log. If you click on the version, you will see what changed in each version, and
so
also the commit message. Yeah.
Yes.
I like this. It's generated automatically, and you can see exactly the commit that leads to this entry.
And actually, you can see where can you upgrade from and what you can upgrade to. You cannot assume that you can upgrade from one release to the other release straight away. You have to check basically There is another GitHub from a Red Hat engineer who created like a chart that basically draws all these upgrade paths to you. You can see what Kubernetes release version is using and what Fedora CoreOS. OpenShift 4 is pure Kubernetes with the extensions using operators. So if you ask me why should I use OKD, because first of all, it's an open source platform. I can use it in a hybrid cloud. As far as I know, it's the only hybrid cloud open source platform that is out there, which is holistic. It will give me logging, it will give me registry, it will give me monitoring out of the box, identity, providers, you name it. It comes really, and maybe this is an advantage and disadvantages. If you need something quick and just raw Kubernetes with nothing at all, maybe you can use K3D or K3S, but then you have to do lots of stuff to get it up and running in a good shape. So, and when you see this is not really a tag that is used on the installer. Actually, when you see this one, if I go to this one, for example, and I go to Quay, or will show, I found out that if I need to do really OKD and OpenShift, they don't use these tags, they use the digest. So you have to do this trick to get to the digest. You have to go. You have to use the image, and then try fetch tag. And when you fetch the tag, you fetch the digest, not the Docker bull tag. You fetch the digest because everything in OpenShift and OKD is digests. It makes our life a little bit harder, but it's much more immutable, much more secure, much more good practice for configuration management and stuff like that. Let's go back to Joseph Bodds.
Yeah.
Can
you do an OC get?
Okay.
That's what.
Okay.
Yes. On the first try.
Yes.
Almost. Yeah. That's. Oh, we have already one running container, one running pod. Yeah. Here. Here it is. Here it is. Running. The network operator is always the first. And now, network is installing on the masters. And yeah, from now on, things will go their way.
So OpenShift Multis is an operator responsible for several networking functionality. Okay, and OVN is the actually. Okay, I need to show you this. So another default configuration between OpenShift and OKD. OpenShift will use the SDN is OpenShift SDN. OKD uses the Kubernetes OVN, which makes it easier if you are going to run Windows Container later on. So one requirement for Windows Container is to have the SDN as Kubernetes OVN, which comes by default network configuration option for OKD.
I think it's okay, Diane, if we explain that, because on Azure, the Azure installation will have the same pods. Yeah.
Well, if I go here, okay, and if I do BS, okay, so things are running. I have the Kube APIs. Okay, so the API I think is done. Yeah, the API is done. So I think the bootstrap completed. The server could not find the requested resource.
It's okay. Let it do its job. It will work. So maybe in 10 minutes we could the master as the workers will join the cluster and we have to approve the CSRs. But maybe we can in the meanwhile start the Azure installation. So maybe we could see a UI afterwards, and then you could explain the operators again.
Yes.
Afterwards.
So Azure installations. Okay. So if you install OKD on vSphere, on GCP, on Google Cloud, the Fedora core image is available there, or you can download it for vSphere, or the installer will download it. In Azure, it's a special case because the moment Azure was having CoreOS as an official image, it doesn't have Fedora CoreOS image yet.
So
the installer has in the marketplace. So the installer has a hack. And if I go back to the releases, So Joseph wrote a workaround, and this workaround was available until beta 5, but after beta 5, this workaround by mistake got out, and we have a pull request for it to bring it in. So there is yes, so there is a pull request to bring it in.
It was merged today.
It was merged, so that if we can use the. You want to try the new install?
I don't know if there is a nightly, but I think there was a little problem. The procedure, because the Fedora CoreOS image is not available in the marketplace, is the following: the OpenShift installer downloads the Fedora CoreOS image from the Fedora CoreOS site, extracts it, decompresses it, and uploads it again to Azure. The problem with that is if you have a slow internet connection, like me, and your upload is slow, then Terraform will time out. So our procedure, or the only workaround at this moment, is to use the OpenShift installer not locally on your PC, but in an Azure Cloud Shell. Because if you are already on Azure, things are much faster.
Yes.
Downloads.
So the OpenShift installer is open source for both OpenShift and OKD. The OKD is basically you have to go to the branch fcos, and that's where basically you find the OpenShift installer. And if you want to participate or help on the OpenShift installer for the different platforms. Okay, so Azure, as I said, the main thing is the OpenShift install. So I already downloaded this beforehand, and the one I downloaded, as I said, the first thing to do is always check the installer. So the version, make sure that you're not using something that you don't intend to use. Because this happens, the moment you go into different version or testing different releases, you might get messed up which release I'm using now, unless you have a system in place. So it tells me that this is from commit, because as I said, Joseph basically made the pull request. I made the pull request after him because I thought my pull request was better, but it was the same. So I closed mine. So basically this was from a pull request. It was not committed yet, but as Joseph said, it's committed today. To save us time, I will use this because I already know that this one works. And you can see this, yes? Now, what I have already clustered up as usual. So basically here. So I have one cluster up. Oh, maybe I need to log in again.
This is vSphere, I think.
No, it is local. vSphere. Yes, this is vSphere local. Yes, here. So this is the developer screen in OKD, and this is the default OpenShift monitoring. So you can see the bots, and they are not related. They are not in. So you can see them, and you can scale them and whatever. If I go to the administrator, I will see the status. Oh, that's not good.
No, but this is vSphere again.
Again? No. Oh, yes. Okay. That's why it's not good. You see the confusion when you have more than one cluster? Okay. So how do I know which cluster is up? I can, as usual, I have the kubeconfig file. So I export kube config, install directory, auth, and the kubeconfig. And I ask for the routes. What routes are there? And actually, I'm looking for a specific route, which is the console. I know what it is, but let's check. I will not get it this way because I need to ask in all namespaces in all projects.
Well, this is a pre-installed cluster, isn't it?
So this is a pre-installed cluster, just in case that we had issues.
Yeah.
Yes. So I can go here, for example. I can delete this.
So this is a pre-installed Azure,
yes.
OKD cluster on Azure. Just that you believe us that it's working in theory.
So I don't have storage configured, but I have managed premium. This is the differences now. So in VMware, you will basically you will have the vSphere built-in driver by default, which will provision a storage class called thin. If you need the CSI, you need to do it as an after step. In Azure, it will use basically Azure storage. So this is using Azure storage. And you can create different tiers. You can create different storage classes for this. Okay, so let's kill this cluster. I have to actually, and okay, I will use this time. I will use actually the Azure shell as Joseph explained, because of the uploading and downloading of the image. This could it will be faster doing it from an Azure shell. Azure shell times out every 20 minutes. So if you want to get rid of this timeout, you use tmuck. And you do watch whatever, okay? So basically you open tmuck and you just run a watcher.
Or you press enter from time to time, but this
or,
is not
or you ask
fun.
your kids to come around and press enter. Okay, so I'm in this directory. Why do I want to kill? Because basically the quota reasons. Actually, let me kill the other one, the life. So orange.
Because of your quotas, so we have enough.
I have enough now, but just in case.
Okay. Okay.
Destroy cluster minus directory. No. Oh, it's not directory. But this is how you destroy a cluster. So if there's anything you learned today, it's how to destroy a cluster. Don't do it if at work.
Alert, alert. Takes a little bit.
Usually fast. And if I go to the console, okay, I am in the console actually. If I go into the console and I check VMs, for example, I will see some VMs starting to disappear or starting to go into unknown state. So I have two clusters. One is running in North Europe, Switzerland, and one is running in East US. The one I'm killing, I think, is the one I'm killing is the Eastern, the North Europe one. I was expecting to be contention in last Red Hat Summit. There was contention in AWS regions in US, but today there was no contention. To be honest with you, it's either Azure is really good, or I was lucky today to provision these clusters. Or the quota system works because they didn't give me, my requirement is very small, 80 cores maximum, but it's like took a week to grant me this quota. Okay, let's go back to the command line. So while this is destroying, we can actually create another cluster. Okay. So you have to be careful when it comes to Azure, when it comes to your cloud, because it's not your machine. So you have, you are limited on the size, okay? So /home, which is non-persistent disk, is quite good, but it's non-persistent. Anything you put there, it will get lost if you disconnect the terminal. And /home/your user has only 5 gig blob. So my images is around 8 gig. If I look, I think, I know I don't have. Okay, actually this is, so the trick is, and it's available in the Git repo of the OKD, is to make directory /home/cache. You create the cache on the non-persistent one, okay, and you link to it from your persistent one.
This won't be necessary if Fedora CoreOS finally will be available in the marketplace. Azure and Red Hat are working on that, so we hope that in a few, in a few reasonable time, it will be available, and you can call this command from your local PC.
I love to create directories so that I can limit my devolution of my artifacts for the installations. So I create a directory, and I love to have debug level high. As I said, the key takeaway, how to install OpenShift is OpenShift install create, in no matter, is it vSphere, is it GCP, is it Azure. Okay, press enter. I'm missing something.
Create a cluster.
Create cluster. So what do I want to create? I can create a cluster, I can create a manifest. In this time, I'm using the automated install, so I want to create a cluster. So it's asking me which platform. In this time, it's Azure. Okay, which region? You have to be careful with this because there is a quota, and the default quota is 20 CPUs. This is not enough. You need at least 28, unless you customize your installation, which will. I need North Europe. Yeah, this is where I have quota already agreed by Microsoft. Thank you, Microsoft. And now this is the domain. This is another requirement. So basically, you have to have a domain in Azure in your own account. Okay, cluster name. What do you want to name the cluster? Let's name it Joseph.
Nice. Thank you, Walid.
Okay, the bull secret. Okay, the trick I do is I have this in the dashboard. So basically,
okay.
I cannot write JSON. I'm not very good in JSON. It's fake bar, that's all in JSON, but I have to put it in the dashboard. Okay, so it goes and it fetches master machines. It basically checks with Azure, do I have the credentials? The credentials was done earlier, and I'm not good in video editing like Diane, so I didn't record it. So basically, you need a certain service account with certain privileges. It's all documented. It's very straightforward.
It needs lots of permissions. I don't know
yes.
why, but
yes.
I think it's very good to have a principal with so much permissions, but it's required. Yes.
So now that's the step that Joseph told you about. It's trying to obtain the Fedora CoreOS. Forget the message, obtaining Red Hat CoreOS. It should say CoreOS and that's it. Maybe I should do pull request. And then it copies it into the cache file that we created, and it starts decompressing it. If I want to check now, we saw how we check the infrastructure one, the on-premise, the vSphere. If I want to check, I just do refresh here, and I should see a North Europe resource group. Okay, nothing yet. It's very slow. The console is slow this time, the Azure console. I don't see North Europe yet. Okay, oops. Refresh. Okay, now we see a resource group. Resource group is a concept in Azure where basically it's a container that contains all your artifacts, your virtual machine, your storage, your network, your security groups. So we see a network security group, we see a disk. Be careful with the disk. This is the one that are costly. If you are running OpenShift, select the right disk if you want to customize. These are the ones that really cost. And you can add GPU if you want, but this is another time. So it started creating the virtual machines. It started creating artifacts. I have 2 disks and I have 2 virtual machines. I have the masters.
Where is the storage account, Walid?
Okay, and what is the storage? What is the storage account? Good question. It's not created
yet. But
it should be there.
Yeah, the virtual machine is already running. There should be an image and a storage account. Yeah.
Let's see again. Let's refresh. Sometimes it's just a console. Okay, or we can straight go to storage accounts. Okay, and we should see which, we don't see the North Europe yet. Strange, huh? Maybe it's because it's still decompressing. Let's see what's happening on the shell. It's still decompressing the image.
Yeah.
So basically that's good, by the way, because it's creating the machines. Yeah, while just creating the VMs, it's not really installing them. It's creating all the artifacts that it needs before actually the image is ready, which is good optimization.
But I think, Walid, I think, no, I think the machines should be created after the image was uploaded. Are you in the right, or was it an old one? Maybe it was an old one.
No, I'm what I selected North Europe, correct?
Yes.
Yeah, so it should be. And you cannot see it here because it's not there yet. Let's do again.
Yes, because I think from the in the installer code, the Terraform starts after the decompression. So Terraform shouldn't run at all. It will take a little bit until the decompression has finished. Maybe it was the old one.
So this is the North Europe. Ah, yes. Ah, so this is the one that is deleting.
Yeah, yeah.
So no, I think it's not. I wish there is a way to say how this resource.
Because that's the reason why
you're right.
The
you're right.
Machines.
Yes, you're right.
Can we have a look if it's still decompressing?
Yes. Yes, it's still decompressing. And let's look at it there.
The download was faster than the decompression.
And the deleting is slow. Okay, so I jinxed the Azure. I said Azure was good today.
Can we peek over to vSphere?
Yes.
I hope we don't cause lots of confusion for that, but maybe we have the worker.
I'll fix it. I'll fix it in the video editing. How's that?
Okay. Okay, it's still downloading.
Okay. Take a while.
It's okay. Valid. Yeah.
But that's too long for Bootstrap.
Yeah, it's downloading. It's still downloading.
The timeout is 40 minutes, so I guess it didn't time out yet. But even if it times out, it's you can actually it's still going on. Okay. So we have Bootstrap not finished on vSphere and the decompressing of an image. And this is my fault. I should have done it earlier. If it was on the cache, and that's the difference now. You saw in vSphere, it was on the cache, so it started straight away. But here, it's not on the cache, so basically it's taking its time to get the image and then decompress it. And the decompressing and uploading, okay, it uploaded, so we should see a new resource group. If
now
we
Terraform is
this,
starting.
Yeah. Yes. So if you go to the resource groups, we should see a new North Europe resource group.
It takes a little bit because the web UI is always, even if the resources are created on Azure, the web UI takes a little bit to show them.
Okay, let's see what's on the console. So on the console, it's telling me that basically Terraform has started. It downloaded the Azure provider, and it's initializing the modules that are in the Terraform code manifest. So there is a Bootstrap, there is a DNS, there is a master, there is VNet. These are all resources. The Bootstrap is an OpenShift resource, but the rest is basically Azure resources that Terraform will use to provision basically the OKD. And that's why that's what happened here. So when I said the Joseph code got missing here, because the Terraform provider was changed here, and it required certain changes on the code, and by mistake, I guess, it got dropped. So there was an upgrade to the Azure provider.
That's why a lot of
beta 5.
Lots of people have had reported problems with error messages from the installer telling them that some page blob or block blob problem occurred. Yes, and we fixed that. It was only a small change that was necessary, and it was merged today. And I think in the next release of OKD, it will be in. Next release will come out the week after next week.
Okay.
So you will have Azure support in an official way. Don't have to.
As you see, so one type of storage containers in Azure is beige or block. Block are aligned to 512, and that was the error message. The other issue that was dropped was the source URI. So the source is a cached image, is not a URL. So this was the other change. So it's very easy to participate on the fixing things, especially if you have Joseph backing you up as a mentor. It's really amazing. Yes. So that's the issue.
I have a strong feeling, Walid, that the decompression has ended and that we should see a resource group.
Yes, so we are seeing resources creating. We see VNets. We see Azure Private DNS. So it's recreating the subdomain. Let's go to the portal and see where I am in the portal. Okay, so let's refresh. Okay, we see new
Joseph.
Joseph here. So if I refresh here also, because it's also, I mean, the user interface of Azure, you need to refresh several times. I think it will create like 22 records at the end. Now, what do we have? We have a load balancer, which is expensive. And we have basically the public IP address and the virtual network. We don't have the VMs yet.
The first thing that is crucial is maybe you can show the storage account. It should already be created. It's still
it is creating it. It's creating it. Let's see it. Let's go and see it. So I love basically the Cloud Shell on Google and Azure. It's really nice. It's very, very convenient. If I go to the storage accounts.
Yes. Okay. This way also works. Yes.
Okay. And I refresh. I should see North Europe. Yes, here is Joseph, North Europe. And if I look,
the first entry. It's the first entry. You can take that.
Okay, so the first in. Yes. I did storage account, so why did okay? There was a
you press the resource group.
Interface. Okay, so this is the storage account for the resource group that created recently. Okay, and I have different types of files. We are in containers, and basically there's one for the Bootstrap Ignition file. Okay, it's up and it's uploaded, and the other one is the VHD. So this is the initial phase of of the Azure installer. If you have these two, you are in good shape. And you saw it's 8 GB. That's why you have to be careful when you are installing several releases, because you could run out of space. Okay, let's go to the resource group again.
It was creating an image, so the VMs should also be created soon. Maybe we have one if you scroll down.
Yes, sort by type. I have virtual networks. They should be up.
Takes a few seconds.
Let's refresh. This is the takeaway for Azure. Refresh.
The nice thing about the Azure API installer is that you have to take care about nothing. You have to prepare the service principal one times, as it's it's documented very good. It's very you can have a service principal in a few minutes, and then you only call the installer, create cluster, Azure, enter your credentials, and here you are.
Oh, the service principal is a bit confusing because now if I want to check, do I have the right service principal? I go to the, it's not really service principal. If you search for service principal, most likely you'll not find it.
It's in the...
You go to the application registration, and then you say view all applications, this directory. And that's the service principal I created. And actually it created others. It created something for Ingress, yes.
And I think that's the reason why the initial service principal has so high permissions, that it can create other service principals on its own.
Yes. So I guess this information is safe because the password, there is a password related to the service principals, and there is permissions. And this is what you need to check. You need to check that you have the directory graph. And I'm not sure if this is because it worked for me before, but the last installation, we saw that somehow it's not granted for me, but it will tell you here. There will be a warning, and then you just follow what the warning tells you.
In my company, only a special group of people is allowed to grant. So I personally cannot grant service principals on my own. And that's why this is a two-phase procedure.
So in VMware, there is something called VMUG Advantage, where you can have 1-year evaluation license for almost all products of VMware. In Microsoft, there is the the developer basically subscriptions, which will give you like $150 per month access to Azure. And it will give you, actually, in the beginning, if you don't have an Azure account, it will give you 200 free account. And later on, you get like a quota, $150 per month. And you cannot use this in production. This is basically development test work. But it's good enough. It's really excellent. So this is what we call a developer subscription or something like that. It's still creating the blob images for the machines. Okay. Now, if we look somewhere, we can actually, let's see. Let's see if it created the virtual machines or not. Yes.
No,
so we have.
Really?
This is OKD. This is not the current installation. Sorry, we don't have.
Just uploaded it and creating
Yes.
a VMs. I was surprised. Yeah, it's always confusing if you have lots of resource groups in Azure
Yes.
to mix things up.
Yes. Now, if you ask me, do you want automated install or do you want it user provisioned install? It depends. If you are in a company that is heavily regulated and you cannot change the host names, the current automated install will, for a reason, it will create a hash. So you cannot know the names in advance unless you change your process. So do you want to be on control or do you want the installer to be in control? That's the questions. So if you can answer this question, then you can decide if you want it automated or user provision. So user provision has advantages and automated has advantages. It's not like I should always go with automated. Everyone has an advantage. Okay, if you want more slides. The other thing that I like about OpenShift, the concept of operators. OKD or OpenShift basically are operator. So if it's OpenShift, you can call it operator container platform. If it's OKD, you can call it operator Kubernetes. I don't know what. So what are operators? Think of them as that you have Joseph and you have Christian Hernandez and Chris Short and Diane and everybody from Red Hat in one room. And anything you can ask about OpenShift or OKD, they will answer it for you. So basically, you are putting the whole experience of all of the operations or the developers in one package. That's what it is. It's basically application lifecycle management, capitalizing on all the knowledge that human operators have. So they are just regular bots, and there is a controller. So it's a controller and a custom resource. And there is and everything you configure using the custom resource definition. So basically, even how to manage your Kubernetes environment becomes much easier. Yes. So this is how an operator look like. This is custom resource definition. This is just a hypothetical example. If I have something called cars, this is how I will define it. And it becomes a first-class citizen in Kubernetes. So what kind of first-class citizens we have? Go ahead, Joseph.
Oh, maybe you remember that in OKD3 we had also API extensions, but
Yes.
I don't think that they did it with operators. I think they were extending the API server itself, but with custom resources, you actually can extend the API of Kubernetes with own resources. And this is a mechanism that's not proprietary for, you know what I mean, for OpenShift or OKD, but it's a plain Kubernetes. And if you write the operators with there is an operator SDK, we also use it in my company. It's very easy to write operators on your own. If you have written operators with that, you will, and this is source code, you will immediately see how they work, because there is always, maybe you can show one.
Actually, Chris Short did like a 2 hours workshop on how to write operators using Ansible. Now,
nice.
an idealistic person on on. I mean, he will say, "Oh no, this is the wrong use of Ansible is not a programming language or whatever." But for somebody like me from operations, it's the easiest way to get operators run up and running on OpenShift or OKD.
Use Helm, Go.
There's also a bunch of great operator talks by Michael Rivnek as well that you can find. And there's an amazing group of people in the Ansible world doing work with operators. So yeah, tons of stuff. I just want to give you a heads up at the top of the hour, we are going to cut off the live stream. So if you want to, and then we'll continue with the OpenStack stuff. And you can take more time if we need to, but just let you know.
We are flexible. We will maybe we should have a look on the VMs. Valid? So we don't.
Yes, they are creating. I have the masters creating.
Nice. Okay, so the Bootstrap. Okay, the image is uploaded. The VM start. Nice. Okay.
Yes. And as Diane said, there's lots of resources for operators. One of them is actually learn.openshift.com. It's very easy. You don't need to provision your cluster. You can use one cluster for 1 hour. And there's lots of small tasks that you can do within 1 hour. One main task is the operator framework. So you can understand the ABI, you can understand what's the etcd operator, you can use it as for the application, it's not for the infrastructure, and you can use the operator SDK, the one that Joseph was mentioning, and the Ansible Kubernetes, which basically Chris Shaw did a long workshop covering it. And there's an Ansible refresher even if you want to do the Ansible Kubernetes module.
I think with Operator SDK, you get a CLI where you provide very few parameters, and it will create an operator stub for you. You can immediately compile it and do a few things, and you have only to fill, I think, 2 files: the controller and the API files, where you can specify own fields for your new Kubernetes resources. And it's lots of fun to write operators, especially if you, for example, if you want to create a database like a MongoDB, there are operators that take care about that. Or if you want to create VMs, you can use operators that create VMs on Azure. We wrote an operator, my colleague wrote one, that creates an VMs on Azure with the help of operators in Kubernetes.
Yes. So this cluster is running in Azure. This was created early this morning. And if you look at the selection you have AI machine learning. In AI machine learning, you have the Open Data Hub operator. It's a community operator. So basically, you don't need to subscribe. And it's very easy to install. You just click on install. Hopefully, it will work. This is a live demo. So basically, status unknown. It will try to get the images. And so that's how easy you install a machine learning, deep learning environment. It's basically clicks. Succeeded. How long did it take? Less than a minute. And now I have a complete machine learning environment using operators. So operators really, what does it have? It has Jupyter Hub, which is the main interface for data scientists, data engineers to write machine learning models. Apache Spark for data management, Prometheus for monitoring, and Grafana, Airflow for workflows. So if you are not using, and there is Selden also for workflows, Argo for basically GitOps, and Kafka for streaming. So basically, I installed all of these without any knowledge in any one of these in less than a few seconds. That's how easy it is. Now, you say, okay, you installed it, but you still need to configure it. Yeah, no problem. You go here to Open Data Hub, and then you create an instance, and you configure it. Okay, and there is, if you go back to the OpenShift Commons videos, there are several videos related to how to install Open Data Hub, and from DevNation also there is some stuff related to this.
Because I saw
That's why I love operators.
Because I saw the Hub was using provides a GPU support. I installed the NVIDIA GPU operator a few weeks ago also on OKD. It works absolutely smooth, and yeah, it's a lots of fun, and you can play with your creativity to invent new things because you don't have to care much about how things are installed. You can use operators, and it makes life more easier for you.
Yes. So it's still creating.
Yes, Azure is a little bit slow today, because maybe the other guys from the Kubecon are also creating things.
Yeah, can we send them a message in Slack?
Yeah. Please stop your live demonstration.
Stop for 5 minutes.
Yeah, but it works.
I guess they are partying virtually now. I mean, everybody is in his own way.
But if you see that things will magically goes away, and in the end you have your UI, you can log in and have fun. But what's also nice with Azure is that you can immediately use the autoscaler. I tried it on my own. It's very easy to do that on Azure, and I think it's a very important feature to save money, that you enable the autoscaler. It's on I think Compute.
Thank you for reminding me. Okay, because I have a problem. Because the one problem I have is basically I didn't configure the storage and the OpenShift samples, which are commercial subscription to Red Hat.
All right,
I don't think they are commercial, but they are basically you need to use the good secret from Red Hat.
Go ahead.
Okay, but if I go to the administration cluster setting, I can see there is an update ready for me. So this is the second cluster that I installed. Now, how to update? And just press this button, update to another version, and then you can select. Okay, do you want to go? Yes, I want to go.
Oh, share screen, duh.
So now while we are installing one cluster, we are updating another cluster.
It's that dude,
and
trust me.
That's how
I've been up since 5 with Kubecon
your
stuff.
workload is still running.
I've been up since 4 with kids.
The upgrade,
it's
a rolling upgrade.
All right, so how's that looking?
Yes.
Install
Can you see
all the operators.
Yeah, looks good.
You can see this
and
in
the console behind it looks fine
menu
too.
here.
So, yeah.
You will see that after a few seconds, the versions of the operators change, and in the end, always the last steps is always that all the nodes get restarted. And this is a rolling upgrade. It's always one master and one worker that gets rebooted, and your workload, if it's cloud native, will run and will be not interrupted by the upgrade procedure. That's very nice.
Okay, good. Earlier there was in maintenance status updated. Now it's gone. I haven't seen it before, so I guess it means that when the node was upgraded or something, when the node was rebooted. Anyway, the upgrade will not continue because it thinks that it's not safe. So the cluster version sometimes will have this. Sometimes it will say will not be enabled, but then. And I guess because I have one operator upgraded, if I get rid of this one, most likely this will be very smooth. But even with this one degraded, most likely it will work.
Yeah, well, if you put that operator into a remove state, that will fix it.
Okay.
That's something.
Okay, I go. But this is a cluster operator. How can I do it remote? How can I do it?
I'll post it in the chat.
Oh, you posted. Okay. I see 1051, Joseph. Where is it? This. No, I don't see it.
It's coming.
You can see my screen, so you can tell me if it's.
Yeah, I'm going to drop it in the chat.
Okay.
Rolling through my.
What are you looking for the pull secret, or?
No, it's basically how to disable the samples operator. I think it's handy to disable it. We should disable it by default unless somebody wants it, no?
But is it possible to upgrade if you remove it?
Yeah.
Okay, thanks.
Yeah, if you
really
go into a removed state, that should do it for you.
Okay, nice.
Okay, let's try. I go to the console. I go to the Cloud Shell. I open a new shell.
Creation complete. So okay, now they are getting in completed state.
So hopefully, okay, I'm working on live, correct? So I need to work on this one now.
But you have to use a different kubeconfig. You know that.
Yes, yes, yes.
Should we really do that, or should we have a look for vSphere? Because
just make sure that I am on the right cluster. Okay, I am on the right cluster. I apply the update. So it's a batching job for the operator. That's what I like about operators. You just configure the operator, and it's very simple. So this is like, we didn't really agree on this. We didn't do any demos. We didn't do any dry runs. We were busy doing the pull request. So that's easy. Let's see now in the console. And then we'll go to the vSphere. Okay, good. Yes, that looks much better. Thank you.
It removed.
Okay, now let's see if the upgrade. So basically, we'll wait a little bit, and we will see if the upgrade will go on. Okay, let's go to the vSphere. Waiting up. Still, there is something wrong with the bootstrapping.
I think it's taking too long. Could you see if we have an OC? If you have a certificate signing request?
Ah, yes, yes. So in user provision, you need to sign the workload domains. This is all approved. This is basically the masters and stuff. So we don't have.
The OBS, the network was not set up. I think, yeah, something is. We had this tagging problem in the start. Maybe this was the reason.
Okay, the tagging was for the storage or for the network? I think.
I think for the VMs. Because normally it does not stop at this point. So we had bad luck. But the Azure VMs are starting now. It means we should we could.
So basically, the API is up. Yes.
Yes, great.
And now the bootstrap.
Yeah, and I think
we can log into the. You want to?
I want to say that it is really nice that on every platform the installation process is almost the same. It's even possible to use platforms that are not officially supported. Like I installed OKD4 on Proxmox by selecting platform none, and I provided the ignition files to each VM manually, and yeah, the cluster came up, and the procedure is always the same. If you have the freedom to choose how you want the things to set up with UPI. I like that very much. You have full control about your installation. And the opposite installation procedure is to use IPI, where you have less control about what happens, but yeah, you have to not take care about it. It's easier.
Yes. So bootstrapping in Azure is done. So that's good. We can so we can kill the bootstrap, but we don't need to. Why? Because basically it's automated installed.
I think they kill it. The installer will kill it normally.
Yes. So now it's basically the masters are in control. Oops, what? We already have the cluster. So people don't look at this.
What?
The password.
Yeah, it's something with Joseph. I've seen it.
So I need to log into the. Okay.
Is it really already running?
Yes, it is already up. So it's the initial issues with the VMware installation, but this is the API. Why is it called API? Oh, no. This is the Kubernetes API. No, it should be. This is the old one. Yes, sorry. False alarm.
Is the VMware one up, or is this the?
The VMware, we have an issue with the tagging at the beginning. I think we should have resolved it before we continued. Actually, it is coming up. If you look at the, so let's see why it's not coming up.
Because yesterday we had a few problems with the environment. I have installed OKD on vSphere since January, this year, and it always worked. So
Yes.
it's a problem with our setup, I think.
Too many cooks in the kitchen.
Yeah, but normally it takes half an hour. We talked lots about the insights, and maybe we should have started with the installation just in the beginning and let it install for the hour. But you can believe us, it works either on vSphere and also on Azure. We have done it several times on this weekend.
All right, we'll let you sit there in the background and run it for proof of life.
Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another episode of Public Sector on Air here on OpenShift.tv. I am Chris Short. What is my job title these days? Principal Technical Marketing Manager at Red Hat. I am also a CNCF ambassador, and today is the day 0 of Kubecon, hence the t-shirt. Love your local Kubernetes meetup. Today, I'm joined by the one and only Jason Rittenauer from our public sector team. Jason, please introduce yourself to the audience.
All right, thank you, Chris. Yeah, as you said, I'm a cloud domain architect here in public sector. I specialize with emerging tech, in particular infrastructure and automation, and then automating infrastructure and infrastructurizing automation. So I touch all the virtualization stuff and some Ansible here and there, and basically figure out how to make it work for our customers.
That's awesome. Yeah, that's pretty much why we're here, right? Like we realize that our customers have a need that is very different nowadays with COVID. So we want to make sure that we are delivering them an experience that is accessible to them. So you're going to talk about some virtualization today, which is awesome because I love me some virtualization, but you're going to talk about doing it on OpenShift, which makes it even better.
That's right. And, I say that containers and virtualization, they're basically like peanut butter and jelly. They belong together. Mm-hmm. And, today I'm going to talk about how that relates specifically to public sector customers. I've had a lot of questions, especially since the most recent summit where we had a big presence with OpenShift virtualization. A lot of interest from the public sector space, particularly state and local and education. So I kind of want to address some of the questions I've heard frequently and talk through specific use cases for OpenShift virtualization in public sector spaces.
Let's do it. I mean, the public sector spaces have some significant, interesting needs, right? So there's the security side, the compliance side, the governance side. There's so much to it. So getting arms around it with OpenShift virtualization is going to be an interesting take here. So yes, please enlighten us.
So
I can definitely see your screen. Absolutely. Yeah.
You can't see my screen. Good. All right. So yeah, again, you see my name again, my title, my public sector. So let's go ahead and go forward here. As you mentioned, the big thing is we are looking at virtual machines and containers being managed in the same data plane, in the same control plane, and it's convergence now. Of course, virtual machines have been around for decades. They've been a big part of modern IT infrastructure for more than 10 years at this point. Containers have also been around forever, but we're in this renaissance now with the advent of the Docker project and the other offshoot projects from that, with Kubernetes making it easier to orchestrate them at scale. So what we're seeing is now we're looking at the next generation of containerization. And, you know, really in the early days of this renaissance, as I referred to it, a lot of people, and us included, were trying to manage containers like a subset of virtualization. We were treating the containers like smaller footprints, short-lived virtual machines. And we found out early on that didn't quite work. Containers have a lot of nuances that aren't really the same in like a virtual environment. So, you know, we kind of went back to the drawing board early on and looked at the way we were managing and orchestrating containers. And a lot of what we learned, you know, of course, fed into the Kubernetes project, and other people are reusing it today. That's the great thing about open source. Everybody benefits when we all contribute. But what we realized in back about 2016, we thought, you know, maybe instead of trying to manage containers like small virtual machines, why don't we try to manage virtual machines like long-lived, high-profile containers? So that's where the KubeVirt project began. We started looking at ways we could get virtual machines running in Kubernetes in a native way that complied with the Kubernetes API, that made it easy to fit into like CI/CD pipelines and modern DevOps architecture. But at the end of the day, it's really about running applications, right? So, you know, a lot of our customers are looking to go to more of a container native / cloud native architecture where their applications are ready to be containerized and they are microservice friendly and they can scale up easily. But then we have a lot of customers that have legacy applications and other things that rely on virtual machines, but they still want them to come into OpenShift. They want to be able to benefit from the easy way to get those applications deployed in various providers. They're not tied to like a specific architecture or infrastructure, and where they can get traffic into them easily. So, you know, one of the nice things about OpenShift virtualization is we can containerize applications at a pace that works for all of us. I had an image here that's not showing up for some reason. And that makes me mad because it was going to be, have you ever seen that?
Is it a GIF or something? Is it like animated or?
It's not animated, but it's still not showing up. What it was going to be, so you know that Futurama episode where it's the global warming and they talk about how they throw an ice cube into the ocean to solve the problem of global warming once and for all.
Right.
So what we can do is we can bring virtual machines into OpenShift to solve the problem of containerization once and for all, right?
Right.
But the thing is with that is, so yeah, you might have things that are virtual machines today, and they are legacy, and they are monolithic applications, and they can't be broken down into containers easily without a lot of rework. But maybe you want them to run in OpenShift for some reason. So what we can do is we can take them today, bring them into OpenShift as full virtual machines without changing anything to the underlying architecture of that application. And then you can just get them running in OpenShift, and then you can rework them at your own pace. And, you know, some things are going to be an easier lift to make microservice friendly. And some things might take months, years, never. Regardless of what your pace is, we can do it with OpenShift virtualization. And, you know, maybe you have applications that rely on like vendor virtual appliances and that sort of thing, or maybe some Windows-based apps that depend on like a full-blown older version of SQL or maybe like a Microsoft file server of some type. That can also be containerized as well. So you can have an entire architecture that's maybe a hybrid application where it's part containers, part virtual machines. Regardless of what it is, it can easily come into OpenShift through our import process. Oh, there we go.
There we go.
There's the GIF. So
okay.
I kind of spoiled it, but yeah, we're going to solve this problem of getting applications from a legacy architecture into OpenShift once and for all. So here's what's going on under the hood. You know, you might say, well, you already have Red Hat virtualization, you have OpenStack. Why do you want to reinvent the wheel and do it another way? The thing is, OpenShift virtualization relies on that same underlying hypervisor layer that OpenStack and Red Hat virtualization both utilize. It's all libvirt, it's KVM, it's QEMU, except it's containerized. So this makes it easy to kind of port workloads from one of those platforms into OpenShift virtualization. And it's all the same underlying mechanisms underneath. So if you have an ATO today for Red Hat virtualization or OpenStack, it's probably not going to be that big of a lift to get one for OpenShift virtualization. It's all the same processes underneath. And what we're doing here is basically we're launching a libvirt daemon in a container through this virt handler process. So it makes it really easy to deploy your virtual machines on OpenShift using the same architecture we're using in our other products. Of course, it all wraps into the Kubernetes API, so we can utilize it through the OC command or kubectl. There's also a separate offshoot called virtctl to do some of the virtual machine specific functions like get access to consoles and that kind of thing.
Right. Yeah. Yeah. I mean, I wish this technology existed, 3 years ago when I was working for a financial services marketing company, and we were moving a 10-year-old .NET app.
Oh, God.
And modernizing it and doing all this stuff. And man, I mean, we wanted to use containers. We had to use virtual machines. We had, Windows like 2008 servers that we just could not like break for a while. And it was like, we know we're going to break this at some point. We just don't know when, and we need to move these things now. And if we could have just lifted and shifted them into a platform like OpenShift, boy, that would have saved us a ton of headache.
Yeah, it's funny you should mention that. One of my few non-public sector engagements over my time at Red Hat was back in the early OpenShift 3.x days. It might have been 3.1 or 3.2. Nice. It was a customer in telco. I don't know if I can name them, and I probably don't want to because I might shame them by doing so.
No. Please don't.
But they also had a legacy application. It was WebSphere. And it had been basically, I don't want to say abandoned, but all the people who originally created it were long gone from the company. So nobody knew how it actually worked. Yeah. The only way we were able to figure out anything was by actually looking at like patent applications about this app. So
wow.
We managed to get that thing ported over on OpenShift in a container, but it was like a 20 gig or so image because we had to bring so much along with it because we didn't know how to break it up.
Yeah.
So, again, if we would have had this tech back then, it would have made that a lot easier.
Yeah. And it's, you pointed out the exact right thing, right? Like your ATO, no, don't have to worry about that. It's single pane of glass. It's the same platform. It's the same system. You don't have to change anything. You just update to the latest version and you have this capability. Actually, in 4.5, you have this capability, not just latest version, just to be specific. But yeah, like this is there, ready to go.
Yes, it is. And since it's all operator based, and I know we've done a few sessions on operators here on OpenShift TV, it's easy to deploy. It manages the life cycle, and it's really easy to get started. Awesome. Now, I did mention Red Hat virtualization. We're gonna see kind of a convergence, I think, between Red Hat virtualization and OpenShift and Red Hat virtualization is, of course, a legacy virtualization architecture. I don't want to say
we're supporting it till 2026. It's not like it's going away tomorrow. So let's just be clear about that. Yeah.
Exactly. But I mean, we know that we believe, again, at Red Hat, the future is containers. We believe that the future of virtualization is container native virtualization, or OpenShift virtualization, as we're calling it now. So why not have a path to go forward and to evolve Red Hat virtualization? It's not it's got a future. It's just going to evolve into container native virtualization. So today, with the most recent release of Red Hat virtualization, you can actually reach out to an OpenShift virtualization cluster as an external provider and manage the virtual machines running on that OpenShift virtualization cluster today. You can do your basic start-stop functions. You can get console access. You can do some other like day two operations on them through your existing Red Hat tooling today, Red Hat virtualization tooling. It also cuts the other way because we can actually import virtual machines from Red Hat virtualization and VMware today through OpenShift virtualization. So if you have a legacy virtualization infrastructure, we have got tooling for you to get those virtual machines out of that that legacy architecture and into OpenShift virtualization and make them container native. Now, today we can only do a single virtual machine at a time, but we do have tooling coming later this year that will allow you to do bulk migrations of massive virtual machine workloads through a procedural system.
Yeah, I mean, this is just the evolution of container native virtualization, essentially, right? Like tooling, the foundation has been laid, and now the tooling is coming in on top to make migrations and lift and shift a little bit easier.
Right, and you made a good point. This is the foundation. This is the first generally available release. I guess I can actually say today that it was made available at the GA announcement was made at Kubecon today.
Yes.
So, it's out there. OpenShift virtualization is there for existing OpenShift customers. You can, again, deploy it through the operator marketplace. And, the current version of virtualization is 2.4. So that is our first generally available release. It is supported. So, if you're using it today, if you file a support case, you'll get your normal SLA with your various levels of support.
Also, congratulations on beating my cohort, Andrew Sullivan, on the channel after the GA of OpenShift virtualization. Good job. Nice work.
Yeah, that was what I was excited to see that I was going to be presenting today. I'm like, all right, it's GA day. Woohoo. I get to be the first one to kind of honk that horn. So yeah, good stuff.
Awesome.
So, our government agencies, public sector, we kind of tend to maybe get sometimes treated with the same broad brush. And there are so many different agency types in public sector. And they've all got different needs and different wants and desires. And, like, for example, security to a DoD customer is different than security to like a civilian agency.
Oh, yeah.
So regardless of what specific subset of public sector they are, they're all trying to modernize applications just the same as everybody in commercial is. So we're working with them to help them bring these modern applications. These two examples I got here on the slide are examples of partners working with public sector, but like the military has been in through the Defense Innovation Unit, working with us in the OpenShift Innovation Labs to get their applications containerized and cloud native and cloud friendly. Lockheed Martin is another good partner for us. So what we want to do in the public sector space is we want to help these customers find ways to get their applications into production in the fastest possible way using our technology. So this brings up some of the concerns I've seen from public sector customers, some of the frequently asked questions I have.
Yep.
And I'm going to hit these through a combination of presentation, back and forth Q&A with you, Chris, demo, who knows, maybe even some interpretive dance if we get to that.
Yeah, we might have to.
But yeah, so let's hit on some of these concerns I've heard from the public sector space. So, as I said, we did go GA today, the official announcement at least. It's actually been released a couple weeks back, but it's officially OpenShift virtualization is here today, ready for your workloads. And I've heard some customers say, well, this is new emerging tech. Is this really production ready? Can I actually run production workloads on this today? And I'm here to say, yes, you can. Now, again, it is emerging tech. So some of the features you have gotten used to from like Red Hat virtualization or VMware aren't in the product as of yet today. But you can spin up virtual machines. You can migrate them back and forth. You can access storage, networking, all that good stuff. And we have a very aggressive roadmap with OpenShift virtualization. It's going to release at a 3-month cadence, the same as OpenShift is. So just looking at the stuff I see on the roadmap today, I'm very excited. It's going to rapidly mature, and it's going to be a matter of time before not only does it catch up with where Red Hat virtualization is today, but it's going to eclipse it and go forward because it is container native, because it's Kubernetes native. It's going to open up new possibilities that just don't exist with the legacy virtualization infrastructure today.
Yeah, there's a lot of opportunity with the container native platforms and Kubernetes native function, or not functions, but Kubernetes native way of doing things. When you start layering in VMs on top of that, it gets pretty cool.
Yep. And again, we've been working on this for a few years now. We actually started the KubeBurt project back in 2016. And we have a couple customers today that actually are running on production on upstream versions of the OpenShift virtualization stack, since we didn't have a GA until recently, but they've got production workloads and, they're having great success with it. So, I think in time, as the platform evolves, we'll be able to take more and more use cases and bring them into OpenShift virtualization to where it's really going to be a matter of time to where, most everything that's not a container is going to run on a OpenShift native application architecture.
It's a platform, right? Like we want you to put your workloads here. And we want you to be able to put your workloads anywhere at that point, right? Like that's the beauty of OpenShift.
Exactly. I mean, it's like you said, it's a platform. It's not just for developers. We're ready for the operations team to come in and bring their stuff into OpenShift and see the joy that is Kubernetes and how much simpler it can make your life.
Exactly. Can't wait. All right.
So
does it work in FIPS mode? Yeah, exactly.
Yes. That's another thing I've heard a lot. Of course, FIPS is important to our public sector customers for sure. And we do have the ability to enable FIPS-based cryptography, starting, I think, with OpenShift 4.3 was the first version that we supported that. That story is constantly evolving. I know it's coming soon to OpenShift container storage. So again, watch this space for more information about that. But, you know, I've actually had an SA ask me a couple weeks back, it's like, well, does OpenShift virtualization support FIPS? And I thought, you know, I haven't seen anything about that, so I want to try that myself. So the environment I am going to demo in today does have FIPS enabled. Nice. We do have, I have etcd encryption on the back end, all that kind of stuff, and it works fine. Now, the reason I have an asterisk here is because I did specifically put out an ask to the product team to say, do we support this? Because I like to say works and supported are two different things.
That's very true, right? Like, yes, OpenShift is FIPS compliant in a certain way. OpenShift virtualization is FIPS compliant in a certain way. But do we support working under that FIPS compliant in OpenShift virtualization? That is kind of a yes or no question at this point. We don't know yet.
So I'm waiting on feedback from a member of the product team.
I would imagine the answer is yes, but yeah.
I think it's going to be, but yeah, I want to see an official statement somewhere that yes, we support FIPS mode and OpenShift virtualization. Until I see that, I'm still going to put that asterisk, but you know, in me putting it through the pace, I haven't seen any problems. So good stuff so far. So if you're ready for FIPS, we're ready for you.
Question in chat is, can we run Windows VMs now? Yes.
Yes, we can. I'm going to get to that in a little bit as well, but OpenShift virtualization is actually past Microsoft's Windows Server Virtualization Validation Program. Try saying that 5 times fast. It is supported going back as far as Windows 2012 R2 is the oldest version of Windows we support.
Okay.
Again, older versions of that may work, but are not supported. So, right. But again, that's going to help a lot because I know that, you know, Windows containers are also tech preview now in OpenShift.
Yes.
And if you got something that supports like, you know, .NET, the most recent versions of .NET or the most recent versions of SQL, that'll probably containerize easy, but some of these older versions of SQL or .NET, probably not so much. So we can just bring those legacy Windows VMs in and present them through OpenShift as just another containerized .NET or SQL environment or what have you.
It can, so I haven't tested this on Windows VM. Does it do graceful shutdowns? And yeah, okay, so good.
Yeah.
Okay, and then
right, yeah. If you do stop virtual machine, it'll do an actual shutdown.
Proper shutdown. Okay, cool.
Correct.
And do we support cloning of Windows VMs right now? I don't think so.
I
but
believe
it's
so.
like it. I mean, it's like copy paste YAML basically still, right? Like so. I mean, it's
there is actually a clone mechanism, but I haven't tried it on Windows VM. I'd have to validate that. I would cautiously say yes.
As would I, right? Like I would assume yes, but I don't know for certain. So yeah,
right.
We'll check in on that one.
Yeah, I'll check on that and I'll follow up with you. But yeah, I would think the answer is yes. But again, I'll put yes with an asterisk.
There you go. Yeah,
that's gonna be my go-to if I can't say for sure.
Okay. Cool.
So the other thing public sector customers are always asking about.
This is why we have this show.
Disconnected install. You know, this is especially big in the DoD space. They want everything to be able to deploy without any active connection to the internet.
Manufacturing same way. Yeah, exactly.
Yeah. And I mean, I've had to do many POCs over the years with various Red Hat products where, you know, I go into a totally air-gapped environment. You know, it's the type of places where you have to like leave your cell phone in a locker and you have to go into a Faraday cage and you've got no connectivity to the outside world. You can get hit by a nuclear bomb and not know until you walk out at the end of the day.
Right.
But getting Red Hat bits into those environments can be a challenge. And you know, some operators are better than others about installing in a disconnected environment. So I will say OpenShift virtualization does support disconnected install. Again, I haven't tested a fully air-gapped environment because COVID, I haven't been going to those kind of places. But from what I've seen, based on how it's handling the image pulling process and getting it distributed to the disconnected environment, it looks like it shouldn't be an issue in an air-gapped environment. So again, that's there. That's
super
supported.
important for our folks out there that are in protected environments. We'll just call it. Yeah.
Definitely. So another big thing, of course, is network security. I've got to say, I think OpenShift network policies are probably some of the most fine-grained security controls I've seen out of the box for networking, at least in any Red Hat product. Of course, the older versions of OpenShift utilized, multi-tenancy, as it's called today, where basically everything in one project could only talk to things in its own project unless it was explicitly enabled to talk to another project. Today, the default is everything uses this network policy isolation mode where things can talk to each other from project to project, but you can easily set it so that, again, only things in the same project can talk to each other, only certain pods with the same label can talk to each other, only certain ports are allowed to be accessed from a particular pod or virtual machine. So this makes that east-west traffic control really easy. And we'll hit on some of this when we demo it later, but I think it's a pretty complete solution.
Yeah, keep in mind, folks, that it's like your container is now a pod. Like it's treated as a Kubernetes native asset. So you can apply all kinds of policy. You can go full OPA on it if you want, open policy agent with Rego and everything, right? Like you can go nuts with your policy and regulatory requirements here. I mean, and yes, you're absolutely right. Our east-west like granularity is insane. So yes, love it very much.
Mm-hmm. Now, another thing we have in OpenShift virtualization is we have the concept of routes for handling HTTP and HTTPS traffic. And we expose those to services, and then you can access that through a fully qualified domain name, which we refer to as a route. Mm-hmm. Now, if you're doing non-HTTP or HTTPS traffic, then you have to think about that a little bit differently. The preferred way to do it today, if you're using the pod native networking that we've just been discussing, would be to expose your virtual machine through what we call a node port. So what we're basically going to do is we're going to open up a port on that your node, your virtual machine is running on, and we're going to map that back to the port that's handling traffic on that virtual machine. In this example, you can see a node port that's going to talk to the remote desktop protocol on a Windows virtual machine. So you can get access to like the RDP, the console through RDP that way. You can use that to get like SSH access to a Linux virtual machine that way. There are, of course, other ways around this, other like modes of ingress, but this is just based on what's in the box today, what's the default OpenShift configuration, how you would go about accessing some of those non-HTTP and HTTPS services through container native virtualization. And then another thing we can do is we have the concept of multiple interface networking using Multis, where you can actually attach a virtual machine directly to your physical network. So again, this allows you to get traffic that isn't HTTP or HTTPS into your virtual machines. If you need to like Pixie boot a virtual machine for some reason and build off a Pixie server or whatnot, this is how you would go about doing that. Now, the caveat here is that OpenShift network policies don't apply to these like bridged interfaces. Mm-hmm. So to that end, you'd either have to run like a host-based firewall on the virtual machine itself, or handle security and traffic through rules on your external firewalls or whatnot. But yeah, it really opens up the possibilities what you can do as far as traffic handling within the virtual machine.
Oh yeah, Multis is a pretty nifty tool. And as far as just being able to bridge all the different networks that you could possibly want, right? Like Multis is it.
Definitely. Very cool technology. And again, this is a very much evolving story. We're going to see a lot of innovation happen with this. I can see.
I mean, just the CNI space is exploding already.
Oh,
so
definitely.
Yeah.
And another thing to point out as well, there's also a lot of other like partner and even Red Hat supplied stuff on the marketplace today that can extend the functionality of your networking and increase, do different things with security and that kind of thing. Like, of course, Red Hat Service Mesh is one possibility. There's New Vector, there's a Twistlock. So definitely, if you're using any of those technologies today, they can also integrate with the OpenShift virtualization. Again, like Chris said, it's all pod networking at the end of the day, at least with the default interface. So
yeah, it's Kubernetes native. You can do what you got to do with whatever Kubernetes tool you want.
Indeed. Now, as far as day two operations on the virtual machines, I'm very happy to say that Satellite and Ansible are still going to be the heroes here. I got a couple articles here with some Bitly URLs so you can get to them easier. But we do have a KubeBert satellite provider that allows you to provision virtual machines using satellite. That is still tech preview, I think. I'm not sure that it's considered GA now since OpenShift virtualization is GA, or if it's going to have to wait on another satellite major release to be considered GA, but it's out there and it works. There's also a plethora of KubeBert Ansible modules that, again, they've been around for a while. The one I'm linking to here is actually the KubeBert VM module, but there are plenty of others. There's one for disks, one for handling networking, that sort of thing. Ansible can also utilize OpenShift virtualization or KubeBert as an inventory source. So again, we can pull in your virtual machines and figure out how to access them using that. And then finally got an article here to link to using a jump host to get access to an environment that Ansible maybe can't talk to directly. We use that a lot in OpenStack or public cloud providers where they don't have, not everything has like a public interface or a public floating IP or whatnot.
Yep.
So this way we can use that as like a bastion host to get in and talk to virtual machines that aren't exposed on the public network. So lots of different ways to do your day two operations. This is going to be great for handling like security profiles on your virtual machines. Again, both satellite can do that through its OpenSCAP integration. Ansible can certainly apply a STIG profile. So whatever way you prefer to manage your virtual machines, it's really not going to be that drastically different with OpenShift virtualization. It's just a matter of maybe tweaking how you're accessing them directly a little bit.
Yeah, I mean, I use jump hosts for the Ansible all the time, right? Like it's totally normal operation for me now, I feel like.
Yeah, it's good stuff, and it's very flexible and versatile. So we'll actually do a little bit of Ansible demos. I've actually got Tower running in OpenShift, so that makes it a little easier. And that's another possibility too. You can Tower in OpenShift, so it's just using the native pod networking as well. But again, regardless of what way you choose to go about it, we can definitely manage it with Tower or satellite. No problem. So some of the other questions I hit about public sector customers, of course, OpenShift 4 runs on CoreOS, which is based on RHEL 8. And as you know, we dropped support for a lot of older hardware with RHEL 8. There's just some of the kernel modules aren't there.
I hit that bug this weekend.
I've got a whole bunch of sad Dell R610s down in my basement that
R820, yeah.
Exactly. And you can hack around it to get those kernel modules in it and working.
Yeah, totally you can, but
But again, not supported. So it makes it hard for customers that do want to just play with OpenShift virtualization and see how it runs in their environment, get a feeling for what managing virtual machines are like. So I'm going to present a couple of different things you can go about. And again, notice the first bullet point here, none of this is supported. This is just your friendly neighborhood cloud domain architect telling you, if you want to play with this and do non-production stuff, this is how you can go about it.
Here's to tinkers.
Exactly. So of course, it does depend on hardware virtualization. You can enable nested virtualization on Rev or vSphere or OpenStack. And that exposes the VMX bits and everything. And then you can actually, run nested on that environment. You're not going to see too big of a hit on performance that way because it's just passing through the CPU instructions directly to the underlying host. So that's one way of doing it. My first real exposure to OpenShift virtualization was running on a vSphere stack. So it's viable to do it that way for testing. But the thing is with that is that's not going to work for most of your public cloud providers because they don't expose the nested virtualization bits. So for that, you can enable software emulation, which that is, you're going to see a little bit of a performance hit that way. Confession, the environment I'm going to demo today is actually using software emulation because my storage in my home lab, unfortunately, had an issue. Yeah, I found out the hard way that the old adage of the time you're most likely to lose a disk is during a RAID rebuild. So I already had one rebuild going on and another disk drop. So yeah, I'm up the creek right now. But anyway, so again, this works. It's maybe not as performant as nested virtualization, but again, if you're just trying to see what it looks like, get a feeling for how you manage your virtual machines, how you access them, this works. And to this end, we do have support coming for running OpenShift on bare metal public cloud providers.
Yes.
That's one of the things today that kind of falls in the maybe sort of will work, but it's not supported. And the main reason for that is we with the public cloud bare metal providers, we run into things like how they do the networking, and it doesn't necessarily jive well with how OpenShift tries to lay down its software-defined network. So, but full official support is coming later. And
we're working with our partners on that right now. Absolutely,
yeah, definitely think that's going to be something that's going to be a game changer, because a lot of times we see our public sector customers, they're trying to shrink their data center footprints, and they're trying to do more stuff in the public cloud. So I definitely see that public cloud bare metal use case being something that is going to be, especially for the SLED guys, they're always interested in that.
Absolutely.
So with that, I'm done with my slides. So now it's time to see what we can break in a demo environment.
Oh, we're going to break some stuff.
You know it.
Love it. Yeah, I bought an old R820 to put in my house. It's the first real server I've ever owned. Yeah, I was spinning up a RAID 10 array on just the 4 disks that came with it, like 10,000 RPM disks, and I was like, wow.
Right.
I have to buy some SSDs for this thing.
Yeah, I know.
Because the IO is not too hot. Yeah.
No, but it's definitely not fun, but yeah, it's I like, on the one hand, I like having a data center in my basement. On the other hand, my wife doesn't like it, and it's my R610s are actually an upgrade from the 2950 I used to have, and man, that thing, it was right below our living room. So we'd be like watching TV at night, and all of a sudden I'd turn it on via IPMI, and you would just hear like the sound of jet engines underneath us, and she'd just kind of look at me and roll her eyes like, "Oh my God, are you doing work stuff now?" So at least my R610s aren't as loud, so I can be a little more stealthy about it. But yeah, I'm definitely
noise rating was definitely one of the things I checked when I bought this one.
Right. All right, so we are on an OpenShift environment in the public cloud.
4.5 for those out there. Yep. 4.5.5 to be clear. 4 VMs underneath the hood there. Yeah.
4 virtual machines running across a couple different namespaces. And you can see I got a healthy mix here. I got some Windows. I got a Windows virtual machine, a RHEL, a CentOS, and a Fedora.
Nice.
So we're gonna get in here and play with these in different ways in a little bit. While we're doing that, though, I want to go ahead and give me a second to. We're gonna spin up a virtual machine right now just to show what the process looks like. So thought I left that tab open in my browser, but I didn't.
Whoops.
Yeah, no.
No big.
Sometimes I'm so smart, I forget how smart I am, and I forget to do stuff. All right, so I'm going to do new from Wizard here. This allows me to basically go through a UI that I define everything, pretty much like you would with a legacy virtualization system.
Yep.
It's asking me for a source. Again, I can select Pixie, so I can do a full-blown Pixie install. I can point to a URL. I can pull like an image or an ISO in. I can do a container image. So we can actually take container images and mount them as disks. And then I can also do like an existing disk I've already got uploaded. So in this case, I'm going to do URL. I'm going to drop this in.
Nice.
So this is going to use the latest CoreOS cloud image. CoreOS, for those of you not aware who maybe haven't seen it in OpenStack, it's a really lightweight Linux-based virtual machine. And it's good for when you want something just spun up fast just to validate basic functionality. So since that's not listed, I'm just going to do a CentOS 6 or higher operating system profile. That's mostly just metadata about the virtual machine, so it's not really having much impact on functionality here.
Right.
You can see we can do either like t-shirt size type flavors, or we can specify the memory and CPU count manually. In this case, I am going to go ahead and select tiny though. Whoops, tiny, not small. And then your workload profile. The only one I've got here is server. There's also like desktop and high performance.
Right. And that's where the OS dropdown matters, right?
Right.
Yeah.
So default, I'm going to use the pod networking interface. So again, this is going to mean that everything is going to utilize the native OpenShift networking. You can see I can easily add an interface though.
Oh, yeah.
If I had different definitions, they would be right here.
If you got bonds, you can go all day with anything you want.
Right. You can do bridge, you can do SRIOV, you can specify the MAC address if you want. Again, there might be a few use cases that you want to have that kind of control over it. But yeah, it's really easy to add an interface through the wizard here. Next, we get to storage. Now, it's going to define a root disk by default here. And again, its source is going to be URL. So that means it's going to pull from that image from the URL I supplied. I'm going to go in and edit it though, and make a couple changes. So you can see I can change the size here. So default is 10 gigs. CoreOS doesn't need anything that big, so I'm just going to go and drop it down to 5. It could even be tinier, but we can also specify the interface. So do we want to use VirtIO, or excuse me, VirtIO, SATA, SCSI? And again, there might be a couple of use cases where, you know, for CD drives, you might want to use SATA rather than VirtIO.
Right.
You might have some like a legacy system that needs to utilize SCSI rather than VirtIO. So again, we can be flexible with that. I am going to go ahead and leave this on VirtIO though. Storage class allows us to take an existing defined storage type in OpenShift, and that is the backend storage. Now, in this case, I have AWS EFS. So this is going to utilize Amazon's Elastic File System to dynamically create a share for me on the back end. That's one of the nice things about running this in Amazon. I mean, you know, performance aside of software emulation,
Right.
I've got easy access to other types of storage. So again, I could do GP2. If you're running on-prem, we can do like OpenShift container storage. We can do NFS. We can do basically any type of storage OpenShift supports can be easily exposed to a virtual machine. And then going even further, if your provider supports something like full disk encryption for a block device, it's easy to do that as well using that that built-in provisioner.
Nice. Did you happen to do that with the service operator? To create the EFS thing, or did you do that on your own?
I did not. I did that manually.
Okay, that's fine.
I
was just curious.
Is there a service operator for that?
Yeah, there's a. I think it has 3 words in the name, but it's something service operator, right? And it's designed to work with those external services. I don't know if it would have spun it up for you too easily. I haven't kicked the tires on it with like EFS, but
interesting. I'll have to look into that for sure.
Yeah, maybe give it a look. It might help you save some time in the future at least.
Because man, oh man, do I hate creating PVC claims and PVs myself. It's so nice to have a storage class that does it for you.
Yeah.
So anyway, one thing I want to point out here, note I'm making this shared access, RWX. It's very important for if you're going to want to migrate the virtual machine from node to node, it has to have the backend needs to be read-write mini. Mostly because as we get in here that when you do a migrate, basically it has to spawn another kube launcher pod or virt launcher pod on the virtual machine that's going to, on the node it's going to migrate to, so you can hand off the storage to that other node. So it basically does have to be mounted both places at once for at least a brief few seconds. So we'll go ahead and click next here. You can supply a cloud init payload if you want. So I'm going to specify my host name. I can drop in a SSH key if I want. You can do a full-blown cloud init script here if you want. So
nice.
This shows you what it looks like. You can, again, if you're familiar with cloud init, you can pass along all sorts of things to like configure packages.
Run Ansible if you want. Yeah, all kinds of fun stuff. Exactly.
Exactly.
Yeah.
So virtual hardware, I could attach a CD-ROM if you wanted. One thing to point out here, when you're doing like Windows virtual machines, it's automatically going to pull the VirtWinIO container image and mount that as a CD. So you can do, so that way you'll be able to see like the storage drivers to access your disks, because by default, Windows doesn't have built-in support for VirtIO drivers.
Yeah.
So it's going to go my little review screen, ask me to confirm everything. This all looks good. So I'm going to go ahead and click Start Virtual Machine on Creation, Create VM. And now let's go look and see what's going on the back end. So I'm going to go over here to pods. Now, since I am supplying this as a URL, it's going to run this importer CoreOS root disk, and it had an issue. Scratch space required and none found. That's interesting. Well, it certainly didn't do that when I was testing this. But it looks like it's going to try to spawn it again. So what that scratch space basically is, that is a file system space that allows you to pull in the raw image or the ISO or whatever, and it uses that to then transform that into something that OpenShift virtualization can mount. And then it goes through and also validates that the image is kosher and ready to mount more or less. So what we would see here is we would see through, okay, there we go, this worked.
Okay,
so
cool.
Apparently it was just a slight race condition and it didn't didn't have that scratch space ready, but you can see it went through, it pulled the image in, it validated it, it converted it to raw, and then it mounted it on my Vert launcher pod, which is now running, and it terminated that importer pod. So that utilizes the containerized data importer is what that process is called, where it pulls in your image or ISO or what have you.
Mm-hmm.
So we now have a running virtual machine.
Just like that.
Just like that. And this is over on my CoreOS test VM. And again, you can see it's telling us all sorts of neat information about it. It's telling us what node it's running on. It's telling us its pod networking IP address. We'll kind of explore that in a little bit. It's telling us information about the virtual machine, about the network interfaces, the disks, what its current resource utilization looks like. And note here, again, like everything else that's Kubernetes native, everything is defined as YAML.
Right.
So I can
Exactly.
easily...
It's all YAML, all the way down.
I can go in, I can make manual edits to this YAML if I want. I can export this out and go do some edits and then spawn another virtual machine from it if I want one that's similar. So yeah, you can see like things like the CPU, memory, disks, all of this are defined as YAML. So, you know, again, this is something that's probably going to fit into like CI/CD pipelines and DevOps really naturally as we start exploring it more. But here's the big thing. You can see we have console access. Now this is using VNC by default. I can also switch over to like a serial console if I want for Linux VMs at least.
Right. And it does do RDP for Windows VMs.
It does. We'll hit that in a minute too.
Yeah.
But I think I typed that right. No, I did not. And you can see it got my host name that I supplied there. So yay for Cloud and Net.
Nice.
And I've now got a prompt here. So basic Linux instance, nothing too exciting, but so yeah, that's how you would create a basic virtual machine. And of course, it can do a lot more than just CoreOS. We can do several different versions of Windows, several different versions of Linux are supported. Red Hat Enterprise Linux, of course, being the way we want you to go, but we can also do Fedora, CentOS, even Ubuntu, 1804 long-term support. So we're opinionated, but we're not biased. So if you want to run a non-RHEL OS here, we're certainly okay with that.
Yeah. So
the next question is, you know, how do we get access to these virtual machines from the outside world? How do we SSH into a Linux VM? How do we SSH or get RDP access, like you said?
Mm-hmm.
So we'll go over here to another project I've got. Let's go to Vert Demo 2. I've got a couple existing virtual machines running. I got a Fedora 32 and a CentOS 7.
Nice.
And again, you can see it tells us what node it's running on and what its IP address is. Now, those are, of course, pod networking IP addresses, so they're not accessible from outside the OpenShift cluster.
Right.
So the challenge with that is I want to get access to that, and I want to be able to do it from my workstation on the regular Office network, right?
Mm-hmm. Yeah, I don't want to have to jump into the web interface every time I need to touch a VM.
So this is where, well, and honestly, you know, the console is VNC based. It works, but it's not something I'd want to manage virtual machines through all the time. It's good if you just want to do some basic troubleshooting, but yeah, I'd rather have SSH shell access myself. So you can see we can utilize services here. I've got a couple services defined for SSHing into both my CentOS and my Fedora VM. And what this is doing is this is creating a cluster IP address that I can then access, in this case, through a node port. So you might be saying, well, how does that work? I'm going to go here to my terminal window. And again, I'm doing this through Windows because I want everybody to see that you don't need to be a Linux whiz to know how to do this.
Right.
The OC binary, the virtc binary, they're available for Windows, Mac, what have you. So
yep,
I'm going to do
and
OC.
Go and can be cross-compiled. It's great. Good stuff.
So if I type OC get BMI, I'm going to go and do all namespaces too. So this will show me all my virtual machines running across all my projects within OpenShift. So you can see my Fedora 32 VM is running on this node right here. So I'm going to SSH in. SSH, not DDH. I don't know what that's going to do.
Well, you never know.
You never know. It might do something.
Just duplicate help? No? Okay. I would have no idea what that would do in Windows.
So let's see here. Actually, I got a little bit ahead of myself. Let me cancel out of that because I need to see the port. OC get service. And that's invert demo 2. Okay, so my Fedora SSH port is using 354. So let's see here, SSH as user Fedora to that node. You ever have one of those days where your fingers just don't want to do what you're telling them to do?
No, that's quite frequent for me.
It is not fun at all.
No.
When that happens.
Are you on a Mac keyboard or something?
I am.
Or some weird keyboard. Yeah.
That really throws it off. All right, so now port 30354.
You can do it. I believe in you.
I can do it. So again, I already had my public key copied to this virtual machine. So I was able to do that without supplying a password because I've got a public key on this host. So yeah, I'm logged into my Fedora virtual machine now. And basically it's the same as any other shell instance. You know, I can do ls. I can validate that my HTTP server is running.
Yeah.
And because I've got that HTTP service running, that is normal HTTP traffic. So I can hit that through a route that I've got exposed here. So there's my hello world.
Nice.
So, you know, just to show there's no funny business here, I'll validate that that is in fact the same one.
You could actually drop that link into like the Twitch chat if you wanted, or just send it to me, and it's actually public to everybody. You know?
I can do that.
Yeah.
But I can't do it if I'm not logged in as the root user. So.
Well, permissions matter.
Yeah, they do. Stupid secure by default.
Right.
Why can't everything just be chmod C70 774? All right, so now if I go in and refresh that, there you go. Hello, Chris.
Hey, look at that. That's
so yeah,
awesome.
I'll drop that into the chat so that if anybody else wants to see it.
Grab that up.
Oh, come on.
You can do it. Copy.
I think yeah, there we go.
All right. Question is, which chat are you dropping it in?
Chris Short privately.
Okay, that works.
You see it?
Nope.
Nope. All right, well, let me do this other one then. There's 2 Chris Shorts, and that's messing me up. How many of you people are there?
Just enough. Just enough of them. You could share it with everyone. It's just us here. But yeah. Copy. Paste. There you go.
So, you know, that's how we would go about getting traffic into a virtual machine from the outside world. Again, if you're running, you know, HTTP or HTTPS, it's not really any different than any other pod. It's when you're doing something like RDP or SSH, that requires a little bit more planning. So to that end, I'm going to go over to my Vert demo project. Oh, if I get out of my Fedora virtual machine first.
Minor detail.
Minor detail.
Yeah.
There we go. So now I'm using that. So OC get BMI. There's my Windows 2019 virtual machine I have running. I'm going to use that burtcuttle command I was talking about. Again, this is a binary that's available. I want to say it's on the kubert GitHub, if I'm remembering correctly, but within RHEL, we do have it exposed in a repository that you can download it from. But again, for Windows or Mac, you're not going to be using a repository, so you can just grab that from GitHub. So I'm going to do expose VMI Win 2019. Name is going to be Win 2019 RDP. For my port, I'm going to do the default RDP port, which is 3389.
Oh boy.
And then target port. I don't need to do the target port, but I do need to do
node port. Or
yeah, right type is node port. Okay, so
so yeah, I'm going to drop the blog post about the GA today in the chat for everybody.
Cool. So, what have I done around here? So, where's my node port? Node port.
I might have told you the wrong thing too.
No, you definitely. I've done this before.
I know you have.
It's just not.
Not your day.
It's
okay
not.
though. You know what?
It's not.
It's okay to not have a great day on this channel. It's totally fine.
Type equals node port. What the heck am I doing wrong here?
Order. Is the order right? Does the order matter?
Shouldn't matter. Port. All right. All else fails, up arrow to when it worked right?
There you go. Capitalized. That's I should have known that. God, I should have known that. Damn it.
There we go. OpenShift commands are case sensitive. Some of them are.
So that goes all the way down to the core Kubernetes, man. I should have known that. My bad.
And you know, I should have done it. I should have known too, but
yeah. Oh well.
Yeah, like you said, it's been a long day.
Yeah, I mean, I've been up since 5, so I've been going at it hardcore with Kubecon.
I know you got Kubecon. I just got kids to keep me up all night.
Yeah, well.
So
that
too
now,
sometimes. Yeah, I know that's always fun, isn't it? Yeah. So now I've got this Windows 2019 RDP port. So that's exposing RDP on that port. If I go back over to my virtual machine, so Windows 2019. So if I hit the console here, there is my Windows console, the lovely default lock screen. I'm going to hit my drop down here. And again, I've got that same serial console option, but I've also got desktop viewer, which now brings up a little lovely window to say, hey, do you want to launch the remote desktop client? This is another part of why I did this through Windows, because I wanted to save myself the pain of trying to access RDP through a non-Microsoft terminal services client.
Sure.
So you can see it's going to come up. It's going to ask me for the password to log in as administrator. I could change who I'm logging in as if I want. And you can see it's going to bring up that little, that friendly little dialog box saying, hey, this is a self-signed cert with this Windows host name. Are you sure you want to do this? And I can say, don't ask me. I can hit yes. I could go in and make some changes to that RDP file as well if I want. So just go ahead and hit configure here and we'll let it go through. It's actually going to take a little bit because it's going through a couple different layers of natting. But while we're waiting for that, let's see, what else did I want to show? Oh yeah, I wanted to hit Tower, Ansible Tower before we wrapped up. So you can see if I go over to my Tower project. Actually, I've already got it running in a tab here.
Oh, sweet.
See, I tell you, sometimes I do think ahead and I actually do keep certain tabs open. So this is Ansible Tower running in OpenShift, which is, it works, it's supported if that's the way you want to go. Again, if not, you can always do a jump host or whatever to get in.
Mm-hmm.
I do have a manually defined inventory that consists only of that Fedora virtual machine I was running.
Okay.
So you can see him right there. He's using the pod networking IP. And since Tower is running as a pod, it can talk to it on that without any special precautions. So I can actually run in here.
Mm-hmm.
And I can do a basic ad hoc command.
We're going to do this poor thing.
So we're just going to go ahead and do just a simple ping just to validate that it's up. I'm going to supply a credential to it. I've got my my private key baked in here, so I can just go ahead and run that. Hit launch. And it'll go through and it'll establish its connection. It's going to give me a warning about Python being not the right version for Fedora, basically, but that doesn't really amount to anything for what we're doing. It's just establishing the communication. Come on, Ansible, do your thing.
So it's tower running on OpenShift, going across the OpenShift network to the vert. Okay.
Right. And there we go. So we got our
Okay.
response back. So that works. So yeah, that's how you would do like day 2 operations. You can do, you can do your full job templates against it. So if I want to secure my SSH, I can just go ahead and run that. And you can see it's going to talk to that same demo inventory, utilizing the same credential.
Nice. I mean, this is OpenShift tower or OpenShift tower, Ansible tower that I know and love. Yeah.
Yep. So you can see it's gathering its facts now. We'll be able to access those if we want. So again, the facts are going to be something Ansible is going to gather just intel about the virtual machine and the environment that it's running in. So
yeah, and it's all on OpenShift.
It's all on OpenShift.
Or you could have your tower instance outside and do stuff with that and jump into OpenShift. However you wanted to mix this cocktail, you can.
Yep. So this is going to go through some of this stuff has probably already been done, like disabling password login. I'm going to set like an SSH banner,
nice.
A couple things like that.
Cool.
So yeah, disable password login was already done, so no changes there. Write the basic issue.net file and so on and so on. So with that, we're at the top of the hour here. I've hit just about everything I wanted to show other than the network policies, but take my word for it, that's awesome.
I mean, if I've got a few more minutes, if you want.
Well, if you got time, I'll go through it.
I can give you 15, right?
Okay.
Yeah.
Cool. So let's SSH back into my Fedora VM here. If we time it right, unfortunately, we didn't get to where that SSH banner was set.
There you go.
There, it's added now. I'm sorry, I just got to get out and do it again. I want to see my banner, make sure it worked.
I like you.
Let's log in. It didn't give it to me. Oh, because this is
it just did. Yeah.
All right, I'll let it go.
Yeah.
I will cat the Etsy MODT just to validate that it's there. Oh, it's writing it right now.
Oh, well, there you go. Well, where's the issue.net file? You can find that.
Let's look at that.
Yeah.
There we go. Authorized users via public key only. No plain text passwords.
Yeah.
So that's what my tower job was doing. You can see it says we're right here. So we know that worked at least. All right. So one thing to point out about the networking in OpenShift, the pod network IP address you see is not the actual address on the virtual machine itself. They all have this 10.0.2.2 address, right?
Mm-hmm.
Of course, since we're using software-defined networking, it doesn't matter what the actual IP address of the virtual machine is. The pod networking is translating everything back and forth between the different interfaces. So to things running in the podified environment, they're going to talk to it on that pod IP address we saw.
Right.
So again, I'm going to go back out here. I'm going to drop into that CoreOS virtual machine I created earlier. Let's go to virtualization. Oh, wait, that's right. I put it under default because I was stupid.
Oh, yeah, that's right.
I forgot to change.
You got to change projects. Yeah. No, do it all the time. It's fine.
Yeah. So I'm going to log into CoreOS or Ceros. I never know what to call it.
Yeah. Cloud thing.
Yeah. Right. So again, IPA, it's got the same address. Now, let me log back out here and we'll do OC get BMI, all namespaces again, just because I want to see all of their addresses. So you can see it's showing their namespace and what their IP address is, right?
Right.
So let's look at the Fedora. He's 10.128.4.38.
Okay.
So if I ping that guy, I'm getting a response.
Nice.
Again, to validate that there's no craziness going on here, I'm going to curl that guy on that same address And you'll see that same index
Yeah.
HTML we edited earlier, right?
Nice.
Good stuff. Now, what if I don't want that to happen though? What if I want to be able to,
yeah, I don't want stuff in my default project to be able to talk
Yeah, right.
to anything, right? Like,
right.
yeah.
Nobody wants that. So
No.
I'm going to do a deny all.
Oh snap.
So now, that's right. I need to apply this to the default namespace. Haha. OC project.
Oh,
That'll
yeah.
probably break stuff. I
That'll-
don't think I want to do that.
Yeah, yeah, be careful with that one.
But I do want to go to all right, so I'm on the Vert demo 2. And now let's go look at our network policies. What? Why did that not apply? Let me just cat that to make sure I didn't have any All right, well, let's do this the hard way. Okay. So, or easy way, maybe.
Easy way. Copy pasta.
Copy, paste, create network policy. Let's dump all this stuff out of here. Paste that in.
Okay.
Now,
Sure
we go back over to our virtual machines. Let's just do all projects so I can see them all at once.
Cool.
Let's go back to my CoreOS guy. And now let's see. And now I don't have any pings going in.
Nice.
I can't curl it. So that's what I'd expect.
All traffic is stopped. Good
now, maybe I do want to allow some traffic in there. Like, you know, that's a web server.
Right.
I want to be able to access the web on it, right? So this is just a matter of going in. We'll go ahead and dump this guy. And we'll create a new policy. So again, you can see this is going to allow, this is going to apply to all pods in this project. And again, I could get granular. I could do like tagging there, labeling based type access. But the main role here is it's going to allow traffic in on port 80 TCP, which of course is your typical web services port. Oh, there's our RDP window, by the way. Woohoo. So going back over here, now we're going back over to our virtual machine console in CoreOS rather. Come on, CoreOS. So now again, I can curl it.
Hey, look at that.
But I still can't ping it.
Nice.
So that's just a quick intro for how you can secure your workloads on container native virtualization when they're using that native pod networking. And again, it's insanely granular, the stuff you can do using network policies in OpenShift.
Yeah, no, you can get down to like, I want this label to only be able to transfer, you know, X amount of data per day kind of thing. I think if you really wanted to meter it out and everything else, you probably could string all that together. But goodness, I mean, you know, like, I think there's plenty of policy, you know, like examples out there for folks to use and copy, right? Like you don't have to do that on your own. Go look for some, right? Like there's plenty of valid stuff out there that's worthwhile and using, right? Like you can read YAML, just like everybody else can. So just validate that it's good for you and your workloads, and off you go.
Yep. And I'll say the docs actually have a good section on network policies, and then there's also some stuff up on the OpenShift consulting GitHub, the Red Hat consulting stuff, some of the things they've done for other customers. So
yeah,
lots of good examples to get started.
Cool. Awesome, Jason. Thank you very much for everything today.
Yeah. Well, I think that's all I wanted to show today. You know, I just want to point out I'm wearing my
containers are Linux shirt. And I've a little addendum to that. So are VMs now. So
nice.
I'll see if Paul can get me one officially printed up like that. Paul,
just
come here
like
if you're
that,
watching
like
that.
with the sideways Post-it note. That'd be great. I would love that. That would be amazing. Awesome. Yeah.
So thanks,
Peter,
Chris. I've
Peter
had fun
Lauerbach,
today.
if you're listening still, please, we need that.
Yep, I had a good time today. This was fun. Thanks for
Awesome,
having
Jason.
me. And yeah, public sector customers, if you're interested in OpenShift virtualization, talk to your reps, have them ask for me, and I hope you figure out if your workloads are a good fit.
Yeah, and definitely come back next week for oh, come on, calendar. It's just one of those days. How to build and scale applications with confidence using Microsoft Azure Red Hat OpenShift. That'll be cool, right?
Definitely.
Yeah, that'll be awesome. That's actually from, who is that with? I'm going to be joined by Phil Cramp.
Oh yeah, he's a good person.
Peter Cramp. Sorry. Yeah. Your demo was awesome today, though. Thank you so much, Jason. Really appreciate your time. OpenShift virtualization is GA today. That blog post again. If you missed it, I will drop it again. And when in doubt, check the live streaming calendar, which I just dropped a link to again. And you too can join us and subscribe and follow us on Twitch, Facebook, or YouTube, wherever you think is best for you to catch our live videos. And we'll see you again out there in the streaming universe very soon. Bye, everybody.
Bye.